India is a country rich in water resources. But its rivers and groundwater resources are under great threat. Rapid economic development, intensive water use in agriculture, continuous growing population.
Fantabulous sessions that's coming your way. So ladies and gentlemen, please make sure that you put your mobile phones on silent. We'll be starting in a bit.
India is a country rich in water resources. But its rivers and groundwater resources are under great threat. Rapid economic development, intensive water use in agriculture, continuous growing population, and increasing urbanization are pushing the water demand, which is creating...
Interesting. So ladies and gentlemen, once again, a very, very warm welcome to each and every one present here. Thank you so much for joining and making our day two a grand success. Even before it starts, I am so excited and I'm 100% sure even you are looking forward for all the sessions. Ladies and gentlemen, we are all set to start. I request all the delegates who are standing outside to please join us inside the hall. We'll be starting off in next few minutes. I request everybody to please make sure that you take the front seats because we have very interesting sessions that's coming your way. Thank you so much, ladies and gentlemen. Ladies and gentlemen, please make sure that you keep your mobile phone on silent or vibration mode. We'll be starting off in next few minutes. I request all our esteemed delegates who are standing outside to please join us inside the hall. Very good morning, ladies and gentlemen. Namaste from Nama Bengaluru. Welcome to International Conference on Dam Safety 2026, Day 2. So, ladies and gentlemen, today we are right here kickstarting our technical session where the session says it's about aging dams, state-of-art rehabilitation practices. So, to head the technical session, we have our chair, Dr. J. Chandrasekhar Iyer, sir. With a huge round of applause, I request everybody, let's welcome Dr. J. Chandrasekhar Iyer, sir, who's a distinguished water resources and hydropower professional with around 40 years of meritorious contributions to the sector. A 1984 batch officer of the prestige Central Water Engineering Service in the Government of India. He started his career in the Central Water Commission and rose up the ladder to head the APIC's national organization as its chairman in the year 2022. Dr. Ayers is an alumnus of IIT Madras and a NORAD fellow for the Norwegian University of Science and Technology. In his illustrious career spanning over 36 years in the government, he has held important senior positions such as Commissioner Flood Management, Chairman of Godavari and Krishna River Management Boards, CEO of Polavaram Project Authority and member Designs and Research, CWC, all under the Ministry of Jal Shakti. He was the first ever chairman of the National Dam Safety Authority after enactment of the landmark Dam Safety Act 2021. Sir's key areas of specialization include planning and design engineering of surface and underground components of hydropower, irrigation and water supply projects, dam safety management, interstate and transboundary water sharing matters, project construction coordination and implementation. He's an NDSA empaneled dam safety member, management expert. His overseas official engagements and learning span across over 10 countries. Post superannuation from government service, Sir has been serving several high-level committees in the government in an advisory capacity, besides advising other sectors. Sir continues to be active globally in the working groups of International Commission on Large Dams, ICOLD, and he has several publications to his credit and is a recipient of many awards and recognition. So ladies and gentlemen, I request everybody to please give a huge round of applause once again for Dr. J. Chandrasekhar Iyer, sir. Welcome, sir. Now, ladies and gentlemen, it's my privilege to introduce our co-chair, Dr. R. Chitra, who's the director at the Central Soil and Materials Research Station under the Department of Water Resources, River Development and Ganga Rejuvenation, Ministry of Jal Shakti in New Delhi. With 37 years of experience in geotechnical engineering, ma'am has led and guided over 460 projects across India and neighboring countries, including Nepal, Bhutan, Afghanistan, and Myanmar. As director of CSMRS, ma'am has led geotechnical investigations, foundation and soil rock assessment, dam safety reviews, quality monitoring of hydraulic structures, and contributes to national standard and guidelines. Ma'am's expertise spans planning and executing geotechnical investigations for river valley projects, and key interests include hydropower development, earth and rockfill dams, problematic soils, dam risk assessment, numerical modeling, ash containment systems, fly ash characterization, geosynthesis and water resources, artificial neural networks, and quality control of hydroelectric projects. Dr. Chitra ma'am has authored over 300 plus technical papers published in prominent international and national journals and conference proceedings. Ma'am serves on an expert committees for dam safety reviews, major dam projects and irrigation initiatives. Additionally, she chairs two Bureau of Indian Standards BIS committees, namely Foundation and Substructure and Hydraulic Structures Instrumentation, and contributes to various national committees like BIS, IRC, playing a significant role in developing, reviewing, and updating Indian standards. Welcome, ma'am. We're very, very happy to have you here. Can we have a huge round of applause? Now, ladies and gentlemen, it's time for me to introduce our esteemed speakers today for today's session. So firstly, I would like to invite Mr. Thomas, who's a senior dam specialist at the World Bank, providing support for bank finance projects relating to dams mainly in Europe, Central Asia, South Asia region. Prior to joining the bank, he worked in the private sector, specializing in dam engineering, working on new dams and hydropower schemes, rehabilitation of existing schemes, emergency preparedness planning, disaster risk reduction projects. And sir is a chartered civil engineer and member of Institution of Civil Engineers. Welcome, sir. Can we have a huge round of applause for Mr. Thomas? Next, ladies and gentlemen, we have engineer British, sir, if I'm spelling your name wrong, please do forgive me, is a Zambian civil engineer and project manager with over 15 years of professional expertise in large-scale infrastructure development, water and dam engineering, and road rehabilitation projects. Sir currently serves as design engineer and project manager at the Zambezi River Authority, where he plays a key role in over USD 290 million Kariba Dam rehabilitation project, including the plunge pool reshaping and spillway refurbishment works financed by European Union and the World Bank, among other partners. Sir has an extensive expertise working on internationally financed projects, including the World Bank funded road infrastructure programs and European Development Fund supported dam rehabilitation works. Welcome, sir. We're very happy to have you. Please welcome, sir, with a huge round of applause. Next, ladies and gentlemen, it's my privilege to invite our next speaker, Shri Udaya Bhanu Chakrabarti, sir, who has completed his MTech in Technical Engineering from IIT Delhi and has 16 years of experience in heavy civil engineering, civil infrastructure projects. He has gained diverse industry experience by working with Larsen and Turbo, Tata Steel Limited, BEL in various technical capacities, and sir is currently working as a scientist at the Central Soil and Materials Research Station, CSMRS. His core areas of interest include rockfill technology, dam zone materials, filters and transition materials, liquefaction studies, and ground improvement techniques. Welcome, sir. Please give a huge round of applause. Next, ladies and gentlemen, can we have Mr. Kishore Kumar, sir, who's presently working as an assistant engineer in WRD Karnataka, and sir comes with rich 16 years of experience in water resource department as an assistant engineer and assistant executive engineer as dam, and he's actively engaged in all procedural aspects such as farming project proposals, discussing with DRIP, that is dam rehabilitation and improvement program, and World Bank consultants for obtaining clearances and financial approvals, as well as execution of rehabilitation works of the KRS dam. So, sir, a warm welcome to you as well, sir. Please give a huge round of applause for Shri Kishore Kumar, sir. And our next speaker, ladies and gentlemen, is Mr. Ainendra Kardam, who's a hydropower pump storage and dam professional with experience of about 30 years in India and abroad in strategic development of hydropower projects from concept to commissioning, bachelor's in civil engineering from Delhi College of Engineering and master's in management from FMS Faculty Management Studies, University of Delhi, associated with various professional bodies involved with policy making of energy sector. Sir has worked with WAPCOS, that is Indo-Canadian Consultancy Services, Bilwara Energy Limited, Indo-Canadian Consultancy Services, and much more. Welcome, sir. Now, ladies and gentlemen, we also have our session in charge, Manish Rathod, Director, HCD, NWS, CWC. So with this, ladies and gentlemen, I hand over the session to our chair and co-chair. Over to you, sir. Thank you so much.
Very good morning to everybody. A warm welcome to all the panelists here and all the distinguished delegates to this session. Today's session is quite interesting on aging dams, the state-of-art rehabilitation practices. We have around, I think, 70 minutes in front of us, and I would request, we have 6 speakers, and I would request each one to limit his thoughts to around 10 minutes. And I would really like to have a question and answer session. That's always better to have one. And followed by around 5 minutes of summing up by co-chair. Without much detailing on this session, I'll straight away start my presentation, and then I would request all of the speakers to kindly limit to 10 minutes so that we are on the dot by around 11 o'clock to the break. Thank you very much. This topic which I would be speaking is on compatibility-driven rehabilitation for ensuring resilience in aging dam structures. Once again, good morning. I would be speaking on compatibility-driven rehabilitation for ensuring resilience in aging dam structures. Basically, we have not come across such a concept, but I thought after visiting so many dams during service, post-service, there is something like compatibility, which is also a very governing factor for rehabilitation. Now my contours of the presentation would be background, compatibility in the context of dam rehabilitation, baseline information that would be a reference for any CDR, and then conclusions. Just one slide on the status of the country with regards to the aging dams. If we go by the numbers of the completed dams 6545, we see there are around 25% of the dams which are older than 50 years and around 68% of the dams older than 25 years. Now, if you really see the decadal growth of dams in the country, we can see the two tall pillars standing during 1971 to 1990. And shortly, they will be crossing the age of 50 years. So within another 15 years, by 2040, we would be having around more than 55% of our dams which are more than 50 years, provided we add more number of new dams in this intervening period. Now, issue is basically with the aging dams. What are the issues? The numbers are increasing. A lot of functional deficiencies are cropping up. Deferred maintenance is a problem for almost all the dam owners, and the risks are evolving. What sort of risk? Hydrological risk, structural risk, seismic risk, and many other risks. So basically what we do in rehabilitation is aimed at restoring the aging distressed dam to its original state and bring it in improvement and align with the modern technology and the latest safety standards. Now, what is compatibility in the context of rehabilitation? That is something important to be seen. Just imagine a dam body similar to a human body. There's a lot of simile between dam body and human body. We also age, dam also age. We have a lot of diseases, dam also has a lot of diseases during the course of our life. Now, basically, there are three things in a dam like we have in the body. We have the surface of our body, that is the substrate, similar like we have the dam substrate. It could be the surface of the dam, it could be the surface of the gate structure. Then second thing is something called structure. As a whole, spillway is a structure. And third is an environment. Now, whatever solutions we are really offering would be either on the substrate or on the structure or on the environment of the dam. Now, what is the compatibility we are ensuring is we are trying to ensure the compatibility, that is a scientific as well as engineering harmony between the existing substructure, substrate or environment and the proposed external rehabilitation which we are really contemplating. If we want to have a long, or if you want to enhance the life of the aging dam. Now, along with compatibility comes the word durability. We do rehab, we do repair, we do rehabilitation, but is it a durable repair or a durable rehabilitation? That is the question now. Compatibility is a must if you want to have a durable repair. Otherwise, it's just a repair. Now, normally in the tenders, we don't prescribe whether it is that whatever recommendations we are suggesting, whether the dam life is going to be increased by 100 years or 50 years or 10 years. We just say, okay, you do grouting, you do waterproofing, you do this. But really the life enhancement factor is not coming into the tenders. That is, the performance of the rehabilitation measure is not coming. Of course, our aging dams have old technology, so modernization should be intrinsic to our rehabilitation. Now, one more dimension comes into this, that when we are dealing with heritage dam structures, retaining the originality in structure, architecture, aesthetics is also important. Now, we can't really have any compatibility if there is no baseline information. And baseline information of the dam really is the reference for having a compatibility-driven rehabilitation. Now, CDR, if you really want to have CDR, every dam safety unit as per the Act must be in possession of all the documents. If they don't have the documents, there is no baseline information at all. Number two, the DSU must be having a holistic understanding. What is the material of my pointing? What is the material of my concrete? What is the material of my gate structure? So that's very important. And many of the dams are having all this information. Some of them are also having in a digital format, but unfortunately, many of them are not having any of them or hardly few drawings. So any ad hoc, unscientific, incompatible recommendations may not really give a long-term benefit to the rehabilitation process. So what's the solution? Can we really recreate the baseline information? Yes, we can recreate. There are various ways of doing it, and in today's date, technology-driven reverse engineering can be done. You try to collect all the data, all the historical records, whatever available, all the documents which are gathering dust, try to collect them, capture the reality of the dam by using LiDAR or by using drone or by underwater sonar techniques. High-tech survey you try to have investigations, non-destructive, you try to have laboratory test, then you do the entire data which you have generated by non-destructive testing and reality capture, you can try to process the data and try to create a 3D CAD or a BIM model of that. From that model, you can generate 2D drawings. So then you try to validate and finalize the drawings. So you can create baseline information. Once you have done that, you are in a better position to really go for compatibility-driven rehabilitation. And what is it? It's a multi-dimensional approach. And we have to harmonize many things. The original materials versus the new materials we are trying to inject. The original designs, which were not considering many of the codal provisions which are there today, we have to cover all the contemporary risks. Then we have the designed environment, but the current environment may be something different. You have acidic water in the reservoir, you may have some other change in environment. We need to make it compatible to that. Technology, of course, gates may be rope drum hoist. Today we may like to go in for hydraulic hoist. We may have a different technology. We had Surki mortar those days in many dams. Today we are having a different mortar. So, of course, the agent infrastructure is going to be a big challenge, whether they can really bear all this. Normally, as an old age man, a man turns 80, we said, sorry, his body cannot take any surgical intervention. So we try to see, okay, fine, let him go. So that is what is going to happen to a agent infrastructure which doesn't have the capability to really take any of these rehabilitation measures. Now, just for example, a dam degradation can have mechanical, physical, chemical, any sort of issues. These are the various diseases in a dam. It could be internal erosion, shrinkage, thermal, alkali aggregate reaction, leaching. All these are various diseases. And we have treatment, like a human body, we have treatment for each one of them. But only thing is we need to see whether we are really identifying it correctly and trying to give the correct treatment to that. For example, pointing. If you really want to see what is the made today, everybody says, okay, I'll go and put a epoxy resin, I go and put a cementitious grout and all. But have you ever thought, really, what is the modulus of elasticity, thermal expansion, or shrinkage? Drying shrinkage is one of the biggest factor, which is really part of the dimensional compatibility, that is volume instability. So these are the compatibility which we need to really bring into the rehabilitation practices. Just, I'll not deal much into this. I come to the simple example of KRS dam, which is very nearby. The gates were being replaced, and we could see that the simple cast iron steel track was an issue. They tried all measures, and finally they saw that the screwing of the embedded parts in place of building was the only way, and that is one of the very good example of compatibility. These are the these such type of gates are never made here, made in present times. But then we have tried to see how best compatibility. CWC was the technical support for this, and the end result you can see the leakages have come down. Next is the structural challenges. Here we have a lot of incompatibility with respect to the codal provisions. Hydrological codes have been revised. Hydrological standards have been revised. Seismic codes have recently been revised. And even the structural details are also being changed. One issue which I thought of bringing in front of the August audience is that ICODE Bulletin 119, it talks of uplift pressure. By 1930, most of the dams which are built, it never had uplift pressure under consideration. So the dams in Germany, for example, during that time which were constructed, or many other parts of the country, the uplift pressure was not part of the design. Now you can imagine what all rehabilitation we need to do today. These other cases coming from Japan, wherein again it was a case study of rehabilitation for flood discharge capacity and adding a spillway. Again, they had to do a lot of tests, and they have to ensure the parent body of the dam is really compatible enough to really take the additional loads which are coming up. A 520 years old dam, a historical dam, made again of lime and surkey mortar. In Iran, it was rehabilitated. A lot of studies were done. The biggest thing is if we try to put a new concrete over the old concrete, that is the shear strength in between the two, that has to be adequate. If that is not that, it will not function as one section. So if you go back, this is what is the important thing between the yellow color and the orange color. You can see that there is if the section has to act together, there has to be compatibility between the old dam and the new concrete. And if it's unable to take this load, we cannot go for this particular rehabilitation. This is the Iran dam. And finally, I've talked about the hydrological compatibility. Comes to environmental. Sediments are really changing the environment in all the reservoirs. Similarly, we have the water quality. I will show you one example. Here you can see all the water which is acidic water has really turned the entire dam is turning brown in color. So the environment goes on changing. It could be a downstream settlement. Suppose, for example, we have increased number of downstream settlements and you're trying to increase the design capacity. You need to really see whether we have adequate waterway downstream. So basically, it is the past, present. Yeah, just to half a second. It's basically a past, present incompatibility challenges that we are trying to address. And CDR is one way that we can really see that our rehabilitation is driven with a purpose of compatibility taking into consideration. So the end is compatibility must be ensured if you want to have a durable repair. Otherwise, it's just a normal repair. Thank you very much.
Next, ladies and gentlemen, I would like to invite our Shri Thomas Edwards, sir, who will be presenting on innovative solutions to dam rehabilitation case studies of various countries. So please welcome Mr. Thomas with a huge round of applause. Come on, ladies and gentlemen, it should be a little louder. Welcome.
Thank you. Good morning, namaste, and thank you very much for giving me the opportunity to present some case studies today. So I'd like to talk about some elements around dam rehabilitation, retrofitting, and reoperation, providing some examples of solutions and some of the challenges that we have come across on a number of projects. I think a lot of you have seen this slide over the last few days, so I won't take too much time, but the point here is that we are in an aging dam environment with a lot of structures having been built between the 1950s and the late 1980s. Obviously, we have these challenges where these dams now require to be reviewed. And one of the aspects that we have been looking at the bank is this concept of the 5 Rs. Looking at both in the built and the natural environment, the ideas of reoperating, rehabilitating, retrofitting, or reforming and raising new. Concentrating on existing dams, we look mainly at the reoperation, the rehabilitation, or the retrofitting of those structures. What does it mean? Well, basically what we're trying to do with rehabilitation, as we all know, is we're trying to sustain and enhance the performance of existing assets, and for their primary use. So that could be water supply, irrigation, flood control, or energy. Now, what we want to try and look at on a lot of these structures is the ability to add functionality to these existing assets. So through the ideas of increasing storage so that they can the additional hydropower generation, for example, providing additional environmental improvements through enhanced environmental flow releases, or providing other benefits such as converting these structures, which may have only one purpose initially, into multi-purpose storages, providing flood control and other such purpose. A few case studies that we just want to go through as ideas, but this was a World Bank supported project in Malawi, where the Kamuzu barrage was permitted to increase the level of Lake Malawi by 40 centimeters, helping increase seasonal storage capacity. We also reduced the flood risk by incorporating a real-time hydromet system with forecasting and early warning systems. There was also some works in the catchment to help reduce erosion and the potential for sedimentation of the lake. Another example, this is similar to some of the work that was presented yesterday by our colleagues from Japan on the idea of adjusting seasonal rule curves in order to increase flood capacity. And this was an interesting case study led by the Sonoma Water, which is a consortium with US Army Corps of Engineers and others in the USA, looking at basically using forecasting information in order to adjust maximize the ability to store floods. These case studies suggested that up to 19% of additional storage was achieved through modeling in one of the years. A few more examples. Here is an interesting case as well in the USA called Glen Canyon Dam, where basically they found that with the increasing droughts and low levels in the reservoirs, they were reaching or exceeding minimum operating level. So here what they did is they provided additional outlets at the base of the reservoirs in order to be able to take water from below the minimum operating level, and therefore providing additional water security in case of regional droughts. Few examples. I mean, a lot of you in the room will be very familiar with these, but of trying to provide additional capacity with the existing constraints of the reservoirs. So we have here some common examples around labyrinth weirs and their evolution with the piano key weirs, and also provide some examples around fuse gate weirs. These structures are often added when hydrologies or the desire to provide additional storage capacity is prevalent, without wanting to necessarily adjust the dam height. So you have these examples of these classic examples of labyrinth weirs. This is an interesting modification to a side spillway where a piano key weir was added, providing additional capacity in the same space. And then there's some examples of some fuse gates. These can either be steel, as it is in this case, allowing basically the ability to keep the storage or increase the storage whilst maintaining the safety of the spillway capacity. This is an example of the dam in Montsalvant in Switzerland. This is another interesting example. Lynn Kellin recently completed works in the United Kingdom. This is a fuse gate spillway made out of concrete. The advantage here is that also you can adjust your designs so that only you can have partial operation as well as these gates collapse under hydraulic load. Just wanted to touch briefly upon some of the challenges. Obviously, we all know as professionals the clear need to define and communicate the operational and safety constraints when setting out these rehabilitation projects. Really understanding the temporary reservoir operation rules during rehabilitation, including the flood requirements and alarm levels. You know, when we rehabilitate these structures, we are often exposing these dams to loads that and vulnerabilities that they may not have been exposed to in their current condition, and so they may be at their weakest during these works. And so we need careful consideration around the safety implications of our works on the actual structure itself in its temporary condition. So here's an example on the right-hand side of the need to perform the works under full supply level with fairly complicated temporary platform arrangements and floating barges. Other aspects is in terms of adaptation of the design and construction techniques and sequencing in order to work with our reservoir operations. The importance of managing risk, as we mentioned earlier, during the actual works, and that can include as well inflow forecasting as well. Issues about challenges around safe isolations when replacing some of the structures in the lower ends. This is an example of an isolation that was used using a robotic arm, and that was placed over a bottom outlet in order to isolate it safely, in order to be able to upgrade and update the duty and guard valves on the structure. The other aspect I wanted to mention is that there's also needs to be careful coordination with the contractors. We've seen good examples of building in temporary works into permanent designs. This as well is another example of what we called a limpet cofferdam. This allowed the reservoir to continue its operation whilst modifications to the overflow structures and improving outlet capacity was undertaken. A few enablers, but that was touched upon by our chair in today's session, is one of the aspects that we've seen, and I'm sorry for repeating the point here, but is the real importance of good records of historic designs and construction information, including the availability of past additional studies.
Just sorry to interrupt, Mr. Thomas.
Yes.
Just try to.
Yes, I just have 30 seconds. Including the availability of past additional studies and their outputs. So, and the importance of quality monitoring records to allow the designs to take place, and the knowledge of operators as well as retired operators in terms of the specificities of these structures that often have their own habits. So I just wanted to highlight the importance of maintained and accessible archives, and I understand that this is an initiative that's being looked at with this Dharma aspect with CWC, and I really think that it's an excellent consideration, and hope that it can continue growing. Thank you.
Thank you very much, Mr. Thomas. I think the challenges of rehabilitation in the operational reservoirs you had nicely spelled out with the international case studies. Now we move on to the next speaker, Mr. Britius Mupeyo from the Zambezi River Authority. He would be talking on Kariba Dam rehabilitation project, and it's a matter of plunge pool rehabilitation, which really we eagerly look forward to the presentation. Over to Mr. Britius.
Yeah, good morning all. Thank you so much for this opportunity to represent the Zambezi River Authority in speaking about this really very unique project with no record globally to show of a similar project having been done. And I think this project stands as a blueprint to any future project or dams that are facing similar challenges that the Kariba Dam indeed faced. Maybe before I dive into my main presentation, it's key that I speak about the establishment of the authority, which is the Zambezi River Authority, a binational in nature, owned by the two governments of Zambia and Zimbabwe, and the sole owner of the Kariba Dam, which is the sole topic in this presentation. I'm glad to mention that the Zambezi River Authority is proud to have partnered with esteemed funding partners, including the European Union, the World Bank, the African Development Bank, and the Swedish government in undertaking this key rehabilitation project amounting to over US dollar 290 million. Just to highlight some key features of the Kariba Dam that will be key in my presentation. The age aspect, over 60 years. The height, over 128 meters. With the spillway gates located above 90 meters, the foundation. Storage capacity, one of the biggest reservoir in the world, 180 billion cubic meters of water. Spillway capacity, 9,000 cubic meters per second. The issue really here has been the development of the plunge pool to 80 meters deep. And this has been caused by the erosive energy from the spilling water from the spillway gates. On its own, the development of this hole wasn't an issue, but the issue really lies in the manner in which this progression was being recorded. What was discovered was a weak rock formation that really cuts across the dam foundation. And preferentially, the erosion or this erosive energy from the spillway attacked the weak zone, which we call the fault zone, which led to the risk of undermining the structural integrity of the dam foundation. This was the sole motivation to the implementation of the plunge pool project. I'm glad also to mention that we have a robust monitoring system in place which identified this issue early enough in the project lifespan, and we are able to track it all along its development. By the 1998 report by our retainer consultant, who is Tractor Bell, we were able to update the risk to which this attack had gone, and the study indicated that the risk had actually reached unacceptable levels where something was needed to be done in order to correct. And as a result of this study, the restrictions on operations of the spillway gates was instituted as a temporary solution to the problem that was attacking our dam. The worst case scenario of this risk was the catastrophic failure of the dam, which on its own had major consequences downstream of the dam to do with the 3 million lives that was at stake, the over 80 billion US dollars at stake in economic value, and also the loss of energy that this infrastructure provides to the two nations. In terms of the permanent solutions, a number of options were appraised at the project appraisal, including just repairing these dilapidated sections of the rock that was worn out by the spillage. Also, there was some option to modify the jet trajectory to enhance the dissipation of the energy. To mention the final solution that was arrived at was to do with the morphological reshaping of the plunge pool. That really involved increasing the volume of the pool in order to disperse the energy during spillage. It also involved the protection of the fault zone, which is the area in the schematic diagram here, by a very high abrasive concrete. Then also the manner in which we had to reshape the downstream face of the plunge pool in such a way that you reduce the turbulence that preferentially was causing this erosion, to promote more laminar flow of water downstream, to the downstream. Our solution was validated by a combination of numerical and physical modeling that really provided confidence. As I mentioned earlier, there are no records of such a project having done. So we relied on the numerical and physical modeling that provided this confidence in the safety and effectiveness of the selected remedial action. And also to do with this modeling, you can see here how the studies was done. On top there, you have a diagram that shows how this swelling around of water caused erosion to the rock mass. Then there was also option of reshaping, partial reshaping of the plunge pool, maybe halfway. At this point also, we still had some swelling or the scouring around. And a full excavation was arrived at, where now you can see that water easily flow downstream the cofferdam, reducing on this aspect of the erosive scouring that was happening. This is just the physical model done in one of the universities in Switzerland to just confirm what I've just indicated. In terms of the approach of the rehabilitation, of course, we had to do the access road construction, which came with its own challenges. We had to construct a cofferdam, a watertight structure intended for the works to be done in the dry for accuracy and quality of the works. We noted yesterday these works could also be done underwater by way of using the remote system, the remote operated vehicle. But for accuracy and quality purposes, we went for the option of working in the dry. Then we had also to install a robust monitoring system on key infrastructures around it to ensure that our works never impacted the structures negatively in any way. Then we had to do a dewatered and the combination of dewatering and excavation in a staged manner to ensure also the safety of the dam. Having exposed the weak sections of the plunge pool, we would now do the repair works or the fault zone in the dry, which eventually would lead to the confirmation of the conformity or the shape of the plunge pool to the design, and finally the commissioning of the project. This just shows the concepts in terms of the design aspects that we had, the engineering, the value engineering applied. We went for the combination of piers and the steel stop lock to allow easy demobilization and the remobilization during the works in case you want to spill the you want to allow for spillage during the works. You easily just lift up the stop rock and allow water to the downstream. Then the cofferdam also, we went for the lighter structure for the piers themselves. We went for a lighter structure anchored into the bedrock by post-tensioned tendons to just improve on the stability. This is the other concept.
Excuse me, sorry to interrupt. Mr. BTS, just your time is another, you have half a minute. Please come over to conclusions. Fine?
Okay. Yeah, so these are other engineering, technical aspects that were applied. The construction of the pier bases underwater by using of specialized divers who were not just divers but also experts in other disciplines of engineering, surveying, structural engineering. Then the way we also did the prefabrication of the pier houses on the lift structures, and also the flotation of the piers to their final destination using the principle of buoyancy. Yeah. Then this slide just shows some location of the monitoring system that I mentioned. This was the picture here, first how the plunge pool looked after first dewatering, 376. And on the right here, you see a reshaped plunge pool, which conformed to the design. If I went up, you actually by just looking, you would tend to align it to the design that was in place. Then the refilling itself also had to be done in a staged manner for various reasons, poor water pressures in the rock. For some time, over a year, the rock mass was dewatered and stabilized in that condition. So now to refill back the water, there could be some destabilization in terms of core water pressures in the rock that form part of the strength of the rock. So we needed to really monitor how this aspect was done. So the 376, which I showed earlier, now I show it again in a reshaped plunge pool. We see now a nicely reshaped pool able to handle the energy that I talked about. In terms of time, initially for 4 years, foreseen for 4 years, executed under 7 years. Cost-wise, 49 million initial contract price, ended up 106. This highlights the number of challenges that the project faced. Among them included the unforeseen geological conditions with the access road to do with the withered rock that we encountered under the piers as we are doing the piers, the cavities, large cavities that we encountered after having dewatered that we had to repair, stakeholder management issues. As you may know, this was a multi-faceted project with a number of key stakeholders that we needed to structurally manage. So these are some of the key takeaways from the project. Early investment in geotechnical investigation will save you $100. You invest $1, you save $100 if this risk had to happen. Then also we are advocating for allowing adaptive and prescriptive blasting issues. We are also advocating for rigorous interface management during the works. We are also advocating for structured governance in complex stakeholder management. And also we are advocating for procurement beyond price. The due diligence with the developer or the contractor is also key in a project of this magnitude where a lot of uncertainties are foreseen. Thank you very much, Chair, for the extra time given.
Thank you very much, Mr. Britius. I think it's a very interesting case study of reshaping the plunge pool of Kariba Dam. We have many such projects around the world, and in India also we have issues with the plunge pool erosion and retrogression towards the dam foundation. So I think your paper would be quite interesting to really look through. With this, we go to the next presentation by Sri Uday Bhanu Chakravarti, scientist from Central Soil Materials Research Station. We would be talking on the construction technology and quality control for Rockfill dams intended for irrigation and pump storage projects. I think it's quite an interesting topic because a lot of Rockfill dams are coming up in the PSPs. Over to Mr. Uday Bhanu Chakravarti.
Thank you, sir. Chair and co-chair of the session, all the distinguished delegates. Today, I am presenting the outcome of an applied research study that carried out 2 major irrigation projects and 1 pump storage project. So these are content of my presentation. Uh, the Rockfill Dam is widely used in earth core Rockfill Dam, then concrete phase Rockfill Dam, and geomembrane phase Rockfill Dam due to their high shear strain, excellent drainage capacity, absorb the seismic resistance, and it can be used any foundation condition. Today, the Rockfill Dam are primarily important due to the rapid expansion of the pump storage project and their large hydropower project. So this is a typical cross section of an zone rockfill dams. The outer portion is made by the rockfill materials. Okay. First case study on the Polavaram irrigation project. This is a Polavaram irrigation project which is being constructed on Godavari River, and this is a spillway which is a flood design capacity is 50 lakh cusecs, and this is a upstream cover dam which is 2.34 kilometer long, and its height is 39 meter. This downstream copper dam, which is 1.6 kilometer long and height is the 15.5 kilometer, and the main dam is being constructed. This is a main dam. Second case, sir, these are old. So no issue. This is the second case study on this canal irrigation project. This is a canal irrigation project, a centrally 312 meter long this spillway, and the both side of this spillway there is a rockfill section. It is a composite section which is in the Uttar Pradesh. So this is a rockfill section. This is a central drain. It is a composite dam. So next, our study is basically on 4 sections. One is the foundation, then trial embankment, the placement sequence, and quality control and testing. So due to this time constraint, I am only focused on the trial embankment and the quality control and testing, particularly for the filter and the rockfill material. So there are 2 types of rockfill material. One is the alluvial or riverbed materials. Another is the quarried blasted rockfill materials, which is obtained through the control blast and fragmentation analysis. So good type of rockfill material are generally obtained from the granite, basalt, quartzite, and meta-type rockfill material due to their high crushing strain and low porosity and absorption capacity and minimum breakage factor. Whereas the rock type, the sandstone and the limestone can be used as a rockfill material, but after the durability test. While the material like the shales and mudstone try to avoid due to their poor mechanical performance. So the rockfill material are tested and their shear strength parameter are determined by the large size triaxial apparatus under different confining pressures. So under different confining pressure, and why the rockfill material tested for these large site triaxial due to the better simulation of actual site condition, and the result often these triaxial they are stress dependent. So these are ideal rockfill materials. What we get from these, what is need for an ideal rockfill material for use as a shell material. Now we are talking about these. Before use of these rockfill material, we have to create a trial embankment which should be the far away from this main dam. So trial embankment is actually validate the design assumptions like the material gradation, the density, then their permeability behavior, their settlement behavior, and the deformation behavior of rockfill material. So this is a typical trial embankment, which the middle portion is a core that is act as a water barrier. Both of the core, there is a filter materials. It is a main purpose of the filter material to retain the base material and dissipates the excess pore water pressure. And the shell material is provide the structural stability to the dam. So the trial embankment is designed, the design parameter of a main dam. So it depends upon the several factors like the roller type, the roller, then the passes, the number of passes, then the roller frequency, their amplitude, the speed, and the moisture content. So these are so layer thickness should be depend upon the maximum size of the particle. If the maximum size of particle is, for our case, we have taken the 600 mm, the maximum size particle, so its layer thickness is restricted to the 900 mm. So, and we have taken 11 ton of the roller and which frequency is 34. So with the increases of the number of passes, the field density is also increases. But after the 8 passes, the field density is no significantly increases due to the particle breakage. It has been observed that at top the surface there is a high content of the finer content is high. Where this, if they remove the top 0.5 meter of the materials, it taken time is more greater than the lower layer, underlying layer. Why this happened? Because the compaction is not uniform throughout the layer. This effect is called a Oreo cookie effect. This effect is called Oreo cookie effect, and this graph, this drawing is this picture is showing that how the compaction is carried out for then CFRD dam. There's concrete face Rockfill dam and the GFRD dam. So the Rockfill material are obtained through the control bus and fragmentation analysis. These are typical gradation analysis of prototype Rockfill material, and there are the upper limit and lower limit. The oversized material should be by the breakers, and the higher size particles should be segregated by these grizzly or separator. So the layer thickness, we have determined how to the layer thickness. And it should be, as I already told, it should be 1.5 times of the maximum particle size. The fines is the upper layers compared to the down one. So the gradation is influence the stress strain characteristics, the volume change and settlement behaviors, then the stiffness and the permeability behavior. A well-gauge Rockfill material should have the CU, that is uniform coefficient, should be greater than 15, and CC, this coefficient of curvature, should be 1 to 3.
Mr. Udayabanu, you
Yeah,
have 2 minutes. No,
Yeah,
you
yes,
have
sir.
2 minutes. No, you have 2 minutes. I'm just giving a
So
caution.
the particle size below 100 mm, how to segregate them? By the standard sieve size as per the I standard. And this particle size above 100 mm but below 300 mm, we customize our sieves and we check each and every particle. And for above 300 mm, it is very difficult to handling them, so we use tape and measuring their least lateral dimension, each and every particle. So then we are taking the permeability of the Rockfill material by the ring and water replacement methods, and the ring size should be 3 to 4 times of this maximum particle size. These are photographed during the testings, and the density should be, density is nothing but the mass by volume, and we know volume of this pit and the material we extract from this pit, so we can determine this density. So for our case, the design density was achieved, and it is above than our design parameters. And the finer content, that is 75 micron below, should be restricted 5%. Otherwise, the poor water pressure generate, and it will dissipate with times, and the settlement will occur. So we have very restricted about the fines control also. This is an in situ parameter. In situ parameter determined by the IS 5529 part 2. This is a inflow to outflow. This is a constant head method, constant head pumping method. And the permeability is 2 centimeter per second. So it is so that the material is pervious to semi-pervious nature. Rockfill material should be pervious to semi-pervious nature. So the conclusion, the well-graded rockfill material should have the high strength and permeability, and it should be well-graded before placing and spreading. Then the tile amendment should be done before the construction, so it validates the design parameters. And a strong QA/QC system, integrated system should be established before it use. And a quality manual should be established for the project. So if, for rapid expansion of the pump storage project and the large hydropower project, we have to build a robust system of quality control. Thank you. Thank you to all.
Thank you very much, Mr. Uday Banu. I think it was a very pertinent topic on the material characterization for the Rockfill Dam and quality control purpose. I think we are having around 70 to 80% of failures in the country, basically for the embankment dams. And it is basically either your design considerations or quality control or any of these construction factors. So I think this paper, what Mr. Uday Bhanu has presented is quite important on the quality control aspects, particularly with respect to the CFRD, which we are now using in a big way in all the PSPs. So I think everyone who are into this subject should be very, very particular about this, these aspects which has been raised in this particular paper. Thank you very much, Mr. Uday Bhanu. With this, we move to a very interesting topic of Krishnaraj Sagar Dam from Mr. Kishore Kumar, a Water Resources Department, Karnataka. And I think it has been it's around 100 years old dam. And I think we have done a wonderful job, CWRD and all, in rehabilitating these 136 sluice gates which were leaking. So let's hear from Mr. Kishore Kumar. Over to you.
Thank you, sir. Thank you. Good morning, everybody. Good morning. Actually, 5 papers, you are getting a little bit tired, I think so. Okay. Presently, I'm presenting 8 minutes of PPT and 2 minutes of little documentary video is there. So that I will start my this one PPT. Basically, the silent features of KRS Dam. And we have to remember Nalvadi Krishnaraja Vadayar and Vishweshwaraya, Saram Vishweshwaraya is the pioneer of the Krishnaraja Sagar Dam. So the Kaveri River is a basic river for this one construction of the dam. So the dam is a Surki mortar with masonry dam. And this one we have got in that total floodgates will be the 152 floodgates will be there. In that 136 gates were been replaced by in drip World Bank project. So these are the surpluses, different levels of the gates we have. Yes, this 136 gates we have replaced. In that one, 103, 114, and 100 this one 6 gates we have placed. Total, it could be 136 gates we have replaced. In this one, challenges what we have means the total floodgates is 152. In that one, design flood is 350,000 cusecs. So before this one replacement, we have got only 236,000 cusecs. So we are only discharging capacity because of 48 dams. This one 48 gates in 103 level gates, 23 gates in inoperative condition, and this one in 106 level 9 gates are in inoperative conditions, and in 114 automatic well gates, that one since inception it is not operated, so it isn't plugged. So this is the major challenges. In June, we have started this one 2014 June. We have started for the experts for coming to the KRS dam. Different experts has been come and different technologies and different methodologies we have been brought out. But lastly, finally, we have choose the methodology and we have done the rehabilitation with along with the World Bank and this one DIP project. The problem in a dam is majorly this is 90 years old dam. The 136 gates all are in cast iron gates. And basically the cast iron gates is the property, this one leakages, leakage with heavy leakage through sluice gates and corroded damages gates in embedded parts and non-closure of the gates. And this one skin plate of the gates has been fully eroded. These are the things which is in inoperative conditions. So it is very difficult to manage the gates because of 90 years the gates has been irreversibly so much of floods has been we have passed through in this gates only. Basically these gates are operated through the gantry crane, that is single motor gantry crane. It has been operated so that it is very difficult for this one for closing of the gates. And we have the jacks to the for complete the leak proof, but it is very difficult for this one gates. So this leads to the loss of flood discharging capacity plus increased changes in gate failures, leading to the poor management of the flood. It is directly affect to the downstream of the dam. Since the dam part is a very important part, is the hydromechanical part, because lot of erosion it's been in the gate piers and in even apron, everything has been changes. So for the structural safety and as flood discharging capacity, this one initially the World Bank as suggested to the Central Water Commission to the wet for the design and drawings. So we have Karnataka SPMU, we don't have the in-house hydromechanical. So Central Water Commission North and South design chief engineer, they have vetted the full complete replacement of gates part. What are the replacement? We have basically initially the sill beam we have replaced, and side guide, and this one seal seat, and total gates and hoisting component. Particularly the embedded parts. Embedded parts is the major part which has been challenging in nature. This is old cast iron. It will not do the. It should not be dismantled since the dam is old. If it is, if you touch one stone also, it may happen to hazardous condition. So the every modified single part of modified, it is a tailor-made method. That is, each gate is different and each gate is different. So that we have made it 10 mm precision to the gate. So for the embedded parts, we have make it is in a tailor-made method. And these are the embedded parts modified. See, this was we have added new side guide, and this one, the cast iron, it has been screwed. It has not been welded. It has been screwed within stainless steel plate, and you can this one is sliding to the this one, and sill beam has been it is replaced, and bottom sill has been done. These are some of the old removal gates has been. And fabrication took in the yard, it seems, in KRS site only. And the third-party inspection part, it has been given to Lloyd's company. This is the sluice gate, how we have replaced the things. And challenges we have made in that one before that one, 2019 agreement was made. The COVID has come, it's a major disaster, so that we can't complete the in time because of the COVID. The labors and everything stuck down, and second wave, the oxygen supply has been not made, and in third, the major cyclonic effect has come. We have got only a working period of 23 days. Like that, some 90 days will be the major challenge proportion for we are replacement the gate. We only after 100 feet only we have to change all these gates. This is the 114 gates which has been not operated by inception. Now we have made it operational because it is a embedded part. Some problem in 5 degree of this one angle is there, so we have made it in straight and parallel, and we are done. These are the gates we are replaced. Can you put a video, please?
The KRS dam, particularly the gate structures, this is having a peculiar special feature. They are all of stony type. When they have to be replaced, the embedded parts are also required to be modified to the fixed wheel gate type now.
This is inside fabrication is done. This one old gate has been replaced. This is new gate we have placed. Hoist system, single motor hoist system.
Even though there was 48 gates at 114 level were to be operated by automatic system as contemplated in the original construction period, we came to know that they were not operated since beginning even once, even though now the age of the dam is about only 90 years. It was those gates were not operated, automatic gates.
This is a SCADA system, remote control. We will operate now the old dam with a new contemporary methodology. Remotely we will operate nowadays. Already 2 floods has been released successfully. So that this is the achievement from the WRDO, CPMO and World Bank consultant. So that everybody is involved in this one. So I am very grateful to everybody. These are the platform which I have given for me for this one. This is the I am nearly 12 years has been in the WRD. These are the opportunity. So they have made me to stand here, and my director KRS and CPMO, SPMO, and all our MD, CNL, everybody is cooperating to success the gate replacement with innovative methodology. Thank you. Thank you.
Thank you very much, Mr. Kishore Kumar. It was quite enlightening. I think all the audience participants would have enjoyed it. I can't resist a few words on this project. I think it's first of its kind project of rehabilitation by the support of World Bank, technical support of Central Water Commission, and wholehearted efforts by the government of Karnataka and Water Resource Department. Never ever we have done replacement of 136 gates of old 100-year-old dam. Again, the same thing comes. There were many issues in this dam, like the earlier design concept was they were not having emergency gate. In this project as well, they didn't have an emergency gate. They had to empty the entire reservoir and then do the maintenance. And water, as you know, in Kaveri Basin is very, very precious. So again, the issue of compatibility. Then comes to the material issues. It was a masonry made in Surki mortar, 1:4 Surki mortar. Again, the compatibility had to come. And then comes the gates, which he mentioned again. So it was not an easy task, and all three together, the concerted efforts have brought this. I think it's one of the best examples of really rehabilitation in the country. I think it deserves a big applause for all of them. With this, I move on to the last speaker, Mr. Janender Kardam from SMEC. He would be speaking on the rehabilitation of dam structured approach. I would be looking forward what is that really about. Mr. Janendra, just 10 minutes.
Sure, sir. I won't trouble you with the mic in your hand.
Very nice, very nice. And we also, I don't want people to leave without a Q&A session here, okay?
Yeah, sure, sir.
So we are encroaching into the break period now.
I'll try to stick to the timelines given to me by the respected chair and co-chair and my co-panelist. I welcome you all. A very good morning to all of you, the delegates, and all of us here. The timelines are very important, not only to us, but to the rehabilitation also. So that is the whole crux of this entire situation, entire paper which I am presenting today, that what is the need of having a structured approach altogether in this complete rehabilitation process. So this is an approach which we have tried to develop from the experiences which we are facing and which we are seeing in the rehabilitation in the DRIP projects and in the various examples worldwide also. My co-authors are Mr. Rakesh Kashyap, Ma'am Neeta Arora, and myself and one of my design engineer, Ms. Nissan Galaj. Basically, everybody has talked about this. The basic problem is the aging of the dams, and that is what is creating the safety risks to the dams, existing dams. And what are the contributing factors to this? Contributing factors are the climate changes, the seismic conditions, and the regulatory push is given by the Act is also means basically allowing us and to move ahead more towards the dam rehabilitation process. So in this altogether, what we need, if we need to really have a dam safety kind of an approach, then we need to be structured, though the structure will come from the existing practices which are already there, but we need to be focused and have a structured stage-wise program or a process where we can reduce the time and cost risks for this entire scheme. Coming to the next part of it, this is the background of this. That in a paper I was going through, there was a paper in which this was the first line which was mentioned, that failures, they have done some studies on about 53 dams worldwide. And on the 53 dams worldwide, they have done some statistical studies that what were the causes of failure for those 53 dams. And having all these studies, they came out with the kind of a statement that the failures are less about structures alone and more about decisions. So decisions are basically which are created in this entire process of the rehabilitation as various processes. If the decisions are taken right in time, generally these delayed decisions are causing the exorbitant cost to the projects and also causing a safety risk to the existing rehabilitation of the dams. Second is this is what I have already mentioned about the global study. So in this case, we need a structured decision-making framework for this. And this paper and what we have tried to develop is a flowchart kind of a thing for you people, so that it is a kind of a sequencing of the activities which we can take up for the carrying out of the rehabilitation. The objective is that it is to present a structured stage-wise rehabilitation program. And here it is what we want to integrate is the engineering with the project management practices which are required
and so as to reduce the cost, time, and the scheduled risks which are there in the rehabilitation of the dams. Who are the stakeholders? Since yesterday in the National Dam Safety Act also we have heard about that who are the stakeholders, but what I could not listen from anybody is the contractors. Contractors are also very important stakeholders in this entire process of rehabilitation, which we generally seem to forget and we generally seem to not take along. And generally these are the people who do the actual thing on the site and who are responsible for getting the rehabilitation done. So it is like these people we have to hold on and we have to take along for the effective rehabilitation program, whatever we decide. We decide unless means we design anything, we may do some good designs, we may do some better tendering, but ultimately when it comes to the implementation part of it, if we can't get hold of a good contractor and if we can't hand hold of him so as to do it, then we are losing ultimately on the time and money and increasing the risk to the rehabilitation of the process. So this is what I just want to highlight in this slide about the contractors. This is the various RCI metrics we have tried to generate, that what is the responsibility, accountability, consultative and informed. Various stakeholders in the various stages of the development. First stage is the problem identification, then assessment of studies, design, DPR, procurement, construction, and then the monitoring and reporting. So in this various processes of this, in the various things, then who is responsible for what? Who should be responsible for what? Though the Dam Safety Act says a lot about it, but we have tried to reframe some kind of it and try to give a new thought to it so that you also could be able to see that where we are and how we need to move along and are we accountable to all this or not. This is the process in which we have tried to generate this entire process in 2 stages. First is the problem identification. This is the stage 1. Stage 1 have been restricted only up to the planning stages, and then the stage 2 comes when where stage 2 is the implementation stage, where we are saying it is more about procurement, starting from procurement to the implementation part of it. So here are the 2 stages which we have primarily defined, and in these 2 primarily stages, what is there is that what we integrate upon is first is the problem identification, that we have to identify that what are the problems involved. So what are the basic, how to identify the problems. So generally presently we are facing is the routine inspections carrying out on the projects. Then we have got the periodic inspections also. Then the inspections which are taken after the special incident has happened to the project, and special and comprehensive or dam safety inspection by the experts. So these inspections which they carry out, generally what is happening is that recording of the observations are sometimes lacking out. So what ultimately we miss out on the risk on this stage, that any effective event which has happened on the project, if it is not recorded and not inspected, then it is ultimately leading to the increased risk to the rehabilitation program. Then the second is the assessment of the problem. Assessment of the problem is basically in this, the main thing which we are lacking is about the historical data. Historical data of the things and data of the projects which we are seeing, that the project which needs rehabilitation, sometimes what we need is the data, and that is what is missing sometimes there. So that to not have that data for that rehabilitation is basically increasing a risk. So how do we do that? That we try to identify the data gap in between. So this data gap identification is the foremost thing which we feel it should be taken along, and it should be done very nicely, in which the maximum risks of the project of the rehabilitation can be eliminated out at this stage. Because this is the stage when if you identify properly that what are your data gaps required and what is the investigations you feel you need to have for this project, then it ultimately becomes very easy for a smooth rehabilitation program proposal to be developed. Otherwise, we are dealing with the things which we don't have in hand with us. This is what, and the third point is the assessment of problem I was talking about, and then the proposed rehabilitation plan. Sometimes we propose a rehabilitation plan based on some good aspects, though we are all very good engineers and we like to play along with a lot of things also. But sometimes it happens that sometimes we give something which is not there implementable to the implementing agencies. So always we are need to have a consultative kind of an approach for having a developer proposed program, so that the IAs and the state governments are also taken on board for this any rehabilitation program which we are giving to them, whether it is implementable to them or not. They considering their own strengths, considering the type of contractors they are having, considering the type of materials they have on the site, and considering that what all infrastructure or resources they have in mind. So if we have got all these, then this entire risk of implementation can be effectively eliminated at this stage. Then the procurement part I was coming upon. Procurement part is basically that to have a right contractor, though I have detailed it in a paper, that it basically depends a lot on the strength of the implementing agency and the type of contract we should go upon, whether it should be EPC or the item rate or whatever. It should be deliberated upon, and not on the that some other project some has been done, then we should do it on this also. It should not be the approach. It should be deliberated upon, and it should be taken along in a very well way with the implementing agencies.
Mr. Jainender,
Yes, sir. Last 1 minute I need, sir.
Thank
These are the key risks which I mentioned, and which we need to eliminate out at every stages. And this is the conclusion slide that which I mentioned, is that a structured two-stage approach enhances the rehabilitation effectiveness, as I briefly mentioned, and this supports informed, transparent, and timely decisions, which are very essential for any project, and helps achieve the safety objectives with the planned time and cost. And this framework, I think, is acceptable, which we have tried to come out with, is acceptable across the dam typologies, various dam typologies, and the across various agencies. So what I would suggest that let's assimilate the things which we have, give them a structured kind of an approach, and move towards with the goal-oriented approach, so that we come out with a good and better rehabilitated programs. I sincerely thank you all for giving me a patient hearing, and I thank my chair and co-chair, Mr. Rakesh Kashyap, and all the CWC chairman, CWC members, CWC is also here. Thank you all for having a patient hearing. Thank you very much.
thank you very much, Mr. Janender Kardam. I think I saw it has been authored by SMEC as well as DRIP project director, and also I think it's a very good synergy between SMEC, which is the PMC, and the DRIP, and this structured approach I think can move forward, so that all the rehabilitation projects have certain way of handling. With that piece of information, we are now through with all the 6 presentations, and no session should go without a Q&A. So we have kept 10 minutes of Q&A, though in borrowing some time from your tea break, I would like a couple of questions to all the speakers here, so that we have further enlightenment from the audience. Yes. Dr. Shahid Joshi ji, bataiye.
First of all, a very enlightening session. And one thing I noticed is all the 7 speakers, either implicitly or explicitly, were speaking about compatibility. And my specific question is to the session chair and Dr. Chandrasekhar Iyer regarding the compatibility of the material as well as the structure. They go hand in hand. I have seen in many cases in many states that these project engineers are not coming out of the temptation of providing either shortcutting or ganiting to the masonry phase on the upstream. So these two are totally incompatible materials. We have seen it gives immediately the result. In a couple of years or 3-4 years, it will give 100% waterproof and seepage will reduce considerably. But over the time, these two incompatible materials will give way and the seepage will again enhance. The best example is of KRS again, Mr. Kishore Kumar presented, not in this, in other. They did a simple pointing, underwater pointing and above water pointing as well, which has yielded a very good result. So my appeal to the session and the session chair while summing it up is to give an insight on using the material which are compatible and structurally as well. So that was an appeal rather than a question. And my congratulations to you for having brought out this compatibility-driven rehabilitation in the forefront of the things in the dam safety. Thank you very much, sir.
Dr. Sharad Joshi, basically, if you really see, that is one of the really most important thing among the various compatibilities, material compatibility, because we often go, as you rightly said, some incompatible solutions to the parent material, particularly so in case of aging dams or old dams, which are beyond 60, 70 years. That's why, while yesterday our CSMRs and Parson were presenting about the pre and post investigations, pre and post. That is, once they do it pre and then they do a post investigations, non-destructive into the structure after the rehabilitation. I would say pre, post, and one more P, post. That is a follow-up of it. Maybe down the line, 5, 10, 15 years, we also follow it up with such follow-ups, studies, so that we know whether whatever we have done, whether waterproofing or pointing or grouting or anything which we have done, whether it's really effective. So we also get, as on date, I don't see any paper which talks of the follow-up outcomes of the whole rehabilitation measure. So your point is well taken, and I think all the speakers were in sync with the whole thought what you have said. Any other question?
Yeah, and this is a question to Mr. Kishore Kumar. There was a unique system of automatic gate closers designed by Sri Vishweshraya. Why there was no efforts to revoke that, or at least they should make a model of that and keep it in KRES so that for the future generations to know what happened to us.
Thank you, sir. Actually, in 2014, we have started expert teams to refurbishment of the automatic well gates. So we had tried for 3 years for estimation and this one, how the methodology we have to fit for the 114, how to get the automatic gates. It is working in Tigra Dam also now. Now it is working in Tigra Dam. This is the Vishweshwaraya's patent. It is a simple, this one buoyancy effect. You can see in our stall also, we have mentioned that one. But efforts has been made, sir, but what is the problem means masonry part, it will not obliging the things. That is a major issue. And also since inception, it has not been operated. As on record, it has not been operated, so that everything is plugged. And also the hanging, that one, the gates are hanging. The total floating this one well is around 6. Each well is connected with the 8 gates. Total 48 number of gates. So it is in hanging portion. The counterweight it is not supporting. One, the labor, it is not in record. Actually, what is the thing means, previous labor, what we have, based on their experience, we have, they are telling that one. Once it has been operated, automatically it has been operated. There is a well and conduit pipe in that one. Our people, after 120 feet level, they will open the block, open the gate wall, so that it will enter to the well, and the float will be, the well is full with the float, so that one, the counterweight, when the level is reached to 124.8, the counterweight will be depressing that one, so that automatically 8 gates has been completely opened. But it has been opened, it has not been closed. It is not has then counterweight that much of the capacity. And also, when the dam is full, the wave obligation, beside the dam, the wave obligation, it is hanging through the chain. So entire that full completely chain, it is wobbling, and noise and everything, it is like a dam break, like that one they are happening. So Saram Vishweshraya and other technical team during 1940-41, they told that one, no, you have to operate with this through gantry crane only. Better to plug this one. We have the enough discharging capacity through 106, 103 level gates, and even plus 80 gates. The plus 80 gates is the major things. It has been total 1,30,000 cusecs it has been discharged at a time when all 16 gates has been opened. So that you can operate through these gates only like that they are told. Like that only our engineers also practice that's the reason. After that one, the drip has come. The drip has come, and in 2014, what's the things means? Hydrological safety is an important thing, and all this one modeling of the climate this one problem, and they have given design flood is varying, so that to keep all the things we should operate all the gates. So for that one only, even Roorkee engineers also they are the pioneers. They are in Tigra Dam. They are operating the same gates only. They are also telling that one, no sir, it is better go for it is keep it as an heritage structure. Better we go for a plan for the backside this one combined high system gates. So that like that only Central Water Commission and DRIP and our SPMU consultants are the major part in this one in field work. Whatever we have done, SPMU consultants, that is you have seen the videos, Shuprasad sir and Chiloraj sir and Madhav sir, and they are the seeing that one how best design we can work out with this CWC, and we have made it. And our project, our Kaveri Neeravari Nigama full total entire WRD team, we have struggle like anything sir for this one. What is the thing? This is a only simple thing, 2 minutes you have seen, but it's the last of 8 years struggle for this one complete gates. See, one stone or one it has been removed means it is a lot of sentiment in India. This is not the dam. This is the sentimental dam. We can't. KRS dam is a different type of dam. So that we have taken all the care regarding in this one, and we have put as a monumental stage. And in upcoming, this gates model has been constructed in the KRS dam for the future some generation. We have put the crane also there only. Crane, whatever the crane dismantle, it has been putting there only. We will 3 types of old gates, how it is working, everything will be kept in the this one in KRS dam site only, sir. Thank you, sir.
Thank you.
If there, yeah, please.
The question is to session chair. Is there any benchmark that demonstrates the long-term performance of the rehabilitated dams? That is question 1. Question 2 is again related to the KRS. 136 sluice gates have been replaced. That's a very good achievement. But is there any reliability or risk-based assessment done to quantify the extended service life of these 136 service gates? Because we want to know how long it has been increased, the service life has increased. Thank you so much.
Yeah, very 2 pertinent questions here. Now, when I was speaking, because of paucity of time, I said that performance criteria should be really defining what is your objective for the rehabilitation. Now, really, it's short term, long term. Now, if you really have to specify, suppose you have a concrete masonry dam or so, it's a concrete structure, for example. There are a lot of papers and literatures available which say that by doing this, we can enhance the life of this concrete structure by this many years. So, as such, we don't have any codal, we can't go for a codal provisions onto this, but at least we have quite many literature studies done on this, which says that by doing this in a concrete repair, there's a lot of literature on concrete repair systems and all. If you really go, and it also talks of compatibility in concrete repairs. So if you go by that, you have quite a good amount of information which has to be brought into our dam ecosystem now. So similarly, we have to see on the embankment dam other areas. That is part 1 of the question. Part 2 of the question, I think Mr. Kishore Kumar would like to answer.
Sir, hydromechanical component is based on the maintenance, sir. See, the gates will be well maintained. It will be well. It will be the age will be improved. That painting, it's O&M manual, everybody, you have got in the dams. So that painting and greasing, oiling, everything. And also, our dam is, we don't have any stop lock gates. That is also one problem is there. So next coming in the phase 3, we have to plan for the stop lock gates. Next, what is the thing means we have problem for only 90 days for the these floodgates can be removed. So the level will be depleted so that in that time only, when it is monsoon, when it is emergency, it is very difficult to operate. But during in 2011 and 2014, the plus 80 gates has been in state grant only. They have removed with this one bulkhead gates. They are making backside bulkhead gates and they have made it. So these are the challenges and faced by the engineers so that we have planned for the only first in this one 136 gates. Later, these gates should be monitoring, and every 3 months, every year, we have to check, and we have to whatever the pre-monsoon, post-monsoon, like checking is the same thing we will do, and we have to kept in order so that it will be life to at least 25-30 years for the mild steel. See, before it is cast iron gates. Cast iron gates is compression is very good, but shear is problem. Yeah, so the immersed in water, so that one corrosion will be less. But in the mild steel, the corrosion will be more. So that it should be get to be treated with the bituminous or painting, and all these things should be taken care. Otherwise, the corroded and everything will be problem. The basic problem in our engineers, this one is, we'll do the work, but maintenance is the problem. So we have to keep on agreement with the maintenance. For in this also hardware tools and who have done the work, 5 years of maintenance we are kept. So that we have to extend the maintenance, we have to keep on maintaining the things. It will be good for the age-old dams and gates and everything, sir. Thank you for this one.
I think it was quite interacting. Now I give the floor to hand over to Dr. Chitra for summing up the whole session.
Good morning, everyone. I'm coming in between your break time with the tea or coffee, but bear with me for 3 minutes to 5 minutes. Yeah, this is a very interesting session on aging dams and the state of art rehabilitation practices. It's a topic that is increasingly important for infrastructure safety and sustainable water management, not only in India, it's a very hot topic in globally. But that shows the number of audience here. It is full packed, spreaded all over this big auditorium. That shows the importance of this. Aging dams, in engineering dams, what it means that the dams are entering the later stages of life, later their design's life. And with the rehabilitation, how much life you are going to extend it effectively. So the terms of ages comes with the several challenges also. With the concrete may crack, reinforcements may corrode, embankment dams may have seepage problems, internal erosion, and flood. History of flood may be enhanced during these many ages have passed. And seismic data or the flood data, it must have been enhanced. That may pose problem, which are all has the problem of you have to look into and then you have to see it. Now coming to the state of art rehabilitation practices, you may have to rehabilitate structural strengthening techniques you may use, seepage control methods you can use, and hydraulic and capacity enhancement you can do, and risk-based dam safety management can also do. Considering these facts, the session has had 6 papers. First started with the chairman himself, compatibility-driven rehabilitation for ensuring resilience in aging of structures. He has talked about compatibility comes with the durability. If you have compatibility will be governing the factor for any rehabilitation, better rehabilitation. Compatibility must be ensured for the durability of the rehabilitated structure. The second one is on innovative solutions to dam rehabilitation. Many case studies he has presented all over the countries, many countries. He started with Malawi project and many of the projects from USA. And the project which he has shown about Glen Canyon project, which I have also visited when I visited USA. And all of this, majority of these projects were rehabilitated because of the storage capacity and reservoir incapability also. And they were having the problem of spillway and rehabilitated with gates also. And he has showed the challenges of rehabilitation on operational reservoirs, safety constraint also. And he has insisted on records and quality monitoring also, which I also insist for many of the new projects as well as the rehabilitated projects also. And the third speaker has talked about Kariba Dam, which was very old dam, which had the problem of erosive spillway and problem of fault zones in the upstream area. And he has emphasized on the challenges and treatment. And he has ended up with the lessons for aging dams rehabilitation, which is a very good takeaway for all of us. And it's a very good challenges, how he has emphasized on what is the challenges you make upon when you are going for the treatment with the contractors as well, which was emphasized by the last speaker, by the SMEC also, who has talked about the rehabilitation of dam structural approach. And the fourth speaker from my organization, CSMRS, he has talked about the Rockfill dams, which is very for constructing the pumped storage projects, testing of Rockfill dams and maintenance of the quality control and quality assurance. He has showed upon the importance of it. Very interesting projects. And he has emphasized on what is the importance of having a trial embankment and the quality control also. And the fifth speaker has talked about the rehabilitation of 136 sluice gates with the SCADA system integration at Krishna Sagar Dam under the DEEP project. Very interesting one. There are many questions, and two interesting questions were asked by the last questioner, gentleman, and which was very opening the eyes of it. And the sixth, all these five speakers have shown their case histories and the slides with a lot of photographical presentation and videos also. And the videos which caught our eyes is by the Krishna Sagar Dam. Thanks to you for giving us the entire system, how it was rehabilitated. And the sixth presentation was on rehabilitation of dams, structural approach by SMEC, Mr. Sasinder. And he has talked about the structural, how you have to approach the rehabilitation of dams, aging dams, structurally. And he has talked about starting in stages you have to plan, and planning, preparation, assessment of problem, and how you are going to implementation on what all the problems you will be encountering with the contractors, and the total rehabilitation, how it can be approached, achieved by doing the structural approach. So it was a very important topic and an important session, and which was completed, started very late and completed in time. I think the time given was 1 hour, 1.5 hours. We could able to complete it thing. And I thank all the audience to be present here till the last minute. Thank you so much. I thank the organizers giving me the opportunity also. Thank you, one and all.
Thank you so much, ma'am. Now, ladies and gentlemen, please put your hands together as I welcome D.S. Cheskar sir, Chief Engineer at National Water Academy, Central Water Commission, Pune. Please welcome sir with a huge round of applause. So, ladies and gentlemen, it's time to give away token of gratitude for all our speakers and chairperson. Firstly, to start off with, I request Dr. J. Chandrasekhar Iyer sir, former chairman CWC, to please step forward and please collect our honor. Please give a huge round of applause. Next, I would like to welcome Mr. Thomas sir to please step forward and do accept our honor. Thank you so much for joining us, gentlemen. Mr. Britius, please do join us, sir. Thank you so much for joining. Ladies and gentlemen, please give a huge round of applause. Next, I request Mr. Uday Banu Chakraborty, sir, to please join us. ಜೋರಾಗಿ ಚಪ್ಪಾಳೆ ಬರಬೇಕು. I request Mr. Kishore Kumar, sir, to please join us. Thank you so much, sir, for joining. And I also request Janendra Kardam, sir, to please join us. ಜೋರಾಗಿ ಚಪ್ಪಾಳೆ ಬರ್ಬೋದು. And now, ladies and gentlemen, the lady, Dr. R. Chitra ma'am, please join us, ma'am. It's time to honor Chitra ma'am. Thank you so much, ma'am, for summarizing it so well. And not to forget our session in charge, Mr. Manish Rathod. I request Manish Rathod, sir, to please join us. Director, HCD, NWNS, CWC. Thank you so much, gentlemen. Thank you so much, ma'am, for giving us such a wonderful session. And ladies and gentlemen, our next session is equally interesting. That is on sediment management and reservoir. Hydrological safety of dams and coordinated operation. So please do join us. Okay, I think I missed something. I'm really sorry. I'll be back again. So let's take a quick tea break. Then that's when the systems work properly. 15 minutes. I request everybody to please join us back. Thank you so much, ladies and gentlemen. Looking forward to have you guys again for yet another interesting session. I request everybody to please do join us back in next 15 minutes. Thank you.
India is a country rich in water resources. But its rivers and groundwater resources are under great threat. Rapid economic development, intensive water use in agriculture, continuous growing population, and increasing urbanization are pushing the water demand, which is creating a problem of scarcity. Compounding this, the discharge of untreated wastewater is deteriorating the quality of our river water. Our life and our economy are totally dependent on water. If no steps are taken, demand for potable water will soon outstrip supply. In India, many states are facing drought. and 12% of the country is affected by floods. Nearly 600 million Indians face high to extreme water stress, and about 2 lakh people die every year due to inadequate access to safe water. Based on the National Commission on Integrated Water Resources Development report, per capita water availability in India is reducing continuously. Between 2001 and 2011, the average volume of water available to a person per year has decreased from 1,820 cubic meters to 1,545 cubic meters. If this trend continues, by 2050, only 1,140 cubic meters will be available for each of us. The National Hydrology Project is aimed towards providing a solution addressing this scenario. With the total outlay of 3,640 crore rupees, spans over a period of 8 years. NHP is a central government scheme implemented by the Department of Water Resources, River Development and Ganga Rejuvenation, a part of the Ministry of Jal Shakti. The project development objective of NHP is to improve the extent, quality, and accessibility of targeted water resources information and to strengthen the capacity of targeted water resources management institutions in India. This is being achieved through 4 project components. Hydrometeorological stations are being installed nationwide to measure water level of rivers, reservoirs, groundwater levels, precipitation, weather parameters such as temperature, wind speed, humidity, etc. at various locations. In data centers, all information is verified, stored, validated and made available for use by water managers, designers, users and researchers. Through web-based database and information system, India Water Resources Information System, non-classified data is made available to the general public. As repository of countrywide water data, an organization named National Water Informatics Center has already been established. Under the Advanced Decision Support System, in dry periods, better decisions can be taken as to how the available water can be used. During flood periods, forecasting system with improved lead time accessible to various stakeholders is proposed to be developed. Institutional capacity building. More than 175 training courses, including 15 international training, have already been conducted under NHP, which was attended by nearly 4,000 participants. National Hydrology Project will facilitate us to know our water resources better and provide the tools for informed decisions to improve the management of water in India. National Hydrology Project, an initiative of the Government of India.
कभी आपने सोचा है कि हमें कुओं से मिलने वाला पानी कहां से आता है? इसे जानने के लिए आइए देखते हैं किस प्रकार जमीन के नीचे चट्टानों की संरचना होती है। जमीन के नीचे आमतौर पर चट्टानें एक दूसरे के ऊपर कई परतों में मौजूद होती हैं। इनमें से कुछ चट्टानों में खुली जगह होती है जिसे छिद्र या पोर्स कहा जाता है और इन छिद्रों में पानी भरा हो सकता है। इस तरह चट्टानों की इकाइयों को जिनमें पानी से भरे छिद्र होते हैं और जिनसे पानी की आपूर्ति की जा सकती है, उन्हें जलभृत यानी एक्वीफर कहा जाता है। इस चित्र में नीले रंग की परतें एक्वीफर दर्शाती हैं। कुओं का निर्माण कुछ इस तरह किया जाता है कि उन्हें इन एक्वीफर से पानी मिलता रहता है। ये संभव है कि कुछ एक्वीफर्स में पानी ताज़ा हो, और अन्य कुछ में पानी खारा। इसके साथ ही ये जरूरी नहीं कि हमेशा एक्वीफर हॉरिजॉन्टल हो, वे कुछ इस तरह झुके हुए भी हो सकते हैं। इसी पृष्ठभूमि में 6 प्रमुख उद्देश्यों के साथ नेशनल एक्वीफर मैपिंग एंड मैनेजमेंट प्रोग्राम यानी नेक्विम की शुरुआत की गई है। पहला, एक्वीफर्स के हॉरिजॉन्टल और वर्टिकल क्षेत्र को चित्रित करना। दूसरा, एक्वीफर्स में पानी के घटित होने और उनकी गतिविधि को नियंत्रित करने वाले गुणधर्मों का मूल्यांकन करना। तीसरा, पानी की रासायनिक गुणवत्ता और उपयोग के लिए इसकी उपयुक्तता का आंकलन करना। चौथा, विभिन्न रिचार्ज और डिस्चार्ज घटकों का अनुमान लगाना। पांचवां, परिमाण निर्धारित करने वाले विषयों की पहचान करना। और छठा, एक्वीफर मैनेजमेंट प्लान तैयार करना। इस तरह तैयार किए गए मैनेजमेंट प्लान्स को राज्य सरकारों और जमीनी स्तर पर स्टेक होल्डर्स के साथ साझा किया जाता है। एक्वीफर्स को चित्रित और विशेषताओं की पहचान करने के लिए विभिन्न वैज्ञानिक साधनों और तकनीकों का इस्तेमाल किया जाता है। हाइड्रोजियोलॉजिकल मैपिंग से हमें एक्वीफर के क्षेत्र के बारे में जानकारी मिलती है। जियोफिजिकल इन्वेस्टिगेशन से सतह के नीचे एक्वीफर्स की स्थिति के बारे में इनडायरेक्ट इंफॉर्मेशन मिलती है। खुदाई की सहायता से किए जाने वाले भू अन्वेषण से एक्वीफर्स की गहराई संबंधी क्षेत्र और गुणधर्मों की बहुत सी डायरेक्ट इंफॉर्मेशन मिलती है। एक्वीफर्स के भंडारण और संचारण क्षमताओं के बारे में पता लगाने के लिए पंपिंग परीक्षण किए जाते हैं। प्रयोगशालाओं में रासायनिक गुणवत्ता का मूल्यांकन किया जाता है। पीजोमीटर के माध्यम से वाटर लेवल का मापन किया जाता है। 3D एक्वीफर मॉडल तैयार करने, एक्वीफर्स की विशेषताओं का चित्रण, पानी की गुणवत्ता का अनुमान लगाने और एक्वीफर में प्रवेश करने वाले और बाहर निकलने वाले पानी की मात्रा का आंकलन करने के लिए इन सभी जानकारियों को संकलित किया जाता है। मैनेजमेंट स्ट्रेटेजी के 2 बुनियादी पहलू हैं। पहला है सप्लाई मैनेजमेंट यानी भूजल संसाधनों का संवर्धन करना। इसे आर्टिफिशियल रिचार्ज या परकोलेशन टैंक, रिचार्ज शाफ्ट, चेक डैम या इसी तरह की स्ट्रक्चर्स के निर्माण द्वारा मैनेज्ड एक्वीफर रिचार्ज के माध्यम से हासिल किया जा सकता है। दूसरी रणनीति है डिमांड मैनेजमेंट या इसके उपयोग में कटौती करना। इसे स्प्रिंकलर जैसी माइक्रो इरिगेशन टेक्निक के इस्तेमाल या कम पानी की आवश्यकताओं वाली फसलों की खेती अपनाने के माध्यम से इरिगेशन एफिशिएंसी के सुधार द्वारा हासिल किया जा सकता है। एक्वीफर्स के गुणधर्म और अन्य स्थितियों के आधार पर आपूर्ति और इसके साथ ही मांग, इन दोनों से जुड़े उपाय नाक्विम के एक भाग के तहत सिफारिश की गई मैनेजमेंट स्ट्रेटेजी में शामिल है। अंतिम कदम है निष्कर्षों, नक्शों और मैनेजमेंट प्लान्स को आम लोगों तक लेकर जाना। CGWD की वेबसाइट के माध्यम से निष्कर्षों को रिपोर्ट्स के जरिए और अन्य रूप में साझा किया जाता है। इस तरह तैयार किए गए नक्शे और मैनेजमेंट प्लान्स राज्य भूमि जल समन्वय समितियों के माध्यम से राज्य सरकारों के साथ साझा किए जाते हैं। जमीनी स्तर पर भूजल के उपयोगकर्ताओं तक पहुंचने के लिए CGWD की ओर से ब्लॉक स्तर पर परीक्षण कार्यक्रम और सार्वजनिक संवाद कार्यक्रम आयोजित किए जाते हैं। अब तक पूरे किए गए अध्ययनों ने ग्राउंड वाटर सिनेरियो और प्रबंधन विकल्पों के संबंध में अनेक नई गहन जानकारियां उपलब्ध करवाई हैं। नाक्विम प्रोग्राम ज्ञान संबंधी कमियों को दूर करते हुए और देश में ग्राउंड वाटर रिसोर्सेज के सस्टेनेबल मैनेजमेंट के लिए उपयोगी जानकारी के साथ स्टेक होल्डर्स को सक्षम बनाने में सहायता कर रहा है। चेन्नई के पश्चिम में स्थित कोयम्बटूर जिले को वालपराई हिल स्टेशन, उकड़म झील, कोवई कुतरलम वाटरफॉल जैसे प्राकृतिक सौंदर्यों का आशीर्वाद प्राप्त है। इसके साथ ही ये कई मंदिरों और प्रसिद्ध आदि योगी मूर्ति के लिए भी जाना जाता है। आर्थिक रूप से ये देश के सबसे प्रगतिशील जिलों में से एक है और कृषि यहाँ की अर्थव्यवस्था का काफी बड़ा हिस्सा है। मक्का, चोलम, नारियल, केला, चावल और गन्ना इस जिले में उगाई जाने वाली कुछ मुख्य फसलें हैं। सामान्य रूप से इस जिले में लगभग 500 मिलीमीटर बारिश होती है। यह जिला बहुत बड़े पैमाने पर भूजल पर निर्भर करता है। तमिलनाडु सरकार के डिस्ट्रिक्ट स्टैटिस्टिकल हैंडबुक के अनुसार कुल सिंचाई आवश्यकताओं के 85% की आपूर्ति भूजल से होती है। एक्वीफर्स, जो भूजल के स्रोत हैं, उन पर बहुत ज्यादा दबाव है। जिले का एक्वीफर सिस्टम अमरावती एक्वीफर सिस्टम का एक हिस्सा है, जो तमिलनाडु के पश्चिमी क्षेत्र में पीने के पानी और सिंचाई के लिए ताजे पानी का सबसे महत्वपूर्ण स्रोत है। CGWB ने एक्वीफर को जाने और एक्वीफर का प्रबंध करें, इस उद्देश्य के साथ नेशनल एक्वीफर मैपिंग एंड मैनेजमेंट प्रोग्राम के एक भाग के तहत इस इलाके में एक विस्तृत एक्वीफर मैपिंग का कार्य शुरू किया है। जिले का ज्यादातर हिस्सा ग्रेनाइट की चट्टानों से भरा है, जो बेहद सीमित भूजल क्षमताओं वाली कठोर चट्टानें होती हैं। एक्वीफर मैपिंग अध्ययन से 2 एक्वीफर सिस्टम की मौजूदगी के बारे में जानकारी मिली। पहले एक्वीफर का क्षेत्र जमीनी स्तर से 7 से 45 मीटर तक की गहराई में है। पहला एक्वीफर विखंडित ग्रेनाइट चट्टानों के रूप में है। इसके नीचे 11 से 200 मीटर तक की गहराई की सीमा में दूसरे एक्वीफर की पहचान की गई है। इस सीमा में पानी धारण करने वाले 4 फ्रैक्चर जोन तक का सामना होता है। यहाँ ऐसी भी कई जगहें हैं जहाँ फ्रैक्चर्ड एक्वीफर सिस्टम मौजूद नहीं है और भूजल केवल सबसे ऊपरी विखंडित परत में ही पाया जाता है। करीब 70,000 एब्स्ट्रैक्शन स्ट्रक्चर्स के साथ, जिनमें ओपन डगवेल्स और बोरवेल्स शामिल हैं, इन एक्वीफर से बहुत बड़ी मात्रा में पंप की सहायता से पानी निकाला जाता है। हर साल करीब 365 मिलियन क्यूबिक मीटर का पानी बारिश और अन्य स्रोतों से रिचार्ज किया जाता है, जबकि 450 मिलियन क्यूबिक मीटर जितना उच्च मात्रा में पानी एक्वीफर से बाहर निकाला जाता है, जो वार्षिक रूप से होने वाले रिचार्ज से कहीं ज्यादा है और इसका अतिदोहन होता है। नाक्विम अध्ययन के एक भाग के तहत एक्वीफर कॉन्फ़िगरेशंस, उनके गुणधर्मों और अन्य कारकों के आधार पर एक मैनेजमेंट प्लान तैयार किया गया है, जिसमें विभिन्न मांगों से संबंधित उपाय जैसे वाटर एफिशिएंट इरिगेशन टेक्निक, कम पानी का इस्तेमाल करने वाली फसलों की खेती और आपूर्ति से संबंधित उपाय जैसे आर्टिफिशियल रिचार्ज स्ट्रक्चर का निर्माण शामिल है। आपूर्ति से संबंधित उपायों के एक भाग के तहत नाक्विम अध्ययन में 155 बंड्स का निर्माण, 220 तालाबों का नवीनीकरण और जिले में 16 से ज्यादा ब्लॉक्स में 716 रिचार्ज शाफ्ट्स के निर्माण की सिफारिश की गई है। सिफारिश किए गए स्थलों की विस्तृत जगहों और डिजाइन की जानकारी डिस्ट्रिक्ट रूरल डेवलपमेंट एजेंसी कोयम्बटूर को सौंप दी गई है। डिस्ट्रिक्ट रूरल डेवलपमेंट एजेंसी कोयम्बटूर ने जल शक्ति अभियान कार्यक्रम के अंतर्गत आर्टिफिशियल रिचार्ज स्ट्रक्चर के निर्माण के लिए नाक्विम अध्ययन की सिफारिशों को लागू किया गया है। गैबियन डैम, रिचार्ज शाफ्ट के साथ गैबियन डैम और चेक डैम जैसे स्ट्रक्चर्स का निर्माण किया गया है। मादमपट्टी फिरका के थट्टीपलयम गांव में गांव के पुराने तालाबों को इस तरह नवीनीकृत किया गया है। बेकार पड़े बोरवेल्स जिनमें पानी निकाला जाता था, उन्हें रिचार्ज स्ट्रक्चर में बदल दिया गया है। इन उपायों से साफ तौर पर जल स्तर में वृद्धि और कुओं की संवहनीयता में सुधार देखा गया है। एक्वीफर्स की बेहतर समझ से किफायती और सक्षम रिचार्ज इंटरवेंशंस की योजनाबंदी और कार्यान्वयन में मदद मिल रही है। एक्वीफर्स से सुरक्षित पीने का पानी सुनिश्चित करने में भूजल दूषण सबसे बड़ी चुनौती बनकर उभरी है। सतही जल स्रोतों और खुदाई कूप में रोगजनक दूषण से निपटने के लिए हैंडपंप और बोरवेल को पीने के पानी के सुरक्षित स्रोत के रूप में बड़े पैमाने पर प्रचारित किया गया था। हालांकि लोह, खारापन, नाइट्रेट, आर्सेनिक और फ्लोराइड इत्यादि जैसे भूगर्भीय प्रदूषकों के सामने आने से नई चुनौतियां खड़ी हो गई हैं। इस वीडियो में हम भारत में भूजल में आर्सेनिक की उच्च मात्रा पाए जाने की घटनाओं और आर्सेनिक दूषण के इलाज में CGWB के कार्यक्रमों के बारे में चर्चा करेंगे। प्राकृतिक रूप से आर्सेनिक भूजल में पाया जाता है, लेकिन केवल एक सूक्ष्म मात्रिक घटक के तौर पर। जब पीने के पानी में इसकी सघनता एक निश्चित सीमा से ज्यादा हो जाती है, तो इसके कारण सेहत पर कई विपरीत परिणाम होते हैं। भारतीय मानक ब्यूरो के अनुसार और इसके साथ ही विश्व स्वास्थ्य संगठन के मानकों के अनुसार आर्सेनिक के लिए सुरक्षित स्तर है 10 पार्ट्स पर बिलियन, यानी पीने हेतु पानी को योग्य होने के लिए 100 लीटर पानी में आर्सेनिक की मात्रा 1 मिलीग्राम से भी कम होनी चाहिए। आर्सेनिक से दूषित पीने के पानी के लंबे समय तक संपर्क में रहने से गैस्ट्रोइंटेस्टाइनल बीमारियां, कार्डियोवैस्कुलर रोग और कैंसर भी हो सकता है। हालांकि इसका सबसे सामान्य असर है त्वचा पर हाइपर पिगमेंटेशन और कैरेटोसिस। CGWB द्वारा किए गए अध्ययन के अनुसार 21 राज्यों के 152 जिलों के कुछ भागों में आर्सेनिक पाया गया है और लगभग 4 करोड़ लोग आर्सेनिक दूषण के खतरे वाले क्षेत्र में रहते हैं। हालांकि इसे नोट करना महत्वपूर्ण है कि एक प्रभावित जिले में सभी ब्लॉक्स प्रभावित नहीं हैं। एक प्रभावित ब्लॉक में सभी गांव प्रभावित नहीं हैं। एक प्रभावित गांव में सभी बोरवेल या स्रोत प्रभावित नहीं हैं। भारत में सबसे बड़े भूजल आर्सेनिक की उच्च मात्रा गंगा के समतल क्षेत्रों में है। इस हिस्से में 6 राज्यों के करीब 66 जिलों में आर्सेनिक दूषण दर्ज किया गया है। ये राज्य हैं पश्चिम बंगाल, उत्तर प्रदेश, बिहार, झारखंड, हरियाणा और दिल्ली। हाल ही में की गई एक्वीफर मैपिंग स्टडीज ने इन क्षेत्रों में अनेक एक्वीफर्स को चित्रांकित करने में सहायता की है और आमतौर पर गहराई में मौजूद एक्वीफर्स आर्सेनिक से सुरक्षित होते हैं। यह एक प्रतीकात्मक चित्र है जो ये दिखाता है कि आर्सेनिक की उच्च सघनता के साथ ऊपरी एक्वीफर गहराई में मौजूद आर्सेनिक सुरक्षित एक्वीफर से कुछ इस प्रकार एक मोटी मिट्टी की परत द्वारा अलग किए गए होते हैं, जिसके कारण इन दोनों एक्वीफर्स का आपस में मिश्रण नहीं होता। इसका मतलब है यदि हम एक ऐसे कुएं का निर्माण करें जो एक गहरे एक्वीफर से पानी प्राप्त करता है और उथले एक्वीफर्स में मौजूद आर्सेनिक दूषित एक्वीफर को कुएं में प्रवेश नहीं करने देता है, तो हम ऐसे कुएं से भी प्रदूषण मुक्त पीने का पानी सुनिश्चित कर सकते हैं। CGWB ने कुएं के भीतर ही सीमेंट की सीलिंग इस्तेमाल करने की तकनीक की शुरुआत की, जिससे आर्सेनिक सुरक्षित पानी उपलब्ध हो सके। इस तकनीक में पहले एक पायलट छिद्र ड्रिल किया जाता है। इसके बाद कुएं में करीब 6 इंच डायमीटर का वेल असेंबली नामक पाइप नीचे उतारा जाता है। इस वेल असेंबली में केवल एक विशिष्ट जगह पर ही छेद किया होता है, जिससे छिद्र आर्सेनिक सुरक्षित पानी रिलीज करने वाले एक्वीफर्स के सामने रखा जाता है। वेल असेंबली और कुएं के बीच की दीवार की गोल जगह को कंकर से भर दिया जाता है और उचित गहराई में सीमेंट के घोल को डाला जाता है, जो ठोस रूप ले लेता है और आर्सेनिक दूषित पानी को उस जगह तक पहुंचने से रोकता है जहां से पानी कुएं में प्रवेश करता है। इस प्रकार जो पानी कुएं से निकाला जाता है वो गहराई में मौजूद एक्वीफर से प्राप्त होता है और आर्सेनिक से सुरक्षित होता है। ये ध्यान में रखना महत्वपूर्ण है कि ऐसी सीमेंट सीलिंग पर्याप्त नहीं है। दूषित एक्वीफर की तुलना में आर्सेनिक सुरक्षित एक्वीफर में पानी का स्तर ज्यादा ऊंचा बनाए रखने के लिए पंपिंग का दर नियंत्रित करना भी महत्वपूर्ण है, ताकि दूषित एक्वीफर से पानी गहरे एक्वीफर या आर्सेनिक सुरक्षित एक्वीफर की तरफ ना बहे। इस डिजाइन का इस्तेमाल करते हुए CGWB ने बिहार, उत्तर प्रदेश और पश्चिम बंगाल के भागों में करीब 600 कुओं का निर्माण किया है। उत्तर प्रदेश और पश्चिम बंगाल के राज्य सरकारों ने सीमेंट सीलिंग के साथ ऐसे करीब 1500 कुओं का निर्माण किया है, जो लगभग 70 लाख लोगों के लिए सुरक्षित पीने के पानी की जरूरत को पूरा कर रहे हैं। एक्वीफर मैपिंग एक्वीफर्स को बेहतर तरीके से समझने में मदद करता है और कई समस्याओं के लिए इनोवेशन सॉल्यूशंस पेश करता है।
Central Water Commission presents Floodplain benefits and need for its restoration. What are floodplains? Floodplains form an integral part of our ecosystem. A river is mainly confined to its main channel, but as the water level rises, the river spreads laterally and forms its own floodplains. They therefore provide the space for rivers to spread their waters during high stages. Why is floodplain important? Its benefits. Floodplain is vital for the health of our environment. They are our natural capital assets that provide invaluable functions for our communities and riverine ecosystem. They contribute significantly in the social and economic growth of a country. Benefits of healthy floodplain. Natural defense against flood hazard. The graph shows the effect of healthy floodplain on peak water level in a river. Floodplains act as natural water storage structures and dampen the peak discharge and water levels during high floods. Water filtration and groundwater recharge. Healthy and wide floodplains allow large-scale infiltration and contribute significantly towards increasing the groundwater levels in the surrounding area. Sediment retention. Floodplain becomes favorable site for deposition of nutrient-rich sediments during floods. It gives enhanced fertile farmlands to the people living nearby. Sustaining natural habitat for plants and animals. Flourishing floodplains are rich in flora and fauna, and form an healthy ecosystem. Social and cultural values of people. Floodplains are the lifeline to many. They improve the quality of life by providing ample recreational and economic opportunities to people. How are we damaging our floodplains? Rapid growth in urbanization has caused unplanned construction and encroachment on our riverbeds. Dumping of solid waste material from industry.
Operation of reservoirs for flood management. I request everybody to please join us back.
Which includes 7.7 TMC of dead storage. 3 river sluices have also been provided to dispose of effectively 502.3 cumecs of water to meet the requirement of the downstream riparian states during the times of distress. The project is located at about 1.8 kilometers downstream of the Kaveri and Arkavati confluence, Sangam. The dam will not affect the historical Mekedatu site as it is proposed at about 1.8 kilometers upstream of the same. The entire submergence involved in the project, including connected infrastructure, totals to approximately 5,252.4 hectares, which falls within the geographical boundaries of the state of Karnataka. The estimated total cost of the project as per the schedule of rates of 2018 and 19 is 9,000 crores. On completion of the project, Karnataka will be benefited in terms of utilizing their share of drinking water and also generating nearly 400 megawatts of power from the release of water downstream into Tamil Nadu. Government of Karnataka had submitted a detailed feasibility report to Central Water Commission (CWC), and the same was reviewed and directions were given to submit detailed project report (DPR). The Government of Karnataka has initiated the due process of formulation of DPR in consonance with the directives of the Central Water Commission.
The International Center of Excellence
Okay, done, sir. Sir, ladies and gentlemen, I request everybody to please be seated. We are all set to start off with one more interesting session, hydrological safety of dams and coordinated operation of reservoirs for flood management. So ladies and gentlemen, the chairperson for this technical session would be Ms. Eileen Burke, Global Lead for Water Resources, World Bank. So ladies and gentlemen, not only the resource specialist is also the global lead for water resources at World Bank. Ms. Eileen co-led the global study on what the future has in store, a new paradigm for water storage. She also leads the bank's global solutions group of water resource management, including working with the World Bank team globally to improve the impact of water resources and lending activities in the bank's $24 billion water lending pipeline. Welcome, ma'am. Ladies and gentlemen, can we have a huge round of applause for our chairperson, Ms. Eileen? Next, ladies and gentlemen, it's time for me to introduce our co-chair for the session, Shri K.G. Mahesh sir, who is the Chief Engineer and Director of Karnataka Engineering Research Station, with over 30 years of experience in the water resource sector, specializing in irrigation development, water management, and infrastructure modernization. Sir has successfully led major projects like Hipparagi, Karanj project canal system and SCADA-based automation systems under the Upper Krishna project. So, welcome, sir. Next, ladies and gentlemen, please put your hands together as I introduce our speakers, Mr. Rakesh Kashyap, Chief Engineer, Dam Safety Organization and Project Director, DRIP 2 and 3, Central Water Commission, DOWR, RD and GR, Ministry of Jal Shakti. Sir is a distinguished Central Water Engineering Service Officer with over 30 years of experience. Sir currently serves as the Chief Engineer of the Dam Safety Organization and Project Director for DRIP 2 and 3. Since 2023, Sir has headed the Central Project Management Unit for the world's largest dam rehabilitation program, a World Bank and AIIB supported initiative spanning 19 states and 3 central implementing agencies. Ladies and gentlemen, next in line, we have our next speaker, Professor Mohammad Razmi, Senior Researcher, who's also a water resources researcher affiliated with the International Center for Water Hazard and Risk Management in Japan. Sir's work focuses on flood risk management, reservoir operation, climate adaptation, and the application of ensemble hydrological forecasting for water-related disaster management. Sir integrates hydrological modeling, remote sensing, and optimization techniques to support evidence-based decision-making for resilient water infrastructure and disaster risk reduction. Next, ladies and gentlemen, it's time for me to introduce our next speaker, who's really very sweet. He came to me and he told my name pronunciation is this. And he told, how you call Nasha in Hindi, that is what my name is. So please put your hands together as I welcome Dr. Nasha, who is a senior hydrologist and water resources engineer with over 30 years of experience specializing in hydrology and optimal reservoir operations in complex river basins. Sir holds a PhD in civil engineering from the University of Manitoba and has received numerous academic and professional awards, including recognition for his contributions to the Yellow River Basin Management Project in China. I would still call you Nasha only, sir. You're a different vibe overall. Come on, ladies and gentlemen, please give it up for Dr. Nasha. Next, ladies and gentlemen, we have Dr. Manikanta Velupuri, sir, who's a distinguished researcher currently serving as a DST Inspire faculty at the Interdisciplinary Center for Water Research, Indian Institute of Science, Bengaluru. Sir has earned his PhD in hydrology and water resources engineering from NIT Varangal in 2023, where his doctoral research focused on assessing hydrologic uncertainty and ensemble flood forecasting with a robust academic background, including an MTech from NIT Varangal and BTech from RGUKT. His professional journey spans roles as an institute postdoctoral fellow at IIT Hyderabad and CAT modeling analyst at Accenture. Welcome, sir. Next, ladies and gentlemen, we have Mr. Teju Kumar, who's a dedicated assistant engineer with the Water Resources Department, Government of Karnataka, currently serving at an advanced center for integrated water resource management since 2016, an alumnus of Indian Institute of Science. From here only, sir is a alumni, Bengaluru, and he holds a master degree in civil engineering and brings a strong academic foundation to his technical role. Sir's expertise lies in hydrological modeling, remote sensing and development of Karnataka Water Resource Information System to enhance operational decision making. Welcome, sir. Next, we also have Dr. Shashi Kumar sir, who is a water resource specialist at an advanced center for integrated water resources management, Karnataka, where sir has been working since 2019 and sir support the ACI WRM Water Resources Department in developing operational decision support systems, hydrological modeling frameworks and state scale water information systems, including the Karnataka Water Resources Information System. Sir's work focuses on water accounting, water productivity, reservoir operations, flood management, hydrological forecasting, and the application of hydrometeorological data for real-time water resource management. Welcome, sir. Please give a huge round of applause as we have our speakers, chair and co-chair. Our session in charge would be Shri Ravi Ranjan, Director, Hydrology, CWC. Over to you, sir. Over to Eileen, ma'am.
Hi, everyone. It's an honor to be with you again today. Whether you're an economist or an engineer, it seems like coordinated reservoir management is obvious, right? It's the best way to optimize the benefits from your infrastructure. Yet we all know it's far more complicated than it sounds, right? The coordination that needs to happen between different organizations to be able to get the data that you need to implement the models that you need, to calibrate them, to ground truth them, and then knowing what the downstream users need is yet another institutional, sometimes we call it a spaghetti diagram. The number of institutions that need to be involved across is incredibly complicated. And so it's a major obstacle to actually coordinating reservoir operations. This is why in one of our earlier publications from the World Bank, What the Future Has in Store, we did case studies not of what you do to integrate reservoir operations, but how you do it. Looking at the models that you employ, the data that you need, but also the processes that you need to run between governmental organizations, the partnerships with universities, to be able to implement the coordinated reservoir operations. So I am incredibly excited to be here today to hear from this esteemed panel. I'm going to be very short because we want to leave time to hear from their expertise. But what I'm hoping is that we can get from today is really hearing what's preventing some of this integrated work from going into effect. Some of the reasons why some of this integrated modeling is having trouble moving actually into implementation. I think one of the things that we've seen through the NHP, the National Hydrology Project, which did a lot of the analytical work that we've been hearing about today, as well as the DRIP project, is that it really has used the government's immense technical talent and created connections, new analysis and connections across offices to be able to implement a more robust dam safety program. And I think as we're moving forward with the next additional financing in the DRIP project, as we're moving forward with a new phase of the National Hydrology Project, the bank is here as a partner and to help with facilitation, to make sure the data you're collecting, to make sure the problems that you're surfacing with your dams can be solved through integrated and coordinated reservoir operation. So with that, I ask you all, one of some of the best conversations I think I've heard during this conference so far have been about how we can solve some of the problems. Everyone's coming to the table with problems and proposed answers, and we're here to help you get to that last mile, to connect across offices, to put some of these solutions into practice. So with that, I'll hand back to our moderators so that we can get into the technical discussions. Thank you.
I welcome Sri Rakesh Kashyap, Chief Engineer DSO and Project Director DRIP for presentation. Thank you.
Thank you, Ravi. So, respected chair, co-chair, dignitary on the dais and the August gathering. In fact, I was getting goosebumps by seeing the timer here. It was 10 minutes. Now he told me to complete in 8 or 7 minutes. So, I think it's a tough task, but let me tell you that I'm trying to present some fresh work, means in terms of the themes of the lectures which have been there in the past few sessions. So, and moreover, I would say that it would be on the basis of pragmatism and some hope that where we have to work in case of some of the optimal solutions related to the reservoir management. So I'll be quickly going through. So it is about the integrated reservoir operations. And in fact, as chair of the session told that under NHP also some pilots were tried to be carried out, particularly in case of Damodar Valley Corporation and in case of Odisha for Ravi Shankar complex. But somehow those were not, could not be taken forward. But this time we are quite confident because now the states are fully on board for this initiative, and we are quite confident that this time we'll be able to carry forward this initiative in Krishna Basin. But it's a pilot only, but after the outcome of the project, I am quite hopeful that all the 4 states of the Krishna Basins, they'll be able to take up this initiative. And in fact, the structure of my presentation is like this, but presentation would be only a prop. I'll be discussing the issues otherwise. So, in fact, we know our problem that our dams, most of the dams, although we are having, we are the third in the world in terms of large number of dams, but very few reservoirs are having dedicated storage for moderating floods. Simultaneously, the climate change, the hydrometeorological unpredictabilities, they have complicated our situation. In that way, how to optimize our reservoir? Where is the hope? How to move forward under this initiative? For that, we will be discussing under this topic. And in fact, we do have a number of reservoirs. We are cascade in nature, and we all know that the basin is the actually it's the hydraulic unit which we need to take into account, and it is everywhere in our books, it is everywhere in our guidelines, but actually how to implement in the form of basin management and having the integrated reservoir operation, which is also an interdisciplinary subject. So what this time we have carried out, that earlier our focus was on through the consultants and also by having the references from our textbooks, from our guidelines, but we are not having the examples of successful implementation. So we said and we found that Japan is having this type of expertise available with us, where they are actually having the operational system. And yesterday, Professor Koike and from the Japan Water Agency, they have also highlighted their integrated reservoir operation in terms of having good forecast, inflow forecast, and based upon the dynamic rule curves, they are carrying forward this initiative.
So in that way, the key features basically are the basin level coordination for IRO, reliance on inflow forecasting. So these are some of the challenges also. These are the key features as well as challenges also which we need to take into account, as well as the other operational part of this, that is the administrative challenges we need to take into account. So once we talk of IRO, so importance, I think everybody is well aware of the importance of IRO, so I need not to stress that why it is required. But yes, why it is required, particularly in case of need for India, these are the aspects that in case of India, we know that floods are the major cause of all disaster, cause for the disaster. In case of the natural events, I should say, I'll not go into that. Man-made floods are also there. That is a separate topic, but otherwise floods are at the top. Then we have having the number of rainfall extremities increasing, then the population at risk due to population density of our country, then dependency on agriculture. So these are the factors which basically lead us to seriously think into this aspect, that why we should go for the integrated reservoir operation. And what is the Japan's way? Because I am talking of the example of Japan. So it's not that they are having complexities less than India. They are having more complexities, I should say. But still they are able to manage. Of course, one is that they have a very good river law, which give them the support in terms of institutional arrangement and all those things, but which maybe we are not having that. But in our case, I should say that our intent to do that is more important. If we have the intent, so will we definitely overcome this. So in that way, we can follow the initiatives which have been taken by Japan. And in fact, sometimes we say that we tend to follow whatsoever is being carried out all over the world without customizing it to our needs. But in case of this, I think 80% of our initiative we can follow the Japan's way, but of course the 20% initiative, that is particularly that initiative on two aspects. One is the reliable inflow forecast, and another is our own understanding between the basin states. If they are on board, I think we can also do that. So we are very sure. And these are the strategies, the 5 bullet points which Japan has adopted, and we can also adopt, and we are geared up to adopt those strategies. And in fact, one of our speaker, Dr. Nisa, so he is already working over this aspect also, and we have asked BBMB to be part of this, and he is also supporting BBMB in similar type of initiative. So in fact, on the dynamic rule curves and the concept of pre-depletion, where we have to work, I'll not go, due to time constraint, it is not possible for me to go into the technical details how to go forward for this dynamic rule curves and the pre-depletion concept, but these are the time-tested. Only point is provided we have the reliable forecast and understanding between the basin states or the dam owners. So it is a doable part. So this part we have tied up with the Japanese authorities, and we have also taken on board both the states, means 2 states, Karnataka as well as Andhra Pradesh as of now under phase 1, and under phase 2, all the 4 basin states. That means Telangana and Maharashtra are also expected to be part of this. And in fact, the beauty of the system is that one state, if riparian to other, the other is also riparian to the other. That means like Karnataka is downstream of Maharashtra, then Karnataka is upstream of Andhra. So that means they know the challenges. That way they are well prepared and geared up. Similarly, in the case of Andhra also, one reservoir is upstream, that is the Srisailam, and other are the downstream of Nagarjuna Sagar, which is the part of Telangana. So that means challenges they know, and they will be in a position to carry forward. And we are getting that support, and the reservoirs have already been identified on which both the states will be working in their systems. Means Karnataka will be working on 4 reservoirs, and Andhra is also working on their reservoirs, and ultimately they will be developing on their system. And based upon the outcome of the system, we are very sure that they would be quite satisfied with the outcome of the system, and it would be a showcase for the others. So, ma'am, only 1 minute, less than 1 minute is required to conclude. So this is the one thing, and these are our implementing challenges. It is not that we're talking in the air, we don't know our challenges. We know our challenges and we are working over those challenges. Support from Japan is there, support from our indigenous experts is also there, and we'll be definitely coming out of it, and it will be a system to showcase. Right now it will be a pilot, but ultimately we'll be going for a full-scale system. So this is my last slide where the way forward and conclusions are there. So we need to take forward this, and we are quite hopeful that other states will also follow this initiative. It's a win-win situation. We always talk of complex situations, complex solutions like floodplain zoning, which is very, very difficult otherwise due to administrative complexes. Retrofitting is very difficult, but this is one solution which we can take up with quite less complexities. And hopefully this will be a system to showcase for other states to adopt. Thank you for your patient listening. Thank you.
So ladies and gentlemen, next up, it's time for us to welcome Professor Mohammad Razmi sir, who will be presenting on coordinated operation of reservoirs for flood management. So please welcome sir with a huge round of applause. ಜೋರಾಗಿರಬೇಕು ಚಪ್ಪಾಳೆ. Come on, ladies and gentlemen.
Good morning, everyone. I am Mohammad Rasmi. I'm coming from International Center for Water Hazard and Risk Management. So today I'm going to talk about the coordinated operation of reservoirs for flood management. Basically, my talk will be on ensemble flow forecasting and adaptive dam optimizations and a kind of operational approach. Thank you for the introduction previously that what we are trying to implement and what we are going to do. So quickly, some introductions that, climate change is taking part and giving a devastations, and it has been, increased almost 2 times compared to the previous generations. And if you look at our next generation, they are going to have 3 times more of these disasters. So we are having a huge challenge how to operate or how to manage these disasters or how to operate the dam under different. Okay, so this is better. And so yesterday, I think Professor Koike introduced you about the challenges under climate change. So stationarity is actually, we take into account, right, when we do operations or modeling, but actually it's not anymore. So the climate change and weather is behaving differently and it's out of the range. And this has to be considered in planning and operational. So today's talk basically operational approach. How are we going to incorporate those extremes into our considerations? So as a hydrological science community, how we can help go forward and support policymakers. So though we understand that predicting future is really very, very challenging and uncertain. However, we have to produce some sort of actionable information that should be used to better manage the water-related disasters and bring the resilience and sustainable development. So basically, when we talk about flood and drought, we basically think these are 2 separate events or phenomena. But actually, those are interconnected, system. Flood, basically the excess of water and governed by flow dynamics. At the same time, the drought is a prolonged shortage of water and water availability. But these are basically interconnecting. So we separate this one as different phenomena. These are the 2 sides of the same coin. So as these 2 phenomena, one phenomena interacting other, when you go for operations or modeling, that you need to be considered seamlessly. So when we do the modeling part, mostly what we do for flood modeling, we run separate models, and drought we run separate models. But we need to develop a seamless model approach, a model that should be able to take into the consideration of the aspect of flood and drought, and also need to go forward beyond the flood and drought to go for water and food and energy and their applications. So as a result, at our institution, we developed this water and energy budget rainfall runoff inundation model that consider water, energy, and inundations. So to develop this model, we basically consider a land surface model which can take into account the land-atmosphere interactions. And also the model consider the soil moisture dynamics in detail. And then we couple, the flow equations of the flooding and river routing and so on. Then finally, we come up with this kind of, technology. And this model can able to consider the evapotranspiration, soil moisture dynamics, and flooding and drought and so on. So the model has, since it considers all the hydraulic component, we have a reliability of the flood and drought related risk assessment. And also the model take more inputs in addition to the rainfall. For example, radiation, temperature, humidity, wind speed, vegetation informations, so that model can produce more reliable response to the water cycle variability, as well as the climate change scenarios, which is linked to the global warming. So the model can be used for a long-term simulation, and also can be used for hydrological extreme and catchment with extreme of the catchment with a great confidence. And also this model is very compatible with the numerical weather prediction and climate models, since it has the land surface modeling component. So it can produce better responses to that. And also the model could be easily coupled with the hydrological responses of the model. And finally, most importantly, as this model has all the components, so the model could be stopped at any time and restarted. So this restarting facility is very, very important for operational flow of drought forecasting, as we will not be able to run the model from 2 months before and bring the better initial condition. But the model has to be immediately have to provide the condition of the catchment so that we could be able to directly go for forecast. So that's another advantage of this model. So this model has been applied in various parts of the world for climate change impact assessment and water management, and also flood and drought risk assessment. And let me show you some of the results that we highlight here. When we develop the model, we consider these applications in wet and dry basins. Then we are able to calibrate the models up to 90% of accuracy in those wet and dry basins. And also we run the model for 25 years without stopping the model. So the model could be able to generate the long-term conditions. And also we could be able to generate inundation informations and also the evapotranspiration information, which is linked to the drought and the food security. So this model, once it's available, we have to couple this model with the weather forecasting data that can provide more information on, the flood and drought, and can give us more lead time so that we can, adapt it for our operation. And compared to the one component or deterministic forecast, regional forecast or ensemble forecast provide better information about uncertainty so that we can able to capture the extremes, when we do modeling. So this application has been done in Japan, and we also could confirm that how it could help to come up with the decision making for the flood management and pre-release of the dams. And now I am coming to the Krishna River basins. So if you, to have some ideas, so Krishna River basin has a lot of small dams. Then we have a major dam in Almaty. Then we have subsequent dam in, like, for example, Sri Sailam, Nagarjuna, and so on. So at this moment, we are running or setting up this model with freely available data, and we are using IMD 25-kilometer gridded data and other forcing data, and DEM model or digital elevation model come from HydroSat. And by using freely available data, so we set up a model to simulate 2019 flood, which was, a kind of very strong monsoon event that has taken place between July and September 2019, and it brought heaviest monsoon recorded in 25 years and resulted more than 1,600 people dead and displacement of 1 million people. And also the state of Karnataka and Maharashtra were mostly affected. And this in unprecedented and devastating flood in Krishna River and East River affected large number of people. And the rainfall system looks like this. The rainfall happened in the upstream, most upstream of the area. Then it takes time to travel over the time. And if you look at the simulated discharges at several locations, so we could understand that, you know, the flood peak is actually have some lead time, or by coordinating between reservoirs, you can really operate the dams and release the water, but the time is very, very limited. So probably 1 or 2 days. So to enhance this, you know, the dam operations, so we combine this ensemble weather forecasting, which is downscale to in the Krishna River basins at 4-kilometer resolutions. And we could also understand that how the ensemble is working with the observation of recorded observation of IMD gauges. And we could see that though it's some of the events, it's really underestimated how it performed when you go for the dam operation part. So this is the results of 2019. So if you look at the forecast at 23 and 24 and 25 for next 7 days, so half of the days the ensemble spread is very, very small and really following the simulated discharge. So that means that the observation in the upstream take the control of the river flow in the beginning of the forecasting. Then the ensemble member come into play. So we could be able to get more realistic information from simulation up to 4 days, for example. Then the forecast become divergent. And for this Almaty River and Tungabhadra River in the other tributary and Prakasam Bridge. So we could see at least how this coupling with the model and forecast can able to 1 minute more. Yeah. And similarly, we also done for 2014 flood. And 2014 flood it's in the downstream mostly. So this combined with the ongoing monsoon event, and it brought very heavy discharge in the downstream, and it was very, it's cloud burst happened in the downstream and a lot of damages. So the model also can able to simulate those informations, but we have very, very limited time to act in the case of downstream. And yeah, this is by combining with the ensemble forecast, we could also say similar results at Almaty Dam, Tungabhadra Dam, and also Prakasam Bridge. Prakasam Bridge is the downstream, so we have more uncertainty. But by combining with the upstream, we could be able to, at least send some signals for the flood management. And this is the case in Japan. So how this ensemble forecasting has been used for preempting the reservoir and make the benefit for hydropower, then bring the benefit. So at the case of 2018 or 2019 flood, so by using the ensemble forecast, if you release the water early in time, so we could produce or make some space in the reservoir, so the flood peak could be absorbed. So we can cut the flood peak up to 600 cubic meter per second. Then at the same time, we can enhance the hydropower generation in the basin. And at the end of the flooding, so the dam also come to the full
Professor, could you please
capacity
wrap up?
position.
Sorry.
Right, this is the final slide. So this is an advantage, and we demonstrated that we could also increase the power generation by 12%. And those are the data requests that we are going to work on with each, the governments to get more data from institute gauges, and we will be upgrading the model. Thank you. Sorry for the time. Yeah, it was 12 minutes, so suddenly changed to 8 minutes.
Thank you so much, sir. Next, ladies and gentlemen, all of you, please put your hands together as I welcome Dr. Nasha, who will be presenting on research and development needs of the DRIP project related to the improved hydrological safety of dams for flood and drought management. Dr. Nasha, please.
First of all, I'd like to thank my project director, Mr. Rakesh Kashyap, for giving me an opportunity to be here today. And this presentation has 15 slides, and I don't have 1 minute for every slide. So let's begin quickly. What we're going to talk about today is a little bit about reservoir operation, what is the current practice, and what we should expect to see in the future, both in terms of flood management and drought management. And I want to touch upon the flood design estimates and also the current practices in India and how it could possibly be improved. Let's begin by reviewing what most of you know here. The reservoir operators are currently assisted by these two lines, which are called the upper rule curve and the lower rule curve. And both of those lines are developed typically using trial and error. The upper rule curve requires that we increase the flood storage zone occasionally on some reservoirs where that is necessary. The lower rule curve prevents us from emptying the reservoir storage too soon. So what we do now is we use all sorts of simulation models, trial and error. We put different curves in, then we look at the output, and that may be fine for a single reservoir system, but when you have many reservoirs and many users, it becomes rather cumbersome, and the output is very uncertain. In fact, the output often depends more on the user than the kind of model you're using. Do the rule curves really help reservoir operators all that much? Well, if you're an operator, this is the current level that I'm showing. All the lower rule curve will tell you is what should be the level that you shouldn't go under in the next 10 days, if it's a 10-day time step decision. It doesn't really tell you where you should be, it doesn't tell you how much to release. So it's essentially, what I'm trying to say with this slide is that we really are operating the reservoirs as reservoir operators. We don't get that much help from technology these days. If you were an operator and you were operating a reservoir during a high flow season and you're releasing, say, flow which has a stream velocity of 2 meters per second, and this is a very important slide, how far will this release reach? It'll reach about 43 kilometers downstream. And you know that most basins are much bigger than 43 kilometers. So what we are going to have to do is see what happens to it after the release. Of course, this release will attenuate. There will be some tributaries along the way, which may increase it to this dashed line. And then you'll have another attenuation. And this, by the way, is the area that we're trying to protect from flooding. We have not connected the release in this first 6-hourly time step to the damage that may happen 18 or 24 hours later. And this is a problem both for simulation models and for reservoir operators in real life. We do need to know what is the full bank capacity downstream in order to know what our target is. But this target is not linked in any single time step solutions with the release. The reason for this is that we have the attenuation, and we're also not taking into account more than one time step at a time in most models, and simulation models are the norm. So we have inflow here, and we have initial storage, and what you see is this dashed line, which essentially is the ending storage at the end of time step. If we copy this system and make this ending storage automatically become the starting storage for the next time step, and we do it for all time steps for which we have the time horizon of forecasts, then we are going to create this so-called multiple time step optimization. What this will do is it'll give us a perfect reservoir trajectory. In other words, it'll give us a perfect rule curve given the starting storage level and the water demands. And we do need forecast for this, and we do need to solve this so-called dynamic network. Now, none of the simulation models are capable of doing this. So the future is not simulation or improved simulation. The future is optimization. Here is another slide that shows the same thing, and it shows what happens to the release. That's the red line coming out of the reservoir in the very first day. It'll propagate to the second river reach in the second day and the third river reach in the third day. And this is the way we will link our decision on the first day to its consequences on the third day. This is the only way we can do it. This is termed model predictive control. The term comes from Holland, and it essentially means that we are making a decision for today based on the forecast for the next 2 days. And then we're going to move the whole forecasting horizon by 1 day, and we're going to complete repeat the whole sequence by updating the reservoir levels and updating our forecasts. Of course, we have to develop this flood damage function downstream, which will tell the model to minimize exceedance of spills from the downstream channel. So if you look at this as a system of having a runoff forecast model and this multiple time step optimization combined into a single package, then we have no more need for rule curves, at least not for short-term operation, because seasonal forecasts are a little harder to get. But this can be compared to automated reservoir operation. In the beginning, when we had self-driving vehicles introduced in the transportation industry, it was something of a laughable topic, but I am not the first person who thought about this. And the first paper that described this whole scheme was published in 1983. We have also this paper from 1999 from Charles Howard. The name of the conference was Preparing for the 21st Century, and the paper has a provocative title, Death to Rule Curves. The application of this was done in the Damodar River Basin, and you can see the effects of routing on the river reaches between the reservoirs. We had daily data from 1961 to 2017. 11 catastrophic floods happened in that period, and we managed to keep 9 out of them completely in check. This is one of the worst that we didn't quite keep in check by only using 2-day forecast, mind you. So here is what the solution in the left corner looks like if we have a forecast for only 1 day. If we increase the forecast for 2 days and repeat this solution process, we're going to almost completely eliminate the flood damage, and with 3 days we have no flood damage whatsoever. Keep in mind this horizontal line you see in the bottom has been obtained by effects of routing and tributaries downstream, and we're looking at 4 reservoirs operating in unison together here. We can also use this procedure in drought management. And if you look at these lines with different colors, each line is a perfect rule curve or perfect trajectory of reservoir levels for a particular year that was solved. Now, if you have enough of those years, we can do statistical analysis. These are the probability density functions that you see at the end of every week. And we can identify 50 percentile, 80 percentile, 20 percentile, and create the so-called operating zones. Now, each zone is going to be associated with a certain level of reduction in demand. So if we are above the blue line, we have no reduction. If we are between the blue line and orange line, we will reduce demand by 20% and so forth. This is only one way to optimize or to use the results of optimization in basin planning studies. So far, there is no set guideline for how to create a basin management plan or basin master plan. We should actually have this, and this is where research could help. This is not the only way to use this, but there are, of course, other ways. I'm going to skip this discussion of the difference between multi-objective and multi-purpose optimization. It's interesting. We can discuss this over the break. And I'm just going to move into the last few slides that deal with our flood design. Our flood design procedure is very complicated now. You probably all know that if you have a catchment with more than 5,000 square kilometers, you have to subdivide it into smaller catchments. We're making then all sorts of assumptions which we know are not true, like, for example, the linear channel routing between the catchments. We calculate travel times based on empirical formulas. We assume even distribution of rain over the entire catchment. This is, by the way, the Hirakud Reservoir catchment, 83,400 square kilometers. We know that there's never going to be the rain of equal depth over the whole basin. And then if you look at the historical data, we don't see that the peaks are going up, they're actually going down, probably due to the effects of regulation, which is something that the current procedure is ignoring. There are easier procedures. This procedure, if you look at the solutions from 1976 to 2025, gives various results depending on who does it, even though they're all supposed to be following the same procedure. And it does make a big difference whether you have to increase the size of your spillway by 17,000 cubic meters per second or not. The model we use in Canada is much simpler. It doesn't require convolution integrals. It is based on a historical paper from Nash, published in 1957, which proved that the hydrograph shape should be a gamma function. It uses rational theory, which is essentially calculating the volume underneath this hydrograph by multiplying rainfall area and runoff coefficient. And it gives pretty good results because they are much more consistent than the current hydrometeorological approach. Now, what we want to remove from the hydrometeorological approach is the uncertainty of who does it and the variation of the results that we're getting. And the only way this can be done is by getting involved the research community to inspect a large number of alternative approaches, this being only one of them. So to recap, what we'd like to do is we'd like to, the future operation of reservoirs to be applicable to reservoir operators in terms of helping them guide their decisions. We also need to develop proper benchmark tests because at every conference I've been to, there are tons of different presentations on different papers. I'm also an associate editor for a major journal, and there's been 18,000 papers published since 1960s on reservoir operation. That's a lot, and we should have some benchmarks which will distinguish the quality of those models and provide information to the operators which ones they can use. There is also a significant need for data-driven runoff forecasting model. We live in an information age. We have satellite data coming from various sources. We have artificial intelligence, but we still don't have self-adaptable, self-learning forecasting model, and we should have it, and we need it badly. And this is what the research community should focus on. Finally, a simplified procedure that is more consistent and more reliable for estimating design floods is highly desirable, and I think the research community could be of great help in that regard. Thank you very much for your attention.
Thank you so much, sir. Now, ladies and gentlemen, please put your hands together as I welcome Dr. Manikanta, sir, who will be presenting on evaluating and reducing uncertainty in the Hurst field method based probable maximum precipitation case studies from Indian river basins. Over to Dr. Manikanta, sir. Please welcome him with a huge round of applause.
Good afternoon, everyone. I'm Dr. Manikanta Velpuri. So today here, I'm going to talk about evaluating and reducing the uncertainty in Hirschfield-based estimation of probable maximum precipitation. So this work has been carried out by Dr. Jaya Bhatt and Professor V.V. Srinivas. So today I am here to present that work on their behalf. Yeah. In India, we can see that more than 6,000 large dams are present, and many of them are constructed after independence and they are aging infrastructure. So on a global scale, if we look at the dam failures, many of the dam failures are linked towards extreme hydrological events, particularly to flooding. So in India also, we can see many of the dam failures in the past and recent times. So in order to ensure safety of the large-scale infrastructure projects like large dams, so the inflow design flood should be constructed using probable maximum flood, which is derived using probable maximum precipitation. So according to the definition given by the WMO, probable maximum precipitation is defined as theoretically the greatest depth of precipitation, physically possible under modern meteorological conditions over a catchment area in a specified duration at a certain time of the year. So this probable maximum precipitation is not an observed value. So if we are overestimating the PMP, we might end up in an uneconomical design of the infrastructure. If we are underestimating the PMP, we might be increasing the risk of the dam failure. So in order to estimate the probable maximum precipitation, there are many physics-based methods to do that. However, they need lots of data from the other meteorological variables which are often unavailable. So researchers often go for statistical methods like Hirschfield's method, which is recommended by the WMO. So this Hirschfield method uses long-term rainfall records with the long-term rainfall records using different hydrometeorological variables. And here we are going to define a region and then compute the at-site statistics of annual maximum precipitation. And then we are going to construct an envelope curve based on which we are going to estimate the frequency factor. And this frequency factor is used for extrapolating for the extreme rainfall for the location. So when we look at the mathematical description of the Hirschfield method, here we are going to compute the regional frequency factor using by subtracting the mean of the annual maximum precipitation time series, excluding the maximum value, and the standard deviation also is computed by excluding the annual maximum value. Once we compute these frequency factors, we are going to plot the mean of annual maximum precipitation series at all the sites along with the frequency factor. And then we are going to develop an envelope curve. So based on the envelope curve and the mean annual maximum precipitation series, we are going to extrapolate that for a specific site. So when we look at the computation of probable maximum precipitation using Hirschfield's method, different sources of uncertainty exist. That includes the uncertainty obtained from the data sampling as well as the variants of the Hirschfield methods. When we look at the data sampling we are going to compute different statistical measures from the data sample. So based on the sample we are collecting from the site, so these values, these statistics are going to change a lot. And coming to the HM variants, people often go by defining the entire region as a single homogeneous region, but often that does not make sense. So by delineating the entire study area into meaningful homogeneous zones makes sense. So for computing the PMP, whether to use it as a lumped catchment or else to delineate into meaningful zones also introduces some amount of uncertainty, as well as there exist many outliers in the data set. We can also remove the outliers from the existing data sets. And for construction of the envelope curve, there are different mathematical formulations ranging from linear techniques to exponential curve methods and then the composite methods. So all these methodological choices introduces uncertainty in the computation of the Hirschfield-based probable maximum precipitation. So when we look at the exclusion of the outliers, so in the case study which we have done, they have excluded the sites using this following criteria where the annual maximum precipitation is standardized, and if the value is greater than this particular standardized value, then only the site is preserved, otherwise it has been excluded. And these are the different envelope curve formulations we have considered. So this ranges from linear, exponential, variants of exponential curve and the composite curves. So our study has three fundamental objectives. First, to quantify the uncertainty in the Hirschfield-based estimates and to determine the uncertainty bounds. Once we determine the uncertainty bounds, we are going to reduce the uncertainty by identifying the HM variants that should be avoided. And then we also wanted to increase the spatiotemporal coverage of the data we have considered. And then we are going to compare the uncertainty bounds with and without reducing the uncertainty variants. So this work has been published in Water Resources Research. When we look at the flowchart here we can see that there are actually two different variants for delineating the meaningful zones, and two options available for Hirschfield variants for preparation of envelope curve, and 6 variants of the envelope curve preparation. So in total 24 variants are going to obtain, and we are going to sample the data using the bootstrapping technique for 1000 values, and in total there will be 24,000 samples. And then we are going to use analysis of variance technique to decompose the variance in order to understand the uncertainty contributions. So in order to understand the uncertainty bounds, we have come up with imprecise probability theory. So this imprecise probability theory is going to give us a range of the bounds. Unlike the traditional probability theory, it also considers both aleatory uncertainty as well as the epistemic uncertainty. So in order to compute the bounds using the imprecise probability theory, first we have to come up with a plausibility function, which is shown in the blue triangle. So this will be constructed around the median of the PMP estimates of the entire sample. And then we are going to develop an elementary plausibility function, which is defined as an inverse beta cumulative distribution function. Here, the gamma value is the CDF value, which is unknown. So the optimal value of gamma is found out using the alpha cuts based technique. Once we find out the optimal value of gamma, we are going to compute the plausibility measure, which is the upper bound, and the necessity measure, which is the lower bound. So this is the alpha cut technique which I am talking about. So we have applied this methodology over two Indian river basins. One is Godavari River Basin and Kaveri River Basin. And we have used the IMD gridded data for this purpose. Yeah. So we have constructed four different techniques, 4 different clusters. And then we found out that the uncertainty introduced by interaction components is higher than the individual components. And out of that individual components, the sampling uncertainty has more, is contributing more to the uncertainty. And then based on this, we come up with 3 different recommendations to find out the homogeneous regions and screen the outliers from the existing stations and exclude the envelope curves, traditional envelope curve methods. So if we see here, these are the uncertainty bounds before and after excluding the uncertain things. So after that, we have also increased the spatiotemporal resolution of the considered datasets. So once we increase these datasets, the uncertainty prior was reduced to this. The uncertainty bounds has been reduced. So based on this, the following recommendations has been given. So the thing is, we have to delineate the homogeneous regions before computing the probable maximum precipitations. We have to screen the stations based on the record length to ensure statistical reliability of the envelope curve construction. And also we have to use more spatiotemporal datasets for getting the reliable probable maximum precipitation estimates. And the future extensions could be, we can introduce the climate change projections into this in order to compute the probable maximum precipitations under changing climate scenarios. Thank you.
Thank you, sir. Now, ladies and gentlemen, please put your hands together as I welcome Mr. Teju Kumar, sir, who will be presenting on application of National Hydrological Model, India for basin scale, hydrological assessment and reservoir operations in the Tungabhadra Basin. Over to Teju, sir.
Good afternoon, Chairman, delegates and all the participants. Today I'm here to present about the hydrological modeling which we have applied in Tungabhadra Basin. This work focuses on the hydrological safety part of the dam. Let me begin with the hydrological context. This is a map showing the river basins in India, and this is Karnataka where we are here, and Karnataka is drained by 7 major river basins. It is second most drought prone state in the country. We use 1/3 of our available water. Again, being a riparian state, we are bound by allocations. The normal rainfall map of Karnataka shows that we have an average annual rainfall, average normal rainfall of 1,000 to 100 millimeter. And you must notice here that 74% of rainfall occurs between June to September, which means we need to manage more of our water save the water and use it for further period. And most of our floods are fluvial floods, run-of-the-river floods. Reservoirs are very critical in managing floods, and most of our reservoirs are multi-purpose, which cater needs of irrigation, hydropower, and also flood moderation. Due to climate change and climate variability, we are witnessing more monsoon flows, which shorter lead times. Again, the challenge is that when you have severe floods, saving water for the future season is a critical aspect. So this needs to be ensured. You can't just release off the flood. Dam safety again needs to be looked at. Like it extends beyond structural integrity to have this operational preparedness. Literature review on things on hydrological modeling. It has evolved from just predicting from ungauged catchments to now including the human interaction. Again, we have the physically based and satellite driven models like WIC and SWAT that can give us spatially consistent results. And in data scarce region, we have GRACE data sets. Again, this point of rule curve and importance of having dynamic rule curve was stressed in the session here. Again, the rule curve based operation needs to be looked at because of this short-term, high-intense inflows. Again, data models are being very supportive for modeling, and we need to also harness their capabilities to have this forecast. These points towards integrated modeling forecast frameworks. About NHM model, it's a distributed modeling framework developed by IIT Kharagpur and in collaboration with other national institutes. It represents the land phase and it supports a grid system from 1 to 10 kilometer. It has a GUI base, and this is the framework of the model. Surface water model, the water balance is arrived at the grid scale and considering all the aspects of the hydrological cycle. Forest model considers upper and lower root zones. The groundwater model uses Bosniak equation and Darcy's laws, and the routing is performed using spatially distributed direct hydrograph or spatially distributed unit hydrograph. The reservoir model adapts the concept of storage zone, looking at debt conservation and flood control zones. Again, the important aspect of modeling, the sensitivity analysis is carried out using Morris method. The study area, for this study, we have considered the Tungabhadra catchment up to Tungabhadra Dam, having a catchment area of about 28,000 square kilometer. The effects of small reservoirs such as the Upper Tunga Dam has been ignored in the modeling. This is the data that has been used in the modeling, the dam, the graded rainfall, the observed flows, the remote sensing based LULC, the soil maps, and also the leaf area index and the temporal resolutions even. Results, the interesting part, we had applied this model to the two dam catchments, one being Bhadra in the very upper part of the catchment and Tungabhadra, the point of investigation. The calibration was carried out from 2016 to 2020, whereas the validation period was 21 to 23. And these are the model's quill evaluation parameters. This is the calibration results of NHM model for the Bhadra from 2016 to 2020. You can see most of our, like the lean flows, the low flows are well captured, whereas the model misses the peak flows. In the validation period, the same thing, some medium flows are captured and the low flows are well captured, but again, the peak flows are not so well captured. The reason being, one of the thing is like the temporal pattern and also the water balance by curve number method, the antecedent moisture content is also to be taken care. This is the results for Tungabhadra Dam. You can see here that most of the, sorry. Yeah, most of the low flows and medium flows are well captured, whereas few peak flows are not so captured, but still the model performs well in the peak flows. In the calibration period, we have the medium flows well captured along with low flows, but again, few peaks are missed out. Again, this is again attributed to the rainfall temporal pattern and also the the initial abstraction losses. This is a summary table looking at NSE for Tungabhadra Dam catchment. We have better NSE, like above 0.65 is a better modeling result. We have achieved about, the model has delivered about 0.72 and 0.6. Again, on the inflow forecasting, we have the model adapts the long short-term memory model, and the hyperparameters are trained using trial error method. You can see during the training and testing, we had taken a longer period for training from 2010 to 2014, whereas the testing was for 16 to 18. The model for Bhadra Dam performed well with the NSE reaching up to 0.87 in the testing period. For Tungabhadra Dam, again, the model performed well with NSE reaching up to 0.9 during testing. However, there are a few peak flows that has been missed. This is a summary of comparison for forward-looking for dam operation. The forecasted inflows are very much important to be well prepared. The model performs very well in one-day interval, whereas it depreciates going forward. Again, the summary of discussions and modeling. The model performs well, capturing the inflow variability in the Tungabhadra system. Satisfactory represents the seasonal inflow. The forecast indicated simulation are good for a one-day interval, whereas we need to further investigate for more period. There are some discrepancy. Again, modeling is not 100%. There are some discrepancy, and this needs to be looked at. This demonstrates that a model like NHM can also be adapted for operational use, whereas more of the hydrological modeling are very limited to the academic purpose. But this model enables us to also adapt for operational use integrated with the forecasting environment. And furthermore, like this model has a better GUI, graphical user interface system, and database that can easily be integrated to data dissemination platform like water resource information system. And State of Karnataka has already integrated the outputs with Karnataka Water Resource Information System. Again, with inflow outlook knowns, the dam operators can be well prepared to manage the flood well, and dam safety can be assured. Model has performed well. Future priorities include improving peak flow simulation and working on results for improvement of further lead period improvements, and also better communication by creating alerts. We are thankful for Water Resource Department, ACIRRM, Government of Karnataka for facilitating this work in collaboration with IIT Kharagpur, and also for KNNL for providing all the reservoir data sets. We also thank Professor Rajendra Singh and team from IIT Kharagpur for their sustained support in answering our all valid questions that are related. Again, the Government of Karnataka Water Resource Department is not only collaborating with academic institutions, but it's also building the capacity of engineers and creating an enabling environment so that we, the engineers, can adapt the recent technologies in the academy and implement in the field. Thank you.
Thank you so much, sir. Now, ladies and gentlemen, please put your hands together as I welcome Dr. Shashikumar M. sir, who will be presenting on hydrology outlook for operational water management of dams, integrating observations, forecast, and hydrological models. Welcome, sir.
Thank you. Good afternoon, Chairperson and Co-Chair, and all the fellow presenters. And I want to good afternoon to all the participants also from the Karnataka and other states. This work was done in ACIWRM. My colleagues already, Teju Kumar presented one of the topics. Also, Dr. Shomik Shekhar Rao also part of the work carried out, and our engineer-in-chief, Mr. Rajesh, also was part of this work carried out. So, okay, when we talk about the flood management, dam safety, we generally don't look them together. And most of the time, it's time that we adhere to some kind of a decision support system. Mostly when we operate, it is like more of a anecdotal, or it is a people who know certain things about the way the dam operates and when the flood occurs, etc. But it's time that we move onto a system, a decision support system that can be operational and practical. So in our organization, the important aspect, I recall as our director says, whatever data or whatever analysis we do, we have to move from theoretical to the operational and practical way. So this is one of the work what we have done is what is called as the hydrology outlook. And this is done for the Karnataka state, and which is operational, and it can be discussed with our WRD and other dam safety organizations to see how to make it more workable in the coming days. Again, this was developed in collaboration with IIT Gandhinagar, Professor Vimal Mishra and his team. And I also want to thank the WRD department for supporting all the work carried out for this. So as you see, the problem statement is what is currently happening is the operations are frequently depending on retrospective analysis. So we always depend on some historical data, either in some format which is not really enables us to make a decision currently and for the future. And again, I think in this conference, it's been repeatedly said about the stationarity and the rule curves. Again, the rule curves comes the very heavy reliance on the static, the rule curves in the the climate change has become a big question mark. And also the deterministic forecast. Whatever forecast we use, we try to use single deterministic forecast based on the past data. But again, we need to see that now there are a lot of global models available and also national models available, how we can integrate them together to have a kind of a forecast model. And this, of course, we talked about the increasing climate variability. These are all the problem contexts by why we want to carry out this work. So again, this is about the WRD context. The works are there already. The hydrological outlook is not a new term, and it's not a new work that is done here. Already there are many countries which are using it, but in WRD, in Karnataka context, we wanted to use it under both the drip phase 2 and 3. It kind of supports the institutional strengthening and capacity building in terms of component 3. The technical support can be provided by the ACIWRM. Of course, we also integrate a lot of data from NHP and NWDP currently, which was released this week. So the hydrology outlook, what is an hydrology outlook and what it is not? So hydrology is more than a point prediction. It is, as I'm going to show some of the results, you can see that it is going to give you a kind of a outlook for the next 1 day, 2 days, 7 days, or 15 days or 30 days, based on the available data with us. So this has a very good use because it also uses ensemble data. That is, the available forecast data is there are around 21 members in the part of 21 different models which are integrated in this ensemble. Of course, it is not just rainfall. When I say hydrology outlook, it's not just rainfall. We can even forecast the temperature and also runoff and the soil moisture also. And the outlook formula is very simple. I'm going to present that in my framework. And operational insight, again, we can convey the raw data. As I was saying, the practical application is whatever data. We have a lot of models, we have a lot of processes, we have data available. But how do we convert that into a practical and operational status? So that is the main focus of this work. Of course, we can use it for the, we want this data sets to be used by the engineers. The data for, of course, this is the different data inputs for this model. Observed data is IMD gridded data sets, both the observed data as well as the forecast data. And the rainfall forecast is from the global ensemble forecast system. And the reference data is, again, we used our ground level data to calibrate this model. Of course, we have to be thankful for the NHP program in which a series of sensors across the state has been installed. And of course, the last thing is about the operational outlook. So this is one of the snapshots which is showing the Karnataka, of course, the last year in November. This shows the about 15 days forecast using the IMD observed. This is not forecast. This is IMD observed precipitation and maximum temperature. Similarly, use this model to get the runoff, etc. So I'll just go into the modeling framework quickly. So this actually uses the wick infiltration model, wick model, and also comma flood model. So we have integrated this model together. So there is no, there is no need to have a separate output and run the comma flood model again separately. So it has an operational efficiency. So this we were able to integrate, and we are able to run it every day. And wherever required, some of the forecast which comes once in a week, we will do that also. So this operational forecast is, again, we have automated in our server. The automated process is data ingestion does the data which is shared by the IMD. We collect this data from through ATP, and we use that to run this model. We have a small dedicated server for this to run this and get this output. I will just quickly go to this, one of the important outputs which I wanted to share with all of you. This shows the Karnataka's the map on the thing. Yeah, thank you. So it shows the map where we see that which indicates the precipitation from 0 to 100 mm for that particular season. And also we have the forecast for the next 1 day, next 3 days, next 5 days, and next 7 days. So you can see that. And also the climatology on the bottom shows the long-term period average of IMD data about 1970 onwards. So how the lighter blue shows the long-term period average, and the blue line shows the current, how it is the current year observed data, and the red line shows the future or the next few days forecast. And this we turned on routed using this observed and the forecast model. We also use the comma flood model to derive this for specific dams. So we can see that we have done for the major dams for now. So you can see the inflow to the dam, and the black line shows that, and also the forecasted inflow for this specific dams. So this we can run for every day, and we can get the model, the output. And this also shows one of the other important output is the different streamlines, which are streams which are in the state, which we can indicate by the color coded what will be the kind of discharge that can be expected based on the forecast data. So this has a lot of practical applications. The way forward is to see that how to bridge this observed and forecast together in our operations. And we need to see how to make a kind of a standard operational procedure to integrate this. Of course, there are models which it is not this is the only model we have to follow, but we need to see in coming days how to integrate all these models and make a practical decision. Thank you.
Thank you so much, sir. I request Eileen ma'am, you want to summarize the session? Okay. One question, sir. One question we can take. Sorry, sir. We're just running short of time.
Yes. Only one question, madam.
Yes, sir.
Yes. 1 minute. The question is with regard to that's presentation number 1. Role of Japan, CPME on the knowledge transfer. What specific Japanese reservoir operation practices or decision protocols have been adopted to Indian monsoon conditions, and how sustainable is this knowledge transfer post-drip?
Yeah, so I'll try to reply your query.
Yes, sir.
So this is basically Japan is also having the similar conditions. Number one, in terms of the hydrometeorological part. Second, it is the basically the administrative composition also. Means they are also having the same type. Like in India, we are having the federal structure where center and the states, they are having the center and the prefectures. Only part is their river law, which is different from ours. We don't have any river law, but they have. But then we have the intent. This is what I wanted to say. If we have the intent, we can also do this. Secondly, in terms of adopting their system, which is your specific query.
Yes, sir.
Basically, it is the pre-depletion terminology or the pre-depletion technology which they are using, and similarly we can also use, since we are not having the flood cushions available in our reservoirs, but in case of we are having reliable forecast, we can also go for that. And it has been proven theoretically in case of India, particularly Dr. Nessa present in case of a theoretical study in terms of where he assumed that the inflows are as per the forecasts are as per the historical inflows. So that there we could work out that definitely within the available constraints, we have optimized not only in terms of the conservational use, but in terms of the power benefits also.
Yes, sir.
Yeah.
Yes, sir. Sir, last one question, sir. Very short question.
Yeah.
This pertains to administrative challenges.
Yeah.
That is the data sharing and transparency, sir.
Yeah.
Are there any administrative constraints in real-time data sharing between states? And how are issues of data validation and trust addressed?
Yeah, this is a challenge, but let me give you an example. Are we following any constitutional law in terms of dealing with our household matters? If my wife says that this is to be done, I agree.
Yes, sir.
This is what we generally follow. So that means we don't want at each and every stage. It is the confidence and the mutual trust where we should work. Right now, without having any administrative or institutional setup right now in terms of sharing of data. Yes, data sharing is a challenge. We understand, and it is not even the state to state, even between one chief engineer to other chief engineer. So I have dealt with NHP project, and we have faced this problem. Even the organization-wise data sharing challenges are there. But with the data availability and with the remote sensing products also, now the gridded products are also available. So we can move forward. That challenge will be, with the passage of time, will evolve and come over that challenges. As far as validation is concerned, I must say that should be the responsibility of the data owner, means who is producing that data.
Yes, sir.
And we can use the AI/ML also for validation part, and we can use the hydrological and statistical tools also.
So the very contention of raising this question is I was talking to my secretary who is here.
Yeah.
This is when it comes to the question of sharing waters and in terms of Krishna basin, the downstream riparian is Andhra. We are the middle riparian. Upstream, of course, it is Maharashtra.
Yes.
So we are in the process of attempting towards raising the height of the Almaty Dam from 519.600 to 524.256 meter, almost 15 feet, with an impounding system of 100 TMC. And there is a grows from the Andhra. So this is the administrative with regard to sharing of the data. So when they're opposing, when they're registering their protest, so this might come in the way. So what, with that intention, I have raised this question.
Sir, we can take it offline, the networking lunch.
Sir, only 1 second. I can just inform in terms of legislation. Now the legislation in place, states are bound to share data to the downstream riparian state or upstream riparian state in terms of NDS Act, Dam Safety Act. So those provisions are already in place. States are bound to share their short-term interval data releases to the downstream riparian state also, upstream riparian state also. So there is a law in place in the India. It's binding. It's binding. There's law. That's all.
So basically, I think he is talking of the Dam Safety Act provision. If I am correct, it is 35, Section 35, where there is a liability on the part of dam owners to share the data to the downstream reservoir authorities. That's what he is talking of.
Yes, sir.
But secondly, in case of this initiative particularly, where there were the data sharing concerns in terms of that part, so right now, Karnataka is working on their own reservoirs and Andhra is working on their own reservoirs. There are the dedicated working groups. But I am quite sure that once you will see the utility of this tool, then the further political will and the sharing of data issue will automatically be resolved.
Yes, sir. Yes, sir.
This is what
So thank you, sir. I have got still 3 to 4 questions. Paucity of time.
Yes, sir.
I am not being able to raise questions. Anyway, I will request the same through online.
But
Thank you, sir.
If those are directed to me, are available even the, in the night
even for
also.
different topics also. In a way, I will make an attempt through online.
Thank you.
Yes, yes. Thank you.
Thank you so much, sir. Now, ladies and gentlemen, please welcome Mr. Sher Singh, sir, from CWES office, Chairman GFCC, to please join us on the stage and do the honors for our chair, co-chair, and all our speakers. Please welcome sir with a huge round of applause. Mr. Singh, please. Mr. Sorry, sir. Can we have Mahesh sir to please summarize it?
Thanks for the opportunity. So, amongst the various other safety aspects, I think hydrological safety aspect is one important thing. That's what the objective of this session. So we have totally 6 sessions. The first session was on cascade operation of dams and in Krishna Basin. See, here the suggestion was to have a standard operating protocols jointly by riparian states for the reservoir operation schedule. So this requires robust flood forecasting protocol, as well as early warning system, as well as using dynamic roll curves. So far, we are using only static roll curves. So we have to, we dam owner should work on it to have to develop dynamic roll curves to take care of the reservoir operation during extreme flood situations. And the next topic was coordinated operation of reservoirs for flood management. Here, forecast-based reservoir operation strategies under extreme climate variability was discussed. So here, from Karnataka point of view, I being worked as technical director in Krishna Basin, KBGNL. See, flood management in Krishna main stem, we have a standard operating system, which is working good. Whereas in Bhima, see, we don't have proper coordination to handle the severe flood situation. So during 2019 and 23, we had the worst flood situation wherein loss of livestock and properties were there. So there we need to adapt. We have to have a better coordination to have standard operation procedure, operating protocols for the flood management in Bhima Basin. The next topic was the R&D needs of DRIP for improved hydrological safety of dams. Here, yes, I do endorse the speaker's suggestion. We have to adopt automation and a robust flood forecast mechanism to arrive at a workable adaptive reservoir operation protocols. The next topic was reducing uncertainty in Hirschfield method based PMP. Yes, here the speaker has very well suggested the primary limitations of the Hirschfield method when applied to Indian monsoon-dominated basins. The next, I request the speaker to just suggest us to go ahead with the limitation, how to overcome it. And definitely, if we put a jolt in our standard operating system, and without suggestion, I don't think it is proper. We need to suggest us to go forward. Next subject was application of NHM India for basin scale hydrological assessment. See, I'm proud that I thanks DRIP and ACIWRM for imparting national and international exposure to our young engineers. So they are compelling us, the senior officers, to update ourselves. So I'm very happy to see Dr. Tej Kumar as well as Shashi from ACIWRM. They are really rose to the occasion and making their presentation in the international forum. I'm very glad, and thanks to DRIP and ACIWRM. The last topic was integration of observed data, satellite inputs, and forecast models to improve operational water management. Yes, see, data integration being done at Dr. Shashi, Data integration has been done at the ACIWRM level, but it is not percolating down to the field operators. That is the major gap. Even capacity building also being imparted to the engineers, and they are dumped at ACIWRM or KERS or something else. See, they should work on field. We need to get a better suggestion from the field engineers. We need to groom and we need to impart training to the field engineers so that efficiently they can manage the flood situations. And but not the least, reservoir operation policies be made adaptive under climate change, induced hydrological uncertainties. This all dams owners should come out and really they have to have a standard SOPs. That too, when it is having a cascade interstate reservoirs, I think cooperation from riparian state is very much required. I think one more suggestion from my side, in the capacity of Director KERS, I think Central Water Commission should intervene to develop SOPs for reservoir operation under flood situation when it's a riparian reservoirs are there. Mean to say 3 to 4 riparian reservoirs are there. And second thing is, I requested the NDSO for early warning system protocols, depending on the category of the dams. Because you can look at the numbers. Nowhere much dams are coming out with proper early warning system. I think for flood management, I think robust early warning system is very much required, sir. Thanks. I personally thank the organizing committee of this ICDS for providing me an opportunity to share chair with the big weights, heavy weights. Thank you. Thank you very much.
Ladies and gentlemen, it's time for us to honor all our speakers, starting from our chair, Ms. Eileen. I request Mr. Singh to please do the honor. Thank you, ma'am. Next, I would request our co-chair, Mr. KG Mahesh sir, to please join us. Thank you so much, sir. Next, I would like to welcome our speakers, starting from Teju sir. Next, I would request Mr. Rakesh Kashyap sir to please join us.
Sir, I'll
Thank you so much, sir.
my team to kindly come up. Mr. Yogesh and rather state should also come up, but Yogesh is there. He's the part of working group who is working, so he can receive on my behalf, sir, if you permit.
Thank you so much, sir. Next, ladies and gentlemen, can we have Professor Mohammad Razmi sir, please? Thank you so much, sir, for joining. Dr. Manikanta sir, please. Please join us, sir. I also request Dr. Shashi Kumar sir to please join us. Last but not the least, can we have our session in charge, Mr. Ravi Ranjan, please? Have I missed out? Arey, how can I forget the vibe of the day? Nasha, sir. That had to be a special mention, that's why. Thank you so much, sir. Can we have Ravi Ranjan as well? Mr. Ravi Ranjan, Director, Hydrology, CWC. Thank you so much, sir. Thank you so much, Mr. Singh, for doing the honor. Thank you so much, ladies and gentlemen. With this, we come to the end of our morning session. So next, we are heading towards networking lunch, but post-lunch we have dam failure case studies, lessons learned. That is our session. I request all of you to please join us back in next 45 minutes in the same hall. We reassemble back at 2:30, ladies and gentlemen. Thank you so much. They took my sheet.
Central Water Commission presents floodplain benefits and need for its restoration. What are floodplains? Floodplains form an integral part of our ecosystem. A river is mainly confined to its main channel, but as the water level rises, the river spread laterally and forms its own floodplains. They therefore provide the space for rivers to spread their waters during high stages. Why is floodplain important? Its benefits. Floodplain is vital for the health of our environment. They are our natural capital assets that provide invaluable functions for our communities and riverine ecosystem. They contribute significantly in the social and economic growth of a country. Benefits of healthy floodplain. Natural defense against flood hazard. The graph shows the effect of healthy floodplain on peak water level in a river. Floodplains act as natural water storage structures and dampen the peak discharge and water levels during high floods. Water filtration and groundwater recharge. Healthy and wide floodplains allow large-scale infiltration and contribute significantly towards increasing the groundwater levels in the surrounding area. Sediment retention. Floodplain becomes favorable site for deposition of nutrient-rich sediments during floods. It gives enhanced fertile farmlands to the people living nearby. Sustaining natural habitat for plants and animals. Flourishing floodplains are rich in flora and fauna, and form an healthy ecosystem. Social and cultural values of people. Floodplains are the lifeline to many. They improve the quality of life by providing ample recreational and economic opportunities to people. How are we damaging our floodplains? Rapid growth in urbanization has caused unplanned construction and encroachment on our riverbeds. Dumping of solid waste material from industries and urban centers has caused severe damage to our floodplains. As a result, most of the floodplains in the country today are either rendered dysfunctional or severely water-clogged. Water clogging prevents water going back to main river channel, causing misery to people. Dysfunctional and damaged floodplains has resulted in huge reduction in capacity of rivers to carry flood waters. Consequently, during high floods, the river surges up and creates flood disasters. There have been increased number of such disasters in recent times, where poor floodplain management had not only aggravated the flood situations but also enhanced the damage and losses associated with it. Therefore, preservation of floodplains is crucial for protection from floods. Apart from aggravating floods, poor floodplains also adversely affect our riverine ecosystem and groundwater recharge. What we need to do? There is an urgent need to protect our floodplains from the damaging impacts of encroachment, unplanned urbanization, and the rising trend of using rivers as sink for waste disposal. Mapping of all the vulnerable floodplains should be done with clearly defined no development zones and regulatory zones. Apart from mapping of floodplain zones, various activities allowed in these zones must be clearly defined, regulated, and strictly monitored. Solid waste disposal into river must also be checked, not only by means of strict government regulations but also by sensitizing people towards its ill effects. Enforcement of floodplain protection and its restoration is the need of our, and must be cogently taken up, for better tomorrow. Thanks for watching.
Welcome to this introductory video to understand the key terminologies used by the Central Water Commission on flood situation and forecasting. Central Water Commission is the nodal agency responsible for flood forecasting under the Ministry of Jal Shakti. Currently, CWC issues flood forecasts for 350 stations in rivers and reservoirs all across India. Among these 350 forecast stations, 200 are level forecast stations and 150 are inflow forecast stations, which are supported by 36 divisional flood control rooms and a central flood control room based in New Delhi. CFCR functions 24/7 throughout the year and monitors the flood all across the country. The flood monsoon season begins on 1st May in the northeast region and Jhelum Basin, while it starts from 1st June in the rest of India. It continues until 31st October in southwest monsoon regions and extends up to 31st December in northeast monsoon affected areas. CWC issues short-range forecasts for river level and reservoir inflow with the warning time up to 24 hours. Flood inundation forecast, which provide the flood inundation scenario for next 3 days for some specific cities, and 7-day flood advisories, which provide flood warnings for next 7 days. Before we dive deeper, it's important to understand some basic terms commonly used in flood forecasting like warning level, danger level and highest flood level. Warning and danger levels are decided by the state government authorities. In the context of flood monitoring in India, CWC uses standardized definitions for these levels at river gazing stations. Warning level is the river water level at which flood preparedness should begin. It serves as an early alert to authorities and the public that water levels are rising and could approach a potentially dangerous threshold. Danger level marks the point at which a flood situation is officially recognized and flooding may occur in low-lying or vulnerable areas. At this stage, authorities may initiate evacuation plans and emergency response measures. Highest flood level is the maximum water level ever recorded at a particular river gauge site. It helps in flood risk assessment and planning flood protection infrastructure. When current water levels approach or exceed the HFL, it signals a severe flood event, potentially worse than any historically recorded. Based on these levels, different flood situations are defined. If the water level of the river is above the warning level but below the danger level, then it is called an above normal flood situation. If the water level rises above the danger level but remains below the highest flood level, then it is called severe flood situation. Finally, if the water level of the river exceeds the previous highest flood level, then it is termed an extreme flood situation. Now, let's come to know about the flood forecasting activities. Level forecasting refers to the prediction of the water level at a particular location in a river for a given future time with the rising or falling trend. The forecast is issued once the water level in a river touches or is expected to touch the predefined warning level. Level forecasts help the local administration and other agencies in deciding mitigating measures such as evacuation of people and their movable properties to safer locations. An inflow forecast predicts the amount of water expected to flow into a reservoir or dam or barrage from upstream sources in the coming hours or days. The forecast is issued once inflow to it exceeds a certain threshold value. Inflow forecast enables dam authorities to optimize reservoir operation for safe passage of flood downstream. This is all about the basic information about the key terminologies used in Central Water Commission. We hope it will help you to understand the flood situation in a better way. Thank you.
Groundwater contamination has emerged as a major challenge in ensuring safe drinking water supply from aquifers. To overcome pathogenic contamination in surface water sources or dug wells, hand pumps and bore wells were promoted in a massive way as safer sources for drinking water. However, surfacing of geogenic contaminants like iron, salinity, nitrate, arsenic, fluoride, etc. has offered a fresh challenge. In this video, we will discuss about the instances of high arsenic in groundwater in India and the initiatives of CGWB in remediation of arsenic contamination. Arsenic occurs naturally in groundwater, but only as a trace constituent. When its concentration in drinking water exceeds a certain limit, it is known to have many adverse health effects. As per the Bureau of Indian Standards and also as per the standards of World Health Organization, the safe limit of arsenic is 10 parts per billion. That means 100 liters of water should have less than 1 milligram of arsenic to be fit for drinking. Prolonged exposure to arsenic contaminated drinking water may result in gastrointestinal diseases, cardiovascular disorder and even cancer. However, the most common effect is hyperpigmentation of skin and keratosis. As per the studies carried out by the CGWB, arsenic is found in parts of 152 districts in parts of 21 states, and approximately 40 million people are residing within the risk zone of arsenic contamination. However, it is important to note that in an affected districts, not all blocks are affected. In an affected block, not all villages are affected. In an affected village, not all the bore wells or sources are affected. The largest contiguous belt of high arsenic in groundwater in India is the Ganga plains. In this part, arsenic contamination has been reported from nearly 66 districts in 6 states: West Bengal, Uttar Pradesh, Bihar, Jharkhand, Haryana and Delhi. The recent aquifer mapping studies have helped in delineating multiple aquifers in these areas, and in general, the deeper aquifers are arsenic safe. This is a schematic diagram showing that the upper aquifers with high concentration of arsenic is separated from the arsenic safe deeper aquifer by a thick clay layer, such that water in these two aquifers do not get mixed. This means that if we can construct a well that gets water from the deeper aquifer and do not allow arsenic contaminated aquifer in the shallow aquifers enter the well. We can ensure contaminant-free drinking water through this well. CGWB introduced the technique of use of cement sealing within the wells so that it can provide arsenic-safe water. In this technique, first, the pilot hole is drilled. After drilling of the pilot hole, a pipe called the well assembly of nearly 6-inch diameter is lowered in the well. This well assembly is perforated only at a particular place so that the perforations are placed against the aquifer, releasing arsenic-safe water. The annular space between the well assembly and the wall of the well is filled with gravel, and at appropriate depth, cement slurry is put, which solidifies and prevents arsenic contaminated water to reach the screen through which water enters the well. Thus, the water that is extracted from the well is drawn from the deeper aquifer and is arsenic safe. It is important to note that such cement sealing is not sufficient. Controlling the pumping rate is also important to keep the water level in arsenic protected aquifers higher than in contaminated aquifer, so that the water from the contaminated aquifer does not flow like the deep aquifer or the arsenic protected aquifer. Using this design, CGWB has constructed nearly 600 wells in parts of Bihar, Uttar Pradesh and West Bengal. State governments of Uttar Pradesh and West Bengal have constructed nearly 1500 such wells with cement ceiling that are catering to the safe drinking water requirements of nearly 70 lakh people. Aquifer mapping is helping in better understanding of aquifers and offering innovative solutions to many problems.
Welcome to the Central Soil and Materials Research Station, CSMRS, an office under the Ministry of Jal Shakti, located in New Delhi. What is the most fundamental necessity of life? It is water, the essence of existence, the foundation of development, and the heartbeat of civilization. Water conservation has been a necessity of the past, a demand of the present, and the hope of the future. To ensure the water and energy security of our nation, the stability of water resource structures becomes paramount. With this perspective, the Government of India established the Central Soil and Materials Research Station, CSMRS, in 1954 in New Delhi as the Soil and Materials Directorate of the Central Water Commission, CWC. Since its inception, CSMRS has served the nation through research, consultancy, and testing services for various water resource projects in the country and neighboring countries. On the recommendation of the high-level committee constituted under the chairmanship of Dr. M.S. Swaminathan, CSMRS was separated from the Central Water Commission in 1981 and made an attached office under the Ministry of Jal Shakti, Department of Water Resources, River Development and Ganga Rejuvenation. The mission of CSMRS is to establish a world-class center of excellence in the fields of soil mechanics, rock mechanics, concrete technology, and water resources research and development. Its vision is to be responsive to changing global needs with an emphasis on quality, innovation, sustainability, and professional and human values, so as to make an effective contribution to public welfare and socio-economic development. The activities of CSMRS relate to research, testing, and consultancy, providing assistance to government departments and public sector undertakings. In addition, it also undertakes training, dissemination of information, and academic collaboration with universities and research institutions. The main areas of work include soil mechanics, Rockfill technology, geosynthetics, soil dynamics, rock engineering, geotechnical instrumentation, concrete technology and chemistry, numerical modeling. The soil mechanics division focuses on the mechanical behavior and engineering properties of soil. Soil characteristics are identified through tests such as particle size analysis, liquid and plastic limit tests, and soil classification. The optimum moisture content and maximum dry density of the soil are determined by compaction tests, such as the automatic Proctor test. Soil compressibility is studied using automated consolidation equipment, which is essential for the stability analysis of dams and foundations. Digital servo-controlled triaxial tests are performed to determine shear strength. Field investigations include exploratory drilling, permeability tests, plate load tests, and standard penetration tests, SPT, which evaluate the behavior and bearing capacity of the soil on site. The geosynthetics division utilizes modern materials such as geotextiles, geomembranes, geocells, and geocomposites, which aid in seepage control, filtration, drainage, erosion control, and reinforcement. The Rockfill division studies the strength and deformation characteristics of rockfill materials. Model materials are tested using relative density equipment and large-scale testing devices. This division also performs quality control and health monitoring in dam projects through on-site tests such as density measurements and permeability tests. The Geophysical Division is equipped with advanced instruments such as seismic refraction, MASW surveys, and cross-hole testing, which are used to determine P-wave and S-wave velocities. Resistivity imaging techniques are used to assess the properties of subsurface materials. This division also operates vibration monitoring equipment and remotely operated underwater vehicles, ROVs, for inspecting dam surfaces and underwater structures. The Rock Engineering Division conducts laboratory and field investigations of rocks and rock masses. These include uniaxial compressive strength, UCS, testing, triaxial compression, indirect tension, slake durability, point load, in situ stress measurements, uniaxial jacking, and direct shear tests are performed for underground structures. Ensuring the stability and safety of dams. The Concrete Division conducts construction material surveys, aggregate testing, alkali aggregate reactivity testing, and concrete mix design. It also provides thermal studies of mass concrete and quality control and assurance services, such as for the Polavaram project. Non-destructive testing, NDT, equipment, such as rebound hammers, ultrasonic pulse velocity meters, and half-cell potentiometers are used to evaluate the structural integrity of concrete. The health assessment of the dam galleries are carried out with NDT equipments. The Chemistry Division analyzes the chemical properties of construction materials such as soil, water, cement, fly ash, and admixtures. Advanced instruments such as X-ray diff. The Workshop and Instrumentation Division manufactures precision instruments such as three-dimensional crack meters using advanced lathe and milling machines. These instruments are installed at various project sites for long-term performance monitoring. CSMRS also undertakes forensic investigations, contributing to studies on critical incidents such as the Gharra Dam, Tapovan Vishnugarh project, and Dharchula landslide in Uttarakhand. To promote knowledge sharing, CSMRS organizes annual training programs featuring expert lectures, laboratory sessions, and field demonstrations for engineers, researchers, and students.
This is the Ganga, one of the mightiest rivers in the world, flowing over 2,500 kilometers across the heart of India. Born from the pristine snows high in the Himalaya, the Ganga nourishes one of the most densely populated regions in the world, nurturing life in its fertile waters and providing livelihoods to millions. For Indians, the Ganga is more than a river. And for the last decade, rejuvenating the Ganga basin has become one of the most important and crucial missions for India. Filmmaker and conservationist Mike Pandey travels from the wetlands of the Sundarbans to the Himalayan glaciers to meet the people who are at the forefront of this mission to ensure that the Ganga lives on.
A lifeline actually to over 600 million people.
This is the story of hope, that ordinary people can achieve the extraordinary, to turn the tide and try to save this river from the skies. For the last 40 years, Mike Pandey has been filming wildlife, studying nature and its diversity. He was just 18 years old when he first came to India from England. This was the first time he saw the Ganga in its full glory. A sacred river, a giver of life to one of the most diverse ecosystems on the planet. Over the years, Mike has witnessed the river being gradually crippled by rapid development and mass neglect, becoming shallower and more polluted as it reaches the Bay of Bengal. But over the last decade, systemic efforts have been made to rejuvenate the Ganga on a scale never seen before. The river has been given a fighting chance, a hope for the future, to try and come back to its former glory. And Mike makes a journey along the river to witness this change. Mike begins his journey where the Ganga ends hers, in the mangroves of the Sundarbans, traveling north all the way up to Gangotri at more than 11,000 feet, where the deity Ganga is believed to have descended from the skies.
"10,000 square kilometers across India and Bangladesh. This is the largest contiguous mangrove forest on the planet, flowing in a network of creeks, channels, mudflats, and small island that it builds. And it is here that the Ganga forms the largest wetland ecosystem.
This forest is home to many unique, rare, and endangered species. The Sundari tree, the dominant mangrove species here, has been crucial to maintaining the health of the ecosystem. These mangroves form the most effective barrier against tropical storms, but are increasingly under threat from rising temperatures.
How is climate change affecting Sundarbans? We're talking about ocean sea levels rising. Is that impacting? We're talking about the cyclones. Many of them emerge in the Bay of Bengal. How are they impacting the Sundarbans?
Ajanta Day is an environmentalist who has been working with the local communities to revive the mangrove forests of the region, home to over 4.5 million people.
Mike, it's a huge impact, I would say, because the cyclone hits, the big winds and the waves, they lash on the embankments, which are actually the lifeline for the people of the Sundarban here. And what climate change is doing is we are having increasing number of storms and cyclones. We had 2009, Ayla, and then in last 2 years, 3 cyclones we have faced, Bulbul, Amphan, Yash, and everyone is coming with a higher dimension. What we have understood is that mangroves are the very critical component in this delta, and they are actually nature's own way of building the coastal resilience.
It is the women from the villages here who have come forward to protect their homeland. Collectively, they are planting mangroves and showing the way forward in mangrove restoration.
We go for around 6,000 plants per hectare. So just imagine 4,500, 5,000 hectares we have planted with a huge amount of effort and work with the communities. They have taken the ownership, they go to the field, they do the monitoring, they control grazing, all the anthropogenic, the disturbances that happen in that area. So they control all this and they try to mitigate the problem.
Restoring the mangroves has been crucial to the survival of fishing communities. But human interference and climate change have also impacted the migration of the iconic Hilsa fish, key to the economy of the region. Love for Hilsa in this region is timeless. Culinary tales of the Mughals report that in Kanpur and Allahabad, the emperors relished the Hilsa and looked forward to its arrival every monsoon. But over-exploitation, decrease in water flow and pollution have impacted the migration of the Hilsa.
আজ থেকে 10-12 বছর আগের কথা বলছি যে ইলিশ মাছ একদম নেই বললেই হয় তখন করে কিছু মানুষ অন্য কাজেও ফিরে গেছে দূষণটা অনেক কমতে কিছু মাছ এখন করে কিছুটা মাছ আসছে হ্যাঁ তাতে করে আমরা কিছুটা মাছ পাচ্ছি
Hilsa is the favorite fish here, high prices and popular with most and much in demand. But unfortunately, the population of Hilsa in these waters is dwindling and people are concerned and so are scientists. We meet Dr. B.K. Das today, who is helping to restore, bring back the Hilsa in these waters. Wonderful to meet you.
Thank you.
How nice. Absolutely brilliant. This is one of the top dishes of West Bengal.
Yeah, most of the Bengalis favored, and in all rituals, rituals in festive occasions, in marriage, everywhere they give. And National Mission for Clean Ganga has initiated the activity on this. Most of the thing is entrusted to Shefir in the ranching.
For the ranching of the Hilsa, the fish is cultured in a confined and controlled environment and released back in the Ganga when they are mature adults ready to breed.
And another aspect, we are doing the tagging, fish tagging, so that you see because of Farakka barrage, somewhat the migration has stopped and we are difficult to find. The first mission activity was to re-establish its migratory pathway. When fish in the aqua life, in the riverine systems, it re-establishes its populations, definitely will increase the oxygen in the river.
The dedicated programs to revive the Hilsa population and community efforts to save the mangroves reflect a larger mission to protect this unique region and the many lives connected to it. For the future of the Sundarbans, the threat of diminishing forests, rising seawater, cyclones and storms can only be tackled through sustained efforts every single Mike moves upstream from the Sundarbans to the plains of northern India in search of one of the most unique mammals on the planet, India's national aquatic animal, the elusive Gangetic dolphin. He is headed to Bihar, the land where Gautam Buddha is said to have found enlightenment under the Bodhi tree. Over the centuries, pilgrims and travelers such as Farhian and Hyun Sang crossed Bhagalpur on their journeys across India. Just like these remnants of the past that adorn its banks, the Gangetic dolphins command a special place in ancient legend too. In popular mythology, the hybrid water-dwelling creature on which the deity Ganga travels is often believed to be the Gangetic dolphin. After a dark period of near disappearance, in recent times, the Gangetic dolphin has been spotted thriving in certain stretches along the Ganga basin, indicating the improving health of the river in this stretch of the basin. Mike meets dolphin expert Dr. Sunil Chowdhury to find out how the dolphin has made a comeback.
This region, Vikramshila area, is the ultimate and the largest home of the Gangetic dolphins, and the Ganga supports this life form. Why do they congregate here?
They prefer deep water, clean water. So Bhagalpur Ganga water is relatively clean also compared to the upstream.
We had heard stories that once upon a time dolphins used to be killed and their oil used to be sold for various ailments.
Because of the sustained awareness campaign, now the people and the local stakeholders, particularly the fishing community, they are well aware that dolphins are their friends. Because where there is dolphin, it means there are fishes also. We have experimented in recruiting the dolphin mitras, local fishermen, and they were doing surveillance of the river. Any illegal activity, they used to report to us and we reported to the forest department. So being at Bhagalpur, we used to make surveillance of the entire 65-68 kilometers.
The Gangetic dolphin today faces an uncertain future in the face of degraded habitat and impeded migration. But citizen volunteer groups trained by institutions like the World Wildlife Fund and the Wildlife Institute of India are tackling the issues of poaching, fishnet entanglements and river pollution.
जो गंगा में निवास करने वाले जीव हैं उनका संरक्षण कैसे हो, इसके लिए हम एक वॉलंटियर के रूप में नमामि गंगे और WII के द्वारा प्रशिक्षित किया गया है। फिर हम अपने आसपास जन स्थानीय लोगों के साथ प्रतिनिधि स्तर पर और फिर विद्यालय स्तर पर अवेयरनेस लाना शुरू किया, जागरूकता कार्यक्रम, ये सारा चीज़ धीरे धीरे बढ़ता चला गया।
You've been studying dolphins for decades. So do you see the number decreasing or do you think there's an increase?
When we started the work, the baseline data was 95 to 98 dolphins in the sanctuary. And now it is approximately 200.
So it's a success.
It is a success story, Mike. It is a success in case of endangered species. It is almost, you can see the increase by 100%.
Spotting wildlife in its natural habitat is a dream for any conservationist. Dr. Sunil takes Mike on a river watch. Maybe for a moment, the elusive star resident of the sanctuary will give a rare glimpse of itself. And there it is. This gentle creature of the rivers, safe in its natural habitat. The people of Bhagalpur and the Vikramshila Gangetic Dolphin Sanctuary have not only given the Gangetic dolphins, but several other threatened animals a fighting chance.
In the entire world, there are only 3 breeding ranges of greater adjutant. One is in Kadwa Diara in Bhagalpur, the other one is in Assam, the third one is in Cambodia. We receive birds in different stages of illness or injury. Tens and tens of garuds have been, greater adjutants have been treated here and released into the wild. So during the monsoon season, because the snakes also come out, the rescue calls increase. And in the winter season, we do get a lot of rescue calls for birds because that is when the migratory bird season comes in. And in the winter season, that is also the time when the water starts reducing in the shallow riverbeds. So there is a possibility of some dolphins being stuck in shallow riverbeds. So this way, different seasons give us different challenges as far as wildlife is concerned.
Once again, it goes to show that if you give nature a chance, it bounces back. All we've got to do is to take the first step towards conservation and protection.
Before the next destination, Mike stops at the waterfront promenade of Patna. known as Patliputra back in the day. It is one of the oldest cities in India and an important stop in the journey of the Ganga. Millions gather here every year to celebrate Chhath Puja, when the Ganga takes the form of a mother. The banks of the river that were once laden with debris and dirt have now been made into a flourishing promenade for people to spend time by the water in the safety of modern improvements. Building a connection between people and the river could be the very key to a successful rejuvenation mission. Ever flowing, ever changing, and yet the same. On its journey, the Ganga flows through the land that Mark Twain once called a city that is older than history, older even than legend, the city of Varanasi. Surrounded by 88 ghats, Varanasi welcomes thousands of devotees every day. People come here to take a dip in the sacred waters, to be purified, to be healed, and even to spend their final moments. Flowing through this ancient city, the mighty river slows down, as if to take in life and death, colors and festivities, faith and beliefs.
The most sacred river on earth. I remember standing here, watching it, the Ganges, along with my father, many, many years ago. Where is the Ganga that I saw? Mother of all mothers, giver of life.
Over the years, a lack of proper infrastructure and unabated pollution had made Varanasi one of the most polluted stretches along the river. Add to that a steady flow of thousands of visitors all the year round. These ghats are cleaned regularly by a group of committed citizen volunteers. They remove litter from the ghats that could otherwise end up in the river, indicating a change from within the communities, coming together to protect their beloved river. And innovative methods are being employed to address various issues, such as ritual flowers, the biggest waste generated by offerings to the river every day.
We now have a mechanized system where every day our vehicles go to temples and we collect flowers. These flowers are brought to our facility. Then these flowers are washed, and then these flowers are sun-dried, pulverized, and made into incense.
क्योंकि ये फूल जो हम लोग मंदिरों में चढ़ाते हैं, वो फूल जाके हमारे गंगा जी के पानी बर्बाद करते हैं, और वो अगर हम लोग को काम करने का अवसर मिला है, तो इससे अच्छी कोई बात ही नहीं हो सकती। गंगा जी का पानी हम लोग भगवान ही मानते हैं।
जग के पालने तुलियली अवतार गंगा जी, पूरी चरणन में हमरा नमस्कार गंगा जी।
Another committed group of citizen volunteers patrol the river on a boat, the Jalaj. trained under the Namami Ganga mission. They raise awareness among the local population and make a living by selling their handmade products on these floating boats. While citizens devotedly clean the ghats, reviving this massive river is no easy task. Participating in Ganga rejuvenation is the Ganga Task Force, a group of specially trained personnel of the Territorial Army. Colonel Vaidya, working with the mission to clean the Ganga, gives an insider's view to how this is being made possible.
There are two major challenges what we have as far as the rejuvenation of river Ganga is concerned. One is the land which is being eroded by the floods whenever it takes place in the river Ganges. Second is the drains which are flowing into river Ganges.
To treat toxic waters from the city drains, the Ganga Task Force has implemented sewage filtration methods. Plastic bottles are recycled to make floating beds called biofloats. Saplings of plants like the water hyacinth are placed on these floats. These absorb the heavy metal pollutants in the water, releasing clean, treated water from the tank.
Presently where we are standing in the village Kundla, here we have started plantation and almost 6,000 slips have been planted and about 300 trees we have planted here.
Urban forest is what we need.
Absolutely.
And that's where it comes from.
So they are going to act as a lungs in the city.
And also bring the temperature down.
Temperature down, absolutely. Temperature, pollution, and all aspects of biodiversity will also revive in the city also.
The important link in this rejuvenation mission is the involvement of the common people, the real stakeholders in the future of the Ganga. And a turning point for the Namami Ganga mission was the 2019 Kumbh Mela, when the world began to take notice.
In 2019 Kumbh, they anticipated probably 10 crore people or 100 million people, but because of the purity of the water which was ensured there, and because of the facilities of toilets etc. which were provided by Namami Ganga, we had over 200 million people visiting it. This is a record of sort, and that has been acknowledged by many pilgrims and the religious leaders who had visited that place during the Kumbh.
A timeless connection between the Ganga and its people has existed for centuries. With an ever-increasing population to feed, who will feed the Ganga to keep it healthy for the times to come? On the outskirts of Varanasi, several farming villages around the river are turning towards organic methods, putting a stop to toxic pesticides making their way to the river.
पूर्ण ऑर्गेनिक या पूर्ण जैविक ये जो है मतलब 3 साल उसमें समय लग जाते हैं।
किसानों की इसमें धीरे धीरे जागरूकता बढ़ रही है और वो जैविक खेती की तरफ आ रहे हैं।
And authorities, like the National Mission for Clean Ganga, will aid in this transition through solutions like organic fertilizers made from sludge, a byproduct of sewage treatment. In the near future, there is hope that pollution from agriculture runoff into the river can be curtailed. Millions of litres of toxic wastewater were being released into the Ganga every day from countless sources, from residential clusters, offices, factories and farms, taking away the life of the river. To understand the infrastructure being built to tackle this, Mike visits the industrial hotspot, the city of Kanpur in the state of Uttar Pradesh. The pollution of the river reaches its apex here and poses a tough challenge to government bodies. And most of this untreated, deadly water has been released into the Ganga through the city's largest open drain, the 128 years old Sisamau Nala that runs through the heart of Kanpur.
Kanpur has been a kind of symbol of pollution in Ganga for decades. People used to refer to Kanpur that agar Kanpur, if you can clean Kanpur, then perhaps Ganga can be cleaned. And Sisamo was a kind of symbol of pollution because 140 million liters per day, this raw sewage used to go into the Kanpur almost like a kind of waterfall. So we started dividing the problem into small problems and started diverting this flow into different STPs. One is Bingavan, which has 210 MLD capacity and working at a much lower capacity, and also Jajmo. Jajmo is having a cluster of STPs. So we utilized these capacities and diverted them, and a stage came when Sisamo got completely dried up.
Today, untreated domestic sewage is one of the biggest challenges in cleaning the Ganga. G. Ashok Kumar of the National Mission for Clean Ganga has been leading the Namami Gange program that is deploying about $2.6 billion in various rejuvenation projects across the Ganga basin.
There are very unique experiments which have done in the Namami Gange and found very successful. One of them is the hybrid annuity model in the STP sector. Operator or concessionaire who takes up the project has to build it and run it for 15 years. We ensure that the payment is based on the quality of water which is coming out of the STP. The second very important initiative was the One City, One Operator program, where all the STPs in the city would be managed, operated and run by one concessionaire who will be responsible for the quality of water coming out from the STPs.
The enormity of this challenge could only be experienced by seeing it. Inside the plant, a stream of untreated wastewater gushes in through inlets of the receiving chambers. Here, plastics and solid waste are separated from it. The water is then pumped up to go through an anaerobic treatment process to be made free from pollutants.
How do you deal with this sewage? Well, there is no other way but to ensure that each city and each town addresses the sewage coming out of households, out of industry, out of commerce, is treated. You need a wastewater treatment plant that deals with this sewage. But the wastewater treatment plant then has to be embedded in a network, and the network is what brings the sewage into the wastewater treatment plant to be cleaned. So what we're doing in the World Bank is we're investing $1 billion in helping clean up the Ganga, in ensuring that we're invested in wastewater treatments.
Increased sewage treatment capacities are now being planned in most hotspots along the basin, from Rishikesh and Varanasi to Patna and Bhagalpur, to ensure that the untreated sewage does not flow into the river. The toxic wastewaters from the factories of Kanpur are another serious impediment. Here, the common effluent treatment plant is taking care of just that, treating chemical waste from more than 300 tanneries that discharge their toxic effluents into various drains. The Ganga Basin is the largest river basin in India and drains an area of about 1 million square kilometers. Rejuvenating a basin this size is a gargantuan task, and in 2010, the Government of India roped in the best minds for the job. A consortium of 7 IITs that was tasked with preparing a plan to revive the Ganga.
Scientifically, when we look at Ganga, we just don't consider Ganga as these three streams or the main stem of Ganga, but Ganga is a body which is made up of thousands of streams. So when we looked at this plan, we took the top-down approach. We looked at the main stem of the Ganga and kind of developed a strategic plan as to what can be done to restore Ganga.
To understand the complexity and diversity of a river this enormous, it would be key to map the entire river basin. Without precise data, conservation efforts can hit roadblocks. LiDAR, a technology that uses laser light to recreate an accurate map of the basin, could help find solutions.
Warm welcome for the afternoon session. So before we start, can we have a huge round of applause? Come on, ladies and gentlemen. So yet another interesting case study that you're going to witness now. The topic is dam failure case study, lessons learned. So ladies and gentlemen, it's my privilege to introduce our chair for this session, Mr. Reading Shimre, who's a member and ex officio additional secretary to the Government of India at the Central Water Commission, Ministry of Jal Shakti. He's a civil engineering graduate from BIT Mesra with over 3 decades of distinguished experience in the water resource sector. Sir's expertise includes water resources planning and management, hydrological studies, flood forecasting, river morphology, coastal erosion management, and dam safety. So sir has played a key role in the implementation of dam rehabilitation and improvement program and has contributed significantly to the design and appraisal of major irrigation infrastructure, including barrages and canals. So ladies and gentlemen, please give a huge round of applause for Mr. Shimre. A louder round of applause. Come on, ladies and gentlemen. Now it's time for me to introduce our co-chair, Mr. Anup Karanth, who's a senior disaster risk management specialist at the World Bank, where Sir provides technical and operational support to the disaster risk management program in India. In this role, he supports the design and implementation of both pre-disaster risk reduction initiatives and post-disaster recovery operations, while also contributing knowledge, learning resources, and technical solutions for government counterparts and development partners. With more than 23 years of professional experience, he has worked extensively across Asia on disaster risk management programs, spanning policy, operations, and institutional strength. So please welcome our co-chair, Mr. Anup Karanth, sir. Can we have a louder round of applause, ladies and gentlemen? Now it's time for me to introduce our speakers, Mr. Vivek Tripathi, sir, who holds a BE and M.Tech in Water Resources Development from IIT Roorkee and joined the Central Engineering Service in 1993. Sir comes with extensive 26 years of experience in hydrometeorological observations, investigation, design, and planning of national and international waters resources project. Sir's notable contribution include projects such as Salma Dam, Afghanistan, Rajiv Sagar, MP, Durgavati, Bihar, Lakwar and Renuka, Himachal Pradesh, and Saptakoshi projects in Nepal. Sir is also a member of International Commission on Large Dams, ICOL, contributing to embankment and cofferdam committees. Sir has served as chairman of BIS committees on water conductor systems and dam and spillways, and currently chairs committees on canal system and hydropower structures. Please welcome Vivek Tripathi, sir, with a huge round of applause. We also have Mr. Rohit Gupta, sir, who's a Deputy Director at the National Dam Safety and Central Water Engineering Service Officer of 2018 batch, specializing in hydrology, dam safety, and urban flood risk management at the Central Water Commission. Sir has conducted design flow review studies for major dam projects under Dam Rehabilitation and Improvement Project and appraised pumped storage project areas across multiple states. Sir has developed 2D hydrodynamic models for urban flooding in cities. such as Patna, Gorakhpur, Guwahati, and evaluated flood risk proposals for several Tier 1 and Tier 2 cities. At NDSA, he has formulated standard operating procedures for reservoir filling and dam safety evaluation. Sir is also developing dam risk assessment framework and was part of the expert committee investigating the Luti Dam failure. So, ladies and gentlemen, please welcome sir with a huge round of applause, Mr. Rohit Gupta. Next in line, ladies and gentlemen, we have Lavanya. Miss Lavanya, who's currently serving as an assistant engineer with TNRWD, contributing to quality control and geotechnical investigations across Tamil Nadu. Ma'am holds a master's degree in hydrology and water resources engineering from Anna University, Chennai, and a bachelor's degree in civil engineering from Government College of Engineering, Coimbatore. Ma'am has practical experience in geotechnical and water resources engineering with a strong focus on soil investigation and lab testing. Her expertise includes soil property testing and analysis, bearing capacity and settlement assessment, and foundation design. Ma'am is also experienced in investigating in site investigation, subsurface exploration, and borehole logging. So please welcome Lavanya ma'am with a huge round of applause. Next, ladies and gentlemen, we have Mr. Hurt, who is an accomplished water resource professional with a strong foundation in hydrology and water management. Sir holds a Bachelor of Science in Engineering and Master of Science in Water Science and Engineering, specializing in hydrology from UNESCO, Netherlands, one of the world's leading institutes for water education, with a career dedicated to sustainable water resource utilization and irrigation development. Mr. Hurt is currently serves as a Director of Irrigation Water Management in the Irrigation Department of Sri Lanka. In this leadership role, Sir oversees national water management strategies, irrigation scheduling, and the optimization of reservoir operations to support agriculture and rural livelihoods. His work integrates hydrological modeling, climate resilience planning, and stakeholder coordination to promote efficient and equitable use of water resources. Mr. Hurt's contribution reflects his deep technical expertise and commitment to strengthening Sri Lanka's water security and irrigation systems in the face of changing hydrological and climate conditions. Welcome, sir. We also have Ms. Malini Preeta, who's currently serving as an assistant engineer with professional experience in geotechnical and water resources engineering. Ma'am holds a master degree in hydrology and water resources engineering from Anna University, Chennai, and bachelor's degree in civil engineering from Meenakshi Sundararajan Engineering College. She is involved in a geotechnical investigation, including soil testing, embankment analysis, and suitability assessment for infrastructure projects across Tamil Nadu. She has experience in environmental monitoring and subsurface investigations, including borehole logging and foundation analysis. Earlier, she worked as a flood modeler trainee at Ecofor Services Limited, contributing to hydrological analysis, hydraulic modeling, and floodplain mapping. Ma'am's technical skill includes site investigation, soil properties testing, bearing capacity analysis, and foundation design. So, ladies and gentlemen, now we present to you dam failure case studies, lesson learned, the technical session. Over to chair and co-chair. Please give a huge round of applause for all the speakers, and chair and co-chair, please.
Good afternoon, everyone. Yeah, it is a privilege to welcome you to this post-lunch session on dam failure case studies and lessons learned. You know, today we have converged here for dam safety, so that dam failures do not occur. And the paradox is that we're going to talk about dam failures because dam failure had occurred because of various reasons. When a dam fails, the consequences, we all know that the it is devastating, causing loss of life, environmental damage, economic setbacks, and lots of social impacts. And when it comes to this evening, I think we are the most privileged team, because we are represented from our opposite genders also, equally represented, and we are really privileged. We have our ladies presenters also. It is a post-mortem. It is going to be a post-mortem analysis. And we have in the morning, and yesterday also, we have been all along discussing about the similarity of dams with human body. Today, it's going to be a post-mortem analysis of what had happened after occurrence. That of the dam failure had occurred. And I'm sure, because we have good surgeons, very expert, of 30 years experience in who has deal with the dam designs. So it'll be a good experience. I mean, experience sharing and experience learning for all of us. Dam failures and recent challenges is now related. It's increasingly we are confronted with related to climate change. We can see, now we all know Tista 3 dam incident in Sikkim related to GLOF. Can say that related to climate change. Because of climate change, unprecedented rainfall and GLOF events, these are the new challenges which we are facing now. And making these structures resilient. The question is, can we make our existing dams climate change resilient? Yes, we can. But making these structures resilient, it is possible, but it'll be possible also, but it requires actionable work, like data collections, data farming up, going to history records, analysis of history records, and then structurally expanding the spillways, retrofitting for higher discharges, and runtime operational rules. So we can look forward to, what we have to look into is, we have to look forward to proper database, going back to historical records, and with that, I think we will be able to get into all these design assumptions. This has all been covered, but at the cost of repetition, because this is important, because what has been done during the initial design stage, hydrological assessment, assumptions, and geological uncertainties, and what has been assumed at that stage, all these are important factors. And if we take into account all these things, we'll be able to mitigate the risk. We'll be able to, and if you integrate these aspects, like review the hydrological designs, design floods, we'll be able to mitigate climate change, the risk, and will be able to tackle the climate change, the disasters. As professionals and stakeholders in dam safety, we share a collective responsibility to ensure that such incidents are minimized through sound engineering judgment, regular inspections, timely maintenance, and adopting modern monitoring technologies. One thing we have seen in the morning also that most of the dam failures is not structural based, but is mostly decision based. And with these few words, I look forward to our experts who will be presenting with the practical cases. Thank you once again.
Ladies and gentlemen, please put your hands together as I welcome Mr. Anup Karan sir, Senior DRM Specialist, World Bank, and Dr. Raj Gopal sir, Senior WRM Specialist, World Bank. So ladies and gentlemen, I'm so sorry. We have our first presentation with a case study of Karam Dam failure, lessons learned by Mr. Vivek Tripathi sir, who's a CA and CWC. Please welcome Vivek sir with a huge round of applause.
So, good afternoon. This incident took place in year 2022. Failure of Karam Dam, a case study done. Actually, this case study is also we will learn the structural aspect and side by side the disaster management also. So we'll come. It's a medium irrigation project on Narmada, and it's 42 kilometers from the district headquarters Dhar. So these are the salient features. It's a 42 meter high, a composite dam, and during construction, it has not been constructed fully, but partially when it was in construction, it was filled. So at the filling time, because generally we first construct whole dam up to a certain height, means dam top, then we close the section. River closure we took place after the construction of dam. Here they did what they partially constructed this dam, and even section was not fully constructed, and they closed the dam. So during this closure, the impoundment of water was about 15 MCM. So this is the layout of the dam. It is a composite spillway portion, and this is the embankment portion, right side the embankment portion. So it's a 398 meter earth dam and 192 meter this concrete dam. So what happened during this filling? The distress appeared on the downstream side. So this is the condition. There was a slow failure and this type of condition of seepage. Even so, you can see very well that migration of the particle took place during this seepage. So when migration of the particles took place, so there is a disaster for this dam failure. So 18 villages were evacuated at that time. So 14,000 people were evacuated due to this probable disaster. So at that time, August was there. So rainy season was in full swing. So people bound to live in the rainy, means during rain, in the outside. So early solution of the situation, controlled flooding was expected from CWC, that we have to evacuate this dam. So minister and senior officers on state all were present there. Even Chief Minister of MP was directly in touch with us. So these options were explored. First suggestion was to blast the spillway portion. So, but it took time because it's the reinforced section. So it would have taken much time. Then one suggestion was then we can cut the embankment from middle. So this option was turned down because we have no control over the erosion, uncontrolled erosion, because both sides, left and right, were exposed to the flowing water and also from the bottom. So there is no controlled discharge of water. So it was turned down. Then finally it was agreed upon. Then from the right side, where the hillock is there, because on the other abutment side, hillock, this rock is at higher level. So at least we can protect one side because it is rock, and from in bottom is also rock. So we decided to cut down that section from the right. So it was started on 13th August. So everybody was on toes. Administration was very alert at that time. Military was there, NDRF was there. Finally, channel extraction was done on the right side. Planes was deployed to excavate this section. And finally, when it was completed, then water started flowing from this section. Second one. So after this, from the right side, the widening of the section from the right embankment was done, and discharge was increased with time. And finally, this was the position. So we were safe from the right side because there was the rock. In the bottom there was a rock. Only left side vulnerable for the erosion. So we could discharge this water. We could empty this whole dam 15 cubic very safely. So if I discuss this structurally, so it was not designed as per the section. If you see this section in the next slide, so this was upper side was the design section, but the construction was taken in this way. They have placed this casing up to 302 level, and this blue portion they put core after this. Even they have not compacted the whole section in one go. So in embankment dam construction, we generally compact the whole section upstream to downstream. So this was a main flaw. This is the highly unconventional construction. So conclusion, overall this exercise was well coordinated of all stakeholders like central and state government, Central Water Commission, NDSA, and district administration, and villagers, of course, because they have evacuated their houses from their houses. Early intervention of the higher authorities, it was a central case because Prime Minister and Home Minister was seeing, keeping eye regularly and time to time, very regularly. The standard practice of construction needs to be followed fully, because if we want to avoid this type of disaster, then the standard practice of construction should be followed. And consultation of the water resources sector experts in the planning and execution of such projects can very well omit the arising this situation. So if we see the gravity of this situation, we can see this media because Chief Minister.
हृदय से बधाई दे रहा हूं यहाँ बैठे CS, DGP, ACS, इरिगेशन होम और वहाँ फील्ड पर उपस्थित हमारे तीनों मंत्री तुलसी सिलावट जी, राजवर्धन दत्तीगांव जी, डॉक्टर प्रभुराम चौधरी जी, कमिश्नर IG,
जो प्लान प्रशासन की तरफ से बनाया गया था उसमें सफलता मिली और धीरे धीरे पानी छोड़ने की शुरुआत की गई और सारा पानी डैम से लगभग निकल गया है। हमारे साथ बातचीत करने के लिए यहाँ पर दो मंत्री हैं, राजवर्धन सिंह दत्तीगांव जी हैं और तुलसी सिलावट जी हैं। सर, सबसे पहले तो काफी सफल रहा अब ये ऑपरेशन, अब क्या स्थिति है और किस तरह से इस ऑपरेशन को सफल किया है?
अभी करीब मेरे ख्याल से रिमेनिंग 15 MQM पानी था, मुश्किल से मेरे ख्याल से 4 MQM बचा होगा और अब फ्लो सामान्य सा हो गया है। ड्रॉप हुआ है करीब 297 जहां मेजरमेंट था, अब करीब 284 तक आ गया है, मेरे ख्याल से 284 तक आ गया है। विभागीय मंत्री जी यहां हैं, कल झंडा वंदन करेंगे और मुख्यमंत्री जी के निर्देशन में पूरा स्टेप बाय स्टेप प्लान सिस्टमैटिक कार्य हुआ। पूरी टेक्निकल टीम को, डावर साहब की पूरी टीम को बहुत बधाई, बहुत शुभकामनाएं। जब हमने रात को 1 by 1 मीटर का कट लगाया था।
थैंक यू।
Thank you so much, sir. Now, ladies and gentlemen, please put your hands together as I welcome Mr. Anup Karan, sir, Senior DRM Specialist, who will be presenting on implementation of Emergency Action Plan. Please welcome him with a huge round of applause.
Good afternoon, and I'd like to thank the organizers for having me here. I will be talking a brief on the EAP implementation and where the big bottlenecks are. I'm not going to give a case study, but I want to highlight in terms of how the DRM operations actually take place. There are a few good examples where we are trying to integrate through other DRM projects. I work very closely with the DRIP project internally within the bank. The DRM team and the water team has collaborated now to look in terms of how we can actually operationalize the EAPs that have been prepared. With that background, I just want to quickly highlight the broad content of my presentation. I will give quite of a glimpse into the operations that we do under the DRM, because the way how the DRM operates and the WRD operates is fairly very distinct, and there is a reason behind why some of these things are not getting integrated. From a practical perspective, for the last 20 years, having worked with several disaster management agencies, I do see there is an opportunity now for integrating these things. The risk information decision making within the disaster management departments are fairly different in terms of how they operate. They also have to operate at a much larger level by getting a large number of departments to come together during the time of crisis. So they do have certain protocols and mechanisms which needs to be activated should the integration happen. The end-to-end early warning framework and the flow mechanism for impact-based forecasting, this is something now which is very new to the system, especially in the revenue department and the disaster management authorities. So it's important to understand what the systems are and how this integration can happen. There are two clear opportunities that I see, having worked for the last 10 years into the World Bank operations and also working with some of the SDMAs. We do see there is an opportunity to operationalize EAPs at the level of the Emergency Operations Center and the District Emergency Operations Center. And we just saw in the video the kind of processes that has to be put in place in order to deal with emergencies. And lastly, to look in terms of how we can bridge the gaps. Well, the Dam Safety Act, is very interesting in terms of, how it has been formulated. There are some very interesting terminologies in this particular section. Section 35 actually talks about flood warning systems, talks about public, it talks about risk assessments, it talks about EAPs. But the real challenge has been that, how these things can flow into the systems of the revenue department and the SDMAs. I'm not sure if there is anyone here. I mean, is there anyone from the revenue department or from the SDMAs here today? Anybody can raise the hand? So I don't think anyone is here. I think this is again very important, when we look at from the perspective of, operationalizing it, who is going to operationalize it? It's not always the dam authorities who are, well, I mean, there's a responsibility there, but downstream impacts, getting the district administration to move, the activation of the incident response systems, these are very, very critical in terms of how we want to handle emergencies. So despite what has been given in the Act, in terms of, who has to do what, I think there's a lot that still needs to be done in terms of activating this process. I'd like to highlight that there are some very interesting documents. Obviously, there is a lot of documents that is produced by the Central Water Commission under the program of DRIP. Otherwise, these documents, 15 years ago, there was nothing like this which was operationally available with the departments. We are trying our best from the DRM institutions to see how these documents can become a part and parcel of their regular operations. So the guidelines are interesting, but it is important that how we can take each one of these small little pieces identified in this particular document into the operational window of different institutions. Having said that, what we see are three broad areas as key barriers. And I'm just not trying to highlight any gaps within any institution as such, but what I've definitely seen is that a lot of the documents which are typically data-driven, they're not tool-driven. And interestingly now, SDMAs are becoming tool-driven kind of an institution. So one of the things that we need to understand is how we can activate all the EAPs into a kind of a formulation by putting in some kind of a tools which are operational at the level of state, district, and up to the level of the village. There are also incident response systems put in place. India has adopted incident response system guidelines. There are very clearly identified IRS systems put in place, but the IRS is something that needs to be further operated, considering the kind of inputs that can come from the EAPs. There's also a kind of a weak integration linkages that we have seen. The EAPs are not really written into the documents of the state disaster management plan and the district disaster management plans. For a department to be active in terms of operationalizing it, it's important that the EAPs are integrated within the system of the SDMPs and the DDMPs. The public communication channels, there are large number of channels that are available. I mean, people use WhatsApp, people use different kind of methods, but I think operationalizing it for an event like dams and a dam break kind of a situation, I think you have a very short window to operate and release the communication protocols. I think there is a lot that needs to be done here. The role clarity of the emergency support functions, I mean, as I mentioned, there are a large number of emergency support functions that are actually put across the incident response hierarchy. And that hierarchy brings in about 15-20 departments to coordinate, to manage an emergency response. And that is another big challenge where these things have to fit into the departmental functions. The institutional governance gaps are primarily around interoperability issues. There are no unified SOPs. There are SOPs, but they're not unified across the departments. There is a need to also strengthen these SOPs. There's a bit of a role ambiguity when it comes to dealing with multiple hazards. Sometimes these events are not just single-driven hazard as flood. There are multiple hazards which gets triggered along with that. There could be a potential wreckage of a particular infrastructure. So how do we deal with that downstream impacts? I think there is still a lot of need to look in terms of how do we deal with multi-hazard events. The limited community preparedness is something that personally I have seen it downstream. I mean, it is not only for dams and other events, but by and large, a lot of disasters are not very much understood by the communities. There is a need to involve them right from the beginning. Technological data gaps are existing. There is a lot of work that can be done, and we have been hearing this in the last sessions too, in terms of how data services can be integrated. The point that I want to highlight here is that there are a lot of scenarios being developed in the EAPs, and I think that's a very beautiful exercise that the departments have undertaken. But these scenarios means you need different kind of response systems to be activated. So a lot needs to be done in terms of how we can operationalize this through breaking the barriers. This is a very standard way of how the disaster management operations happen. And I'm just sorry, I mean, it may be very different from how you operate at the departmental level, but there are certain decision points that are a function of the Department of Disaster Management or the SDMAs, and there's a very standard emergency phase in which they operate. But what you see in the middle portion is a set of action points, and these action points typically brings about 15-20 departments to coordinate to stage a response. So that is where I think a lot of this EAP's integration has to happen at the preparedness mitigation phase, at the response phase, as well as the recovery phase, and that detailing has to be still worked out. The end-to-end early warning system is a kind of a framework that many of the disaster management operations are now staggered. In the last 10-15 years, a lot of work has happened, and the end-to-end early warning system is one kind of adopted framework within the disaster management institutions, starting from observation to data analysis to prediction to risk assessments, which is captured in the form of EAPs, and then the potential impact is something that they need to have it upfront. The scenarios that we have created has to be part and parcel of the impact assessments in terms of what are the potential impact in terms of people getting exposed and infrastructure to be exposed, and the downstream information in terms of how you formulate warnings across the communities, how do you disseminate it, and you have to prepare the response also. The NDRF, the SDRF, they all come at a later time. When the event happens, you don't have NDRF and SDRF at that point. In case you have a good lead time, yes, they are there. But in many of the cases, the NDRF and the SDRF usually comes a couple of hours later after the event. So what I mean to say here is that if you have a good sense in terms of the inundation potential, you need to have that information protocols in place to alert that communities at risk. For example, lightning as an event is something that happens very randomly. It can happen within few minutes. You don't have warning for lightning like the way we get it for cyclones or for other events. But interestingly, India has put a system in place to alert communities within the lightning zone. So something like that. In Karnataka, we have an app called Sidilu. And whenever there is a possible lightning strike, the communities around that particular area get this warning in 15 minutes. less than 15 to 20 minutes to get that warning. A similar kind of system can be adopted here. If a potential breach is something that is going to happen, one can actually activate it. I would like to basically say that there are very interesting systems that are currently operational. This is the opportunity number one, which is creating decision support systems which are functioning. These are all functioning systems right now, barring the last two where it is under development. In Odisha, Andhra Pradesh, Tamil Nadu, and Uttarakhand, a lot of these emergency operation systems are currently working. And I'll quickly take through some of those pictures. These are real pictures from the state of AP and Odisha and Assam, Kerala. It's all combined together. There are a bunch of tools that are currently available for taking your EAPs directly into the systems. So that is what we want to work in the next 6 months to 1 year. We would essentially like to target through the interventions under the DRM portfolio and the World Bank's water portfolio to see how we can integrate systems way into the operations of the Emergency Operations Center, the SEOC, and then further down to the District Emergency Operations Center. There are a wide number of communication protocols that are available today. The Common Alert Protocol, the cell broadcast systems, these are all available. How do we take the EAP integration into those protocols is another step that we want to start working on. That is something we are targeting in a couple of states using the existing technologies. Satark is a system, as I mentioned. This is operational in Odisha, fantastic system. It actually reaches out to last mile. It informs people when there is a high level of risk. There is also a system in Andhra Pradesh. This is a system which is called AP Cosmic. There is a system flow diagram which integrates SEOC and the District Emergency Operations Center and the Taluka Operations Center. This is the system which is currently operating in Tamil Nadu called Tamil Nadu Smart, where there is a possibility to integrate. This tool development has got a time span of about 15 years. They started in 2018. It is supposed to complete in the year 2030. So there is a possibility to also integrate the EAPs into this particular tool. We have systems currently available in Uttarakhand. There are also some very interesting things being done. I want to basically stop here for a moment and let you know that Surat had a kind of a very big floods, I think in 2006, if I'm not wrong. And then subsequently, they looked in terms of how do we alert the release from Ukai to people. And then they started working in terms of doing a kind of a very detailed flood modeling. The municipal commissioner spent a lot of resources, time, and brought in a lot of agencies to work on it. And what was interestingly done was to look at how Ukai's release can be actually communicated to people by marking it at different heights. I think this kind of marking is very, very important so that people can relate in terms of what is the potential release and what can get inundated. So I'll just say that this is an opportunity for also all of us to conclude that we can integrate all this thing into the EOC. The second thing is to integrate at the level of the disaster management plans. And these are all the kind of plans that are prepared by the WRD, but also by the SDMP. Right now, the integration is not happening, and there is a possibility for us to look into it. I'd like to lastly summarize by basically saying that there are 6 points I want to leave behind in terms of what we intend to do. One is to have EAP protocols, which we need to put in place. Though there is available, but I think we need to standardize these protocols. We need to have an EAP platform so that everybody can start using it. The DSS for reservoir operations is something which has to be made more impact-based. And we ought to look in terms of how we can integrate that whole process with the SDMP, the district disaster management plans. Obviously, capacity building around emergency response is still not a great work where we see this activity going in. So the role of NIDM, SIDM, and other institutions become critical, and we need to ensure that we have annual exercises and test these protocols and these plans. Thank you.
Thank you, Anup. Now, we have next is Rohit Gupta, no? Yeah, Rohit Gupta, no, I think we have Rohit, take your time, but we have really very limited time, and we have to confine to around 6 minutes. Let's try to finish up in around 6 minutes.
Good afternoon, everyone. Today I'm going to tell you a story of a dam failure. The dam that breached not because of its age, not because of the heavy rainfall, not because the safety inspections protocol were not in place, but it breached because everything that was supposed to generate the alert, that failed. It's a story of Luti Dam failure. I'm Rohit Gupta from National Dam Safety Authority, and I will walk you through the case study. Actually, it's the older PPT. So let me tell you a brief about the Luti Dam. Actually, it's a small dam with a catchment area of about 5.5 square kilometer. The height of the dam was around 12 meter and the gross storage of about 0.44 MCM. The spillway capacity was around 53 cubic. The spillway was ungated and it was in the form of waste weir. So it's still the same. Can you please change the PPT? Okay, anyway, I will continue. So,
Rohit, Rohit, 340. Okay. If you have presentation problem, we can take another one and come back afterwards. Okay, let some next speaker, then we can go. Grant? Yeah. There's another. There's a message. There's a message that we have to wind up within 10 minutes. So you may have to reduce your time to around 3-4 minutes.
okay, sir, no issue. So this is the Luti Dam. It's situated in the Balrampur district of Chhattisgarh. So it's an earthen homogeneous embankment dam, operational since 1982, but it breached on 2nd September 2025 and resulted in a tragic loss of life of 6 people. So this is the video of Luti Dam, as you can see. So the total length of the dam was around 700 meter, and it was completely washed away for about 44 meter length in the middle section. So the dam had already undergone the 2 separate safety assessments before the failure. The first one was the RRSD, which is the initial risk screening, and the second was the Dharma. In this initial risk screening of the Luti Dam, the score which was given to the Luti Dam was around 18%. It's a low score. Low score means low risk. It means no red flag. And again, the second safety assessment which was given was the Dharma. In this pre-monsoon inspection performed for the Luti Dam, it was classified as category 3 dam. It means the dam is having minor deficiencies and which can be recovered during the year also. So officially the dam was declared safe, but it failed eventually. So what went wrong with the dam? The post-failure investigation committee recommended a totally different picture of the dam. As you can see, the failure committee recommended that the failure was due to the piping action, which was triggered due to the spillway itself. So the condition of the spillway is like this. This is the waste weir, as you can see, and this is the ring bund which was constructed in 2018 around. This is a major technical blunder which was done on part of the dam owner. So this is the total profile of the waste weir. The waste weir was of length of around 73 meters, and for this particular portion, this is the effective length of 25 meters for which the spillway was actually functional. For the rest of the length, for about 48 meters, the spillway was obstructed. So the next triggering point was the rainfall event. It's a small, it was actually a small rainfall event of about 2 to 3 hours in the evening, or in the evening, the day the dam breached. So this rainfall event, prior to the failure of the Luti Dam, the dam was already at the FRL. And this rainfall actually resulted into the rise of reservoir level because the spillway was already obstructed. So it resulted into the rise of water level, which actually increased the hydraulic pressure on the dam. And through this, water intruded by the pre-existing weakness present in the soil, present in the embankment portion of the dam. And these weaknesses were like erodible sandy core, the critically reduced crest width, the significant animal burrows, and the historical sinkhole which was present prior 7 to 8 years back, and it was actually filled with 50 to 60 soil layers at that particular time, and later it did not get any address. So these are the photographs which I have taken from our visit. You can see. So this is the burrowing hole which was present at the breach section only. And this is the crest width. The actual design crest width of the dam was around 3.5 meters, but the actual width was less than 10 feet. So this is a sinkhole which was present in the upstream phase of the dam near to the sluice well, which indicated the early stages of internal piping. This is the condition of crest portion. You can see the gully erosion formation was already taking place. This is the burrowing hole which is adjacent to the breach section of the dam. Next, these are the burrowing holes which are present at the dam site.
Rohit, you can go to the recommendation recommendation part.
So the dam failed actually, and the dam had already undergone the two kind of separate safety assessment, as I earlier mentioned, the Dharma and RSD. So why did the dam fail? What were the causes which led to the dam failure? So actually I want to just tell that the fault was systemic. The Dam Safety Act came with a grand vision of having to move from the ad hoc or reactive maintenance approach to a proactive risk-based informed safety assessment with a mandatory framework of practice safety inspection with a non-negotiable, and we have with the institutional framework, which I'm not going to discuss, but it did give a promise to us. So I am quickly come to the conclusion point. So the whole concept of the paper was like, I just wanted to demonstrate the profound systemic gap between the India's robust safety assessment tool like Dharma and RSD and the ecosystem in which they are being implemented. The LUTI did not fail because the risks were unknown. It failed because the known risks were misinterpreted, downplayed, and ignored. So the reason, the systemic gaps in safety culture, in the sense of ownership, in the risk sensitization, and again the institutional memory. So I have done a comparative analysis. I'll just quickly finish in 2 minutes. I have done a comparative analysis of the failure investigation report and the safety assessment which was performed using the Dharma and RSD tool. And I will quickly share you the results of these 3 comparative studies.
Come to the recommendation or conclusion point.
So this is the finding with respect to the spillway. As you can see, the failure investigation recommended the dam is already, the spillway is already constructed, but in Dharma it was rated as capacity was sufficient, and the RSD given a 14% score only. And with respect to embankment, the investigation suggested the dam is having a critical deficiency in the crest width, in the sinkhole, in the animal burrows, but Dharma suggested the dam is having good condition with a nil and 0 piping. So what was the fault? Do we need to change the tools like RSD and Dharma, or do we need to change the ecosystem? The tools are good, the tools are made in a very robust manner, they are as good as it can be implemented. So the change we need to make is in the competency and the monitoring plan, in the automated escalation point with respect to the red flags. We need to change the safety culture and responsibility. We need to enhance the sense of ownership, the risk sensitization, and the institutional memory. And further, the way forward, I would like to say that the Dam Safety Act provides the framework and the robust health diagnostic tool like Dharma and RSD. The challenge is now the cultural and institutional, ensuring these tools are used with utmost sincerity to raise unignorable alarms. India is moving from the reactive to preventive dam safety approach, maybe slowly but certainly, and we have to ensure that the next potential duty is identified, acted upon in time, and saved. Thank you.
Thank you, Rohit. Now, Lavinia can take your time, but it has now come to around 4 minutes.
Good afternoon. Myself, Lavanya, Assistant Engineer from Tamil Nadu Water Resources Department. Our study is about the distress analysis carried out in Anekuttam Dam. In this, we have conducted geotechnical and geophysical investigation to find the cause and to suggest remedial measure. This Anekuttam Dam is located in Virudhunagar district of Tamil Nadu. This Virudhunagar is a semi-arid tropical region. It experiences high temperature and receives only moderate rainfall, and its average rainfall is 811 mm. This area is geologically covered with black cotton soil with concrete nodules in it, and it is followed by rock strata, known as gneiss rock strata. And this Anekuttam Dam is constructed across the river Arjuna, and it is a composite dam. Coming to the hydraulic particulars of this dam, the total length is about 2940 meter, and the earthen embankment is about 2823 meter. The maximum height of embankment is 9.5 meter. And the maximum depth of storage can be 7.5 meter with a gross storage capacity of 0.13 TMC. The nature of distress in this embankment is sinkhole formation. In the year 2021, field engineers observed a sinkhole in the embankment near the right abutment, and they also felt vibrations in the embankment. They said the storage of water in the reservoir is about 6 meter, and they experienced a heavy rainfall of 6.5 centimeter on that particular day. As a temporary remedial measures, the field engineers filled the sinkhole with locally available material, and they reduced the depth of storage to the safer limit. However, the sinking was continuing with the soil particle leaching from the weep holes in the downstream abutment. This analysis was carried out in 3 stages. For the first stage, we have conducted geotechnical investigation for the embankment, and in the second stage, we have tested dispersive character for the bed samples collected. And finally, to get the overall outlay, we have conducted geophysical investigation. After the formation of sinkhole, the State Dam Safety Organization Committee inspected and felt that this is a serious matter of concern, and if it is unnoticed, may result in a catastrophic failure. So they suggest to conduct geotechnical investigation. For this, we have drilled 3 boreholes in the left embankment and 3 boreholes in the right embankment. The samples were tested in the laboratory to identify the profile of the embankment. In the left embankment, we could observe a layer of clay sand at the top, and it is followed by clay of high plasticity. It represents that the embankment is formed as a zoned embankment with a proper layer of casing and hotting zone. And in the right embankment, a borehole was drilled at the location of sinkhole formation. In this borehole, up to the depth of 5 meter, we found clayey sand, and a special condition is noticed during the boring operation. The hand auger was, a sudden movement of augers was noticed at the depth of 3.5 meter. With these 2 conditions, we can observe that it is the filled up material after the formation of sinkhole, and the sudden movement is due to the not proper compaction of the filled up material. At the depth 6 meter, we encountered hot strata and noticed white gravel-like particle known as concur material. This concur is a calcium carbonate material found at the bed of the dam. With this, I ask Ms. Molly to continue the presentation.
Good afternoon all. Due to time constraint, I'm just skipping the slides. So in order to understand the subsurface condition and to arrive at the most feasible repair methodology, geophysical investigation was carried out. Also, drilling of test boreholes in the already distressed portion was not advisable. So electrical resistivity tomography survey and multi-channel analysis of surface wave were conducted. Electrical resistivity tomography maps subsurface materials by measuring the electrical resistivity. Electrical resistivity depends upon the degree of fracture, the porosity, the density, and the concentration of dissolved salts. And multi-channel analysis of surface wave maps soil stiffness and bedrock depth by determination of the shear wave velocity. This shear wave velocity is further used in the determination of SPT n value, which can further help in determining the relative density of the embankment material. So these are the locations of geophysical investigation carried out in Anekuttam Dam. A total of 8 electrical resistivity surveys and a total of 12 MASW test points were conducted on the upstream, top of the bund and downstream of the embankment. Electrical resistivity was carried out for a total length of 115 meters, involving 24 electrodes at a spacing of 5 meters. Similarly, MASW was carried out for a total length of 69 meters, involving 24 geophones at 3 meter spacing. So the depth of exploration in both the surveys was about 30 meters. This is the combined analysis of geotechnical and geophysical survey carried out on the right embankment. It can be observed that from the ground level to a varying depth of 5 to 10 meters, a low resistivity zone is seen, and this corresponds to moderately compacted soil or weathered rock with moderate moisture in it. And this within this low resistivity zone, a moderate resistivity zones can be observed. And this corresponds to the location where the sinkhole was formed. Because the sinkhole was filled with locally available materials, this is at a comparatively better compacted state. Below the low resistivity zone, we can find a high resistivity zone, which indicates weathered rock in its dry state. Within this reach, 3 MASW surveys has been conducted. From MASW 6, the shear wave velocity is less than 350, which indicates that the strata is very poor. Similarly, the same thing has been conducted for...
Malini, yeah, we just have to come to the recommendation or concluding part.
Yes, sir. I'll just take 2 more minutes.
We have
Similarly, in the left embankment, the same was carried out. And 3 layers can be found, which the first one is low resistivity zone representing poorly compacted soil, followed by moderate resistivity zone, and then high resistivity zone. So from the intrusive and non-intrusive geotechnical investigation, it was found that the soil strata below the bund consisted of a distinct layer of calcite, and that is soluble in water whenever the pH was less than 7. The distress found in Anekuttam Dam is because of dissolution sinkholes. Dissolution sinkholes are depressions that are formed whenever water, especially acidic water, dissolves the soluble bedrock, especially limestone. So that is the phenomenon observed here. The loss of lime from the substrata combined with the leakage process causes subsidence of the overlying soil strata, causing sinkholes. So the suggested remedial measures are complete removal of the weaker zones. The weaker zones has been determined by the electrical resistivity survey and MASW survey, and complete removal of the following stretch. Also, because the bund rests on limestone formation, identifying proper cutoff mechanism in the form of concrete diaphragm wall is essential. Thank you for the opportunity.
Thank you, Lavini and Lavinia. Yeah. Now we have a last speaker. I request Herod, to take the time, but we're almost over. So if I take another, you can take 5 minutes.
Good afternoon. I will explain the two reservoirs behavior in this Ditwa cyclone that last November Sri Lanka experienced that cyclone, that is downfall is over 500 millimeter within 2 days. So I am explaining how to the two reservoirs, how to behave and how to manage this large inflow to these reservoirs. I am selecting two reservoirs. One is the Daduruwa reservoir that is situated in the Daduruwa River Basin. This is the Daduruwa Reservoir Basin. In top of this reservoir, there is 3 major reservoirs also there. So this is the technical features of this Daduruwa River Basin. Total catchment area is 2,600 square kilometers. Annual discharge to this C2 that is 1,200 MCM, million cubic meters. So this is the Daduruwa reservoir. Then this is the technical data of this reservoir. This is commissioned on 2014. That catchment area is 1,400 square kilometers. Storage is 75 MCM. Peak inflow, that is calculated 500-year return period, that is 3,500 cubic. Total bund length is 2.4. There is 8 radial gates. So this is the observation point just above that rainfall and inflow to these reservoirs. You see this, there is a 251 millimeter rainfall in 26. Like that day, we received a large amount of rainfall above the Dhruva catchment. This is daily water level variation. You see that 26. There is the water level is 70 MCM. Then the sudden raise in up to over that full supply level, that is above 0.5 meters. This is a spill discharge. You see this about 120 cubic we received within 2 days. That 2-day period continuously we discharge, that is 120,000 cubics. When we compare in this total discharges, you see this annual discharge to see normal condition, that is 1,200 MCM. But within these 4 days, that is 700 MCM we discharge from that Dhruva reservoir. This is water level variation that November 27th and 28th, that is water level go up to the full supply level. That's reached to highest flood level. This is the comparison, this total annual inflow to this reservoir within 4 days, that is 790 MCM. Tank capacity is 75 MCM. Average annual discharge to the sea 1,200. So we are managing this much of large amount of inflow to this reservoir without breaching this reservoir by operating that spill gates. Then this is Rajangana, because time is passing, I am go speed. This is Rajangana reservoir and to do 3 reservoirs upstream of the Rajangana reservoir, and this basin is Kalaway basin. This is the schematic diagram of this inflow and reservoir situated just above the Rajangana reservoir. There is 30 radial gates in Rajangana reservoir. This is that is construction in 1966. This is the technical data. That capacity is 100 MCM. There is 30 radial gates. This is the daily water variation in that during the Dhruva period. You see this water level goes above around 0.6 meters from that is full supply level. You see this is 0.75 actually. That means nearly that bund top level, that water level reached to bund top level. This also that spill discharge variation, maximum 80,000 cubic we discharge continuously 2 days time. This is the rainfall and that water level variation comparison. You see the water level goes up to near to BTL level, bund top level. This is comparison that annual average discharge that Kalaway, that 435 MCM, but tank receive within 4 days that 490 MCM. But however, we are managing this large amount of inflow to this reservoir without dam breaching. These are due to this reservoir discharges, there is some bus also got inundated, something like this is the disaster. So experience of that Dhruva cyclone, we can summarize as this one. This prevailing SOP, that standard operation practice, are enough for we want to reconsider. And 1,000-year return period for spill gates are okay, or we want to reconsider about this one. And then maintaining the reservoir water levels, safety of downstream dwellers, and protecting some water for cultivation. This is the one problem we want to manage. And then the rainfall data, accuracy of rainfall data, spatially and temporally, we want to consider. That's all. I want to thanks for that all the that Karnataka government and other officials and other peoples from here, because we are from Sri Lanka. You are asking for participation in this event from Sri Lanka, and we get some experience, and we get good lot of ideas, and we can share our experience with you. Thank for this opportunity.
Thank you, Harold, for summing up your presentation well in time. We have around 2-3 minutes, so we can either take one question then, or two questions. Question is,
Yeah, you are basically asking that the changes that was made in the
changes
act.
in amendment, and I think so that has to be incorporated in this Dam Act also.
Yeah.
Maybe that.
I think in the previous act, I think what was not really very well captured was the role of the urban local bodies. I think that has been now amended into the act. That is the one big change that has happened. However, what I would definitely say is that each city will also now prepare a city disaster management plan. Earlier, it was not something called mandatory, but some cities actually prepared the DM plan. It is similar to how you prepare a SDMP and how you prepare a DDMP. I think what is typically need to be done is that in the case of all the flood-related disasters and the point that we touched upon today on the EAPs, if the EAPs are prepared, the EAPs have to be an integral part of the DDMP and the SDMP and the CDMP. There are also GPDMP. I mean, there are many other DM plans. I think the more important role that any authority has to do now is to work with the emergency support function department, like the water resource department, and bring that as part of an actionable agenda. Thank you.
Thank you.
Yeah, I'm from Water Resource Department, Karnataka. You have been mentioning about the revenue department when you were mentioning. And actually in Karnataka, we have something called disaster resilience framework based on the Sendai framework. So in that, definitely Water Resource Department is fully integrated into it. And then we have functions separately listed and all those things.
Just like to add a point here, sir. So when I look at all the SDMAs by large, so I'm working very closely with Orissa, Assam, Himachal, Uttarakhand, JNK, also with Karnataka on the Karnataka Water Security Resilience Program. I'm also co-TTL on that project. We're working very closely with KSNDMC, the Karnataka State Natural Disaster Monitoring Center, which has 30 years of its establishment, in terms of its capability and, its operations. And they're fairly good in terms of, advancing warning to certain communities at risk, depending on the scale of the event. But what I've not been able to capture very well, and this is a point that we're discussing with KSNDMC, with the Revenue Department, and with KSDMA, to see how we can take all the EAPs that was prepared under the DRIP program, especially in the case of Karnataka, and get that into the State Emergency Operations Center's decision-making process. And we have put a timeline in the next 6 to 12 months with the government of Orissa on the Hirakud, and as well as in Karnataka with certain dams where the EAPs are there. We want to see that integrated first into their system. And that is a kind of a time-bound agreement that we have under a separate program, which is financed through the World Bank. It is the P4R operation. Thank you.
Good here, because we have no more time. Up here. Following is some valedictory function. So with this, we conclude this session. Yeah, thank you all.
I request Anup Karan sir to please summarize the session.
We're really short of time, so let me quickly take a few points here. I think I won't summarize on the case studies as such, but let me just see what the best possible points to convey here. I think one of the key takeaway from this session is that what I've at least understood is that the dam failures are rarely the result of single point technical defects. They emerge from a combination of engineering vulnerabilities, as it was discussed, delays in certain decision-making processes, as well as weak operationalization of emergency protocols, especially when it comes to the EAPs. And I think that was very clearly evident from some of the case studies that was presented. From the Sri Lanka episode, at least what I can make out is that the increasing climate variability and the extreme rainfall events, especially on the dam infrastructure, is under tremendous stress, and I think there is a lot that needs to be understood from this case study that you presented, sir. In conclusion, I want to basically say that the dam safety must be treated more as a broader governance, risk governance priority, and for that we need to also look at strengthening the institutions, operationalizing the EAPs through the drills, build field level capacity at the level of the engineers. I think this point was also taken up yesterday in some of the sessions, and integrating the dam safety into the disaster risk management systems. That should be a collective way forward for all of us to endeavor and work towards it. Thank you.
Thank you so much, sir. Now, ladies and gentlemen, please put your hands together as I welcome Shri Baleshwar Thakur, sir, Director General, National Water Development Agency, to please join us on stage to do the honor for our chair, co-chair, and speakers. Please welcome, sir, with a huge round of applause. Welcome, sir. First, to start off with our chair, Mr. Shimre, sir, member DNR CWC, to please join us. Please give a huge round of applause. Thank you so much, sir, for joining us. Next, I request Shri Anup Karan, sir, Senior DRM Specialist, World Bank, to please step forward and collect the honor. Now, ladies and gentlemen, it's time for us to honor our speakers. Please put your hands together as I welcome Mr. Vivek Tripathi, sir, CE, CWC, to please join us. Next in line, we have Shri Anup Karan, sir, Senior DRM Specialist. Okay, can we have Shri Rohit Gupta, sir, DD NDSA? Next, can we have Ms. Lavanya? Next in line, we have Ms. Malini Preeta. And we also welcome Shri Hert, sir. Herat, okay, Mr. Herat. I'm so sorry for that. And last but not the least, our session in charge, Samarth Agarwal, Director, CMDD, NNW, CWC, please. Mr. Samarth Agarwal. Thank you so much, sir. Can we have a huge round of applause for the entire panel? Thank you so much, gentlemen. Thank you so much, ladies. Now, ladies and gentlemen, I request everybody to please stay back for the valedictory ceremony. That's going to start now. I request people who are standing outside to please join us inside. With this, I take a leave, but we have other set of anchors who are joining for this. My name is MC Bhanupriya. Thank you so much. And I'll see you again. Thank you.
Respected dignitaries and delegates, here one request from all of you. Tomorrow, those who are willing to come to Mysore, already enrolled through proper channel, the buses will come to the respective hotels. Once again, I request you be ready by 8:45 a.m. to 8 a.m. The buses will going to departure around 8:10. Then it will reach 11 by Hotel Radisson Blu. From we are going to have tea, and then we will move towards Chamundi Temple, and from temple to palace, palace to again Radisson Blu Hotel, we will have lunch, from lunch to KRS, and KRS back to Bangalore. So once again, I request you all of you cooperate. well within that time.
ICET, Indian Institute of Science, Bengaluru. Dams as national infrastructure systems. Dams are among the largest and most complex infrastructure systems ever built. They operate continuously over many decades under changing loads, uncertain geology, and evolving land use, land cover, and climate conditions. In India, thousands of dams together regulate rivers, protect downstream populations from flood risk, support food, energy, and water security to hundreds of millions of people at a national scale. From construction to life cycle safety. The challenge today is no longer just building dams, but managing them safely over their entire life cycle. Hundreds of dams are operating at or well beyond their design life. Issues such as degradation of core construction materials and foundations, changes in flood potential, and seismic loading grow with dam age. Dam safety has therefore evolved into a critical and complex, multifaceted, challenging problem. For risk-informed decision-making, insights on risk to dam are desirable from comprehensive and integrated risk assessment approaches. IISc and the Department of Civil Engineering. Addressing such a complex, challenging problem requires strong scientific foundations. At the Department of Civil Engineering of the Indian Institute of Science, Bengaluru, faculty with strong backgrounds in diverse areas such as mechanics, materials, geoscience, hydrology, hydraulics, computational modeling, and water resource systems have long...
Well, ladies and gentlemen, we have now come to the grand finale. I could see some of our esteemed delegates stationing themselves outside. I would request all of you to please come inside and take your seats, because this will be the concluding aspect of a highly illustrious and successful conference. We already have our chief guest for the valedictory function, Shri V. Somanna, Honorable Union Minister of State for Ministry of Jal Shakti and Ministry of Railways, is coming onto the stage. I would request other dignitaries also to please come over. Shri Subodh Yadav, Additional Secretary, Ministry of Jal Shakti, Shri Anupam Prasad, Chairman of the Central Water Commission, Government of India, Shri Pradeep Kumar Agrawal, Joint Secretary, Ministry of Jal Shakti, Government of India, Shri Thomas Edward Bryant, the Senior Dam Specialist of the World Bank, Shri Krishnamurthy B. Kulkarni, Secretary, Water Resources Development, Karnataka, Shri Paul O'Connor, Chair, Dam Safety, New South Wales, and Professor Satyam Suwas, the Dean of Mechanical Sciences, ISC. Well, the Honorable Minister wants me to welcome you all in Kannada. I did the same yesterday. So, ತಮಗೆಲ್ಲರಿಗೂ ಮತ್ತೊಮ್ಮೆ ಈ ಸಮಾರೋಪ ಸಮಾರಂಭಕ್ಕೆ ಆದರದ ಹೃತ್ಪೂರ್ವಕ ಸ್ವಾಗತ ಸುಸ್ವಾಗತ. Well, ladies and gentlemen, you would all agree with me that the conference of this nature and stature would go a long way, wherein different countries congregate at one place, they learn from each other's failures and successes, but ultimately it would strengthen the global dam safety culture and enhancing resilience, the purpose of this all-important conference. On behalf of Ministry of Jal Shakti, Government of India, Water Resources Department, Government of Karnataka, in association with the Central Water Commission, IISc Bengaluru, and World Bank. I am Shankar Prakash, extending a very, very warm welcome to all of you to the valedictory function of International Conference on Dam Safety 2026. A very hearty welcome to all of you for this valedictory function. As per the tradition of our wonderful nation, at the outset, I would request the Secretary of Water Resources Development, Government of Karnataka, Shri Krishnamurthy Kulkarni, for the welcome address. Please welcome Mr. Kulkarni.
Good afternoon. I am Krishnamurthy Kulkarni, Secretary, Water Resource Department, Government of Karnataka. And it is my absolute pleasure to extend my warm welcome to this valedictory ceremony to all the esteemed guests present here. As you know, dam safety is no longer confined to routine inspection. It's a multi-dimensional challenge involving climate resilience, technology governance, and security. This international conference on dam safety 2026 highlighted the core issues related to dam safety aspects, management and regulations, the emergency action plans, and related aspects with insights and vision. I would like to mention that this conference has launched its dam safety chartboard yesterday, water data visualization portal of NWIC, followed by release of publications of CWC and ACIWN of Government of Karnataka. Now we have reached a final stage. We are towards the conclusion of this international conference on dam safety 2026, and in this valedictory ceremony, I extend my warm welcome to respected Sri Somana Sir, Honorable Union Minister of State, Minister of Jal Shakti and Railways, Government of India, who has consented to grace this valedictory conference, sir. Sir, ತಮಗೆ ಆದರದ ಸುಸ್ವಾಗತ ಸರ್, ಕರ್ನಾಟಕ ಸರ್ಕಾರದ ವತಿಯಿಂದ. Now I heartily welcome Sri Subodh Yadav sir, who is an officer from Karnataka Cadre, Additional Secretary DOWR, RD and GR, New Delhi, who is instrumental in coordinating this event jointly organized by Government of India and Government of Karnataka. Tamgu kuda ಆದರದ ಸುಸ್ವಾಗತ sir. I also welcome Anupam Prasad, Chairman, Central Water Commission, who was presented journey of dam safety in India and role of DRIP in the plenary session. Sir, please, hearty welcome to you also, sir. Now I welcome Sri Pradeep Kumar Agrawal sir, Joint Secretary DOWR, RD and GR, Government of India, who has been a key person for organizing this event, duly guiding and supporting the officials of Government of Karnataka since beginning of this event. Sir was guiding every day before the commencement of this session. Thank you very much, sir, and hearty welcome to you, sir. Now I welcome respected Sri Thomas Edward Brent, Senior Dam Specialist, the World Bank, who is kind enough to participate in this event and has shared his views on the innovative solutions to dam rehabilitation in the today's morning technical session. Welcome to you also, sir. Now I welcome Sri Paul O'Connor, Chair of Dam Safety, New Southern Wales, Australia, who is also a cricket enthusiast and fan of Royal Challengers Bangalore. He presented an insightful overview of the dam safety regulations mechanism in South Wales, Australia. Now I also welcome Sri Satyam Suvas, Dean, Indian University of Science, Bangalore. The IISc has extended its valuable support in organizing this event successfully in their prestigious campus known across the world. Welcome to you also, sir. I also welcome all the delegates, speakers, innovators from around the world and India, special invitees, officers from Government of India, other states, State of Karnataka, as well as our event sponsors for being part of and contributing to the success of this international conference on Dam Safety 2026. I also welcome the media, police, security staff, volunteers, and all other invitees gathered here and provided valuable support in organizing this event. Thank you very much.
Thank you, Mr. Krishnamurthy Kulkarni, for extending a cordial welcome. On behalf of the entire team, please accept the felicitations and also welcome to you. Well, ladies and gentlemen, at the climax, or whatever you call the culmination of this all-important conference, we all will be thinking about what exactly we have derived of the deliberations which has taken place during the last 2 days. For this, I would request Shri Anupam Prasad, the chairman of CWC, and also the additional secretary, DO, WR, RD, and GR, for giving us an insight into the takeaways of the conference. I would request Shri Anupam Prasad ji to take over. Over to you, sir. Mr. Subodh Yadav will do the honors in this regard. Gottu Karnataka sir, nene meet madide sir. Mattomme Karnataka swagata sir.
Thank you very much. ನನ್ನ ಹೆಸರು ಸುಬೋಧ್ ಯಾದವ್ ಅಂತ ಈಗಾಗಲೇ ಹೇಳಿದ್ದಾರೆ, ಆದರೆ ಸ್ವಲ್ಪ ಏರುಪೇರಾಯಿತು. ಫಸ್ಟು ಅದು CWC ಚೇರ್ಮನ್ ಅಂತ ಹೇಳಿದ್ದು, ಆಮೇಲೆ ಎಡಿಷನ್ ಸಿಕ್ಕಿದ್ದು. ತೊಂದರೆ ಇಲ್ಲ, ತಮ್ಮ ಗಮನಕ್ಕೆ ತರ್ತಾನೆ. ಸರ್ ಕನ್ನಡದಲ್ಲಿ ಸರ್ ಒಂದೆರಡು ಮಾತು ಹೇಳಿ, ಆಮೇಲೆ ಇಂಗ್ಲೀಷಲ್ಲಿ ಮಾತಾಡ್ತೀನಿ. ನಾನು IAS ಆಫೀಸರು, ಕರ್ನಾಟಕ ಕಾಡರ್, ಆದರೆ ಸದ್ಯಕ್ಕೆ ಗೌರ್ಮೆಂಟ್ ಆಫ್ ಇಂಡಿಯಾ ಅಲ್ಲಿ ಇದ್ದೀನಿ, additional secretary agi. So since it's an international conference where the delegates are there from various countries, it would be more logical to speak in English. So I will bring forward certain points which were discussed in the last 2 days. Lot of issues have been discussed. Lot of points have been discussed. And you people have literally worked very hard in terms of really detailing so many things which is happening as far as the dam safety aspects are concerned. Now, on the basis of various presentations which have been done, my team has tried to come out with some of the takeaways. I can't guarantee that it's a comprehensive kind of a thing, but we have tried to cover up as much as possible within a very limited time frame. Honorable Minister, sir, with your permission, I will go ahead with this small presentation. So out of the various points which we have discussed, we felt this is the utmost need of the hour, where we need to have the synergy between the union, state, and the dam owners level. I think nothing is possible unless and until we have synergized efforts. And there is an urgent need of integrated dam safety framework which can bring together the technical, financial, and institutional mechanisms to enhance overall dam safety governance. Priority is to be given to sustainability and systematic operation and maintenance to reduce safety risk and rising life cycle cost caused by the deferred maintenance. Risk assessment of dams assist in identifying potential failures and further consequences. This combines engineering analysis, probability, and consequences, resulting into improved decision making. It will help in prioritizing investment for undertaking risk reduction measures. For moderating floods, there is a need for coordinated reservoir operation at basin level. Reliable inflow forecast system is one of the technical challenge, which through dedicated research needs to be improved. This system would also help in effectively dealing with challenges related to increasing climate variability and extreme hydrological events. The initiatives taken by Karnataka and Andhra Pradesh for cascade operation of their own set of reservoirs is a welcome step in this direction. Scaling up of digital operation, dharma, rapid risk screening of specified dams, etc., for real-time monitoring, risk indexing, compliance tracking, and decision support. Platforms to give artificial intelligence-enabled features to process voluminous data for meaningful analysis. Establishment of sustainable financing mechanism for inspection, monitoring, and rehabilitation. Capacity building on monitoring and analysis of instrumentation data and using the same for dam health assessment and rationalizing the rehabilitation measures is the need of the hour. ICDS to play a proactive role in this regard. Geophysical techniques are cost-effective, non-invasive technologies for diagnosing anomalies in a dam structure. However, careful selection of the technique and the combination of techniques along with a skillful interpretation of the result by the subject matter experts is really critical here. Compatibility-driven rehabilitation aims at scientific and engineering harmony between the existing substrate structure environment and the proposed external rehabilitation interventions to have a durable repair and rehabilitation. A data-driven structured approach in phases for dam rehabilitation from concept to implementation involving all stakeholders can significantly improve timely, cost-effective, and safe rehabilitation of existing dams. Sediment management in the reservoir in a holistic and sustainable manner is the need of the hour. For expediting assessment in a cost-effective manner, use of remote sensing for estimation of storage needs to be promoted. Wherever feasible, desilting on revenue surplus model or no-cost approach may be carried out. A number of dam owners in different states, for example, Rajasthan, Punjab, Kerala, Telangana, etc., are already carrying out such kind of activities. There is a need for applied research involving industry to explore the commercial use of degraded stressed material. Considering the hydrological safety issues and more than 85% earthen dams in the country, there is a need of innovative, cost-effective armoring materials to protect embankment dams from catastrophic failures in case of overtopping. Simplified dam break analysis and hazard assessment tool will be a swift and economic tool in generating a first-hand information for planning of more detailed studies considering the large portfolio of dams. Enhancement of emergency preparedness through enforceable emergency action plans, public awareness, and coordination with disaster management authorities is the need of the hour. And this was the point which was just mentioned, I think, in the previous session by one of the speakers. Non-structural measures such as updated emergency action plans, O&M manuals, floodplain zoning, inflow forecast system, flood early warning system are also equally important to mitigate the risk associated with the dams. So these are the certain points which we felt have come out from the last 2 days of discussion. In fact, there are various other points which are equally important, but we felt that these are the points which are really critical and needs to be taken forward. I really hope and anticipate all the delegates who have come from different states, not only from the different countries, must have understood the importance of these points, and I am sure once they are back in their state, they will try to emphasize the importance of these points in their hierarchy to the senior officials, and will try to move around, try to ensure these points as quickly as possible. Thank you very much.
Thank you, Shri Subodh Yadav, for those insights. Dhanyavadagalu. Well, ladies and gentlemen, the Honorable Union Minister of State for Jal Shakti and Railways is a dynamic, tall leader from Karnataka, and now he's heading as the Minister of State in Delhi. Please put your hands together and welcome the Honorable Minister Shri Soman.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. It is a very good occasion. Mr. Sri Subodh Yadav, Additional Secretary, Anupam Prasad, Chairman Central Waters Commission, Rajiv Kumar Agarwal, Joint Secretary, Thomas Edward Bryant, Senior Dam Specialist in World Bank, Sri Krishnamurthy, P. Kulkarni, Secretary, WRD, Karnataka, Sri Paul Wui, Chairman Safety, New South Australia, Professional Satyam, Dean Mechanical Science, IISc, and all dignitaries, Mr. Sri Sanchitaya, distinguished guests from various countries, member of Indian delegates from various organizations, office of the various department of state government and Indian government, ladies and gentlemen, media person. ಪ್ರಪಂಚದಲ್ಲಿಯೇ ಅತಿ ವೇಗದಲ್ಲಿ ಬೆಳೆಯುತ್ತಿರುವ ಮಹಾನಗರಿ, ತಂತ್ರಜ್ಞಾನದ ಕೇಂದ್ರ ಬೆಂಗಳೂರಿನಲ್ಲಿ ಈ 2 ದಿನಗಳ ಕಾರ್ಯಾಗಾರವು ಅತ್ಯಂತ ಮಹತ್ವದ ಐತಿಹಾಸಿಕ ಮೈಲುಗಲ್ಲಾಗಿದೆ. As we conclude the second International Dam Safety Conference, I express my sincere appreciation to all engineers, scientists, administrators, and partners who have contributed to this rich discussion. ಕರ್ನಾಟಕ ಜಲ ಸಂರಕ್ಷಣೆ, ಜಲಶಕ್ತಿಯ ಸದ್ಬಳಕೆ, ತಂತ್ರಜ್ಞಾನದ ಅಳವಡಿಕೆಯ ಮೂಲಕ ಸಮಾಜದ ಕಲ್ಯಾಣಕ್ಕೆ ದೆಹಲಿಯಲ್ಲೇ ಅಷ್ಟೇ ಅಲ್ಲ, ಇಡೀ ಪ್ರಪಂಚದಲ್ಲಿಯೇ ಕರ್ನಾಟಕ ಹೆಸರುವಾಸಿಯಾಗಿದೆ. ನದಿಗಳ ಮೇಲಿನ ಗೌರವ ಸಾವಿರಾರು ವರ್ಷಗಳ ಹಿಂದಿನದು. ನಮ್ಮ ನಾಗರಿಕರಲ್ಲಿ ನದಿಗಳು ಕೇವಲ ಸಂಪನ್ಮೂಲಗಳಲ್ಲ, ಅವು ನಮ್ಮ ಜೀವವನ್ನು ನೀಡುವಂತಹವು. In modern India, one of the greatest engineers who understood this responsibility was Sir M. Visvesvaraya. His work on the Krishnarajasagara Dam is a shining example of how engineering can transform safely. He believed that planning, discipline, and maintenance are important as construction. His legacy inspired us even today. Friends, under the leadership of our Prime Minister Sri Narendra Modi ji, India significantly strengthened its dam safety system. For the first time, the Dam Safety Act 2021, he provided our leader, Sanmanya Pradhan Mantri ji Narendra Modi ji. Surveillance, inspection, operation, and maintenance to specified dam across the country. The National Dam Safety Authority and State Dam Safety Organization are now working in a structured and accountable manner. Through DRIP, hundreds of dams have been repaired, strengthened, and modernized. The digital platform Dharm has brought dam data into a signal transparent system for monitoring and reporting. Under the leadership of C.R. Patil ji, our Jal Shakti Minister, a step have been taken to strengthen dam safety in the country. Greater emphasis was placed on real-time monitoring, risk assessment, and coordination between dam operator and disaster management authorities. The Central Water Commission strengthened the flood forecasting network in Himalaya River Basin. These measures show that we are learning from every incident and acting quickly. Over the last 2 days, we have discussed aging dam, sediment management, risk-informed decision making, hydrological safety, dam failure cases studies, and modern monitoring system. We have reflected on real experience from global rehabilitation project to lesson from dam failure. This discussion reminded us that dam safety is not only about concrete and steel. It is about people's lives, livelihood, and the environment. A dam is a monument of public trust. A dam is a monument of public trust. I congratulate all the scientists and experts for sharing their knowledge and experience with us. Looking ahead, we must focus on 5 clear priorities. First, risk-based dam safety. Every dam must be assessed not only by its age, but by the risk it poses of downstream population. Second, climate. With extreme rainfall events increasing spillway capacities and reservoir operation, rules must be revised scientifically. Third, We must expand the use of real-time seasons, remote sensing, satellite monitoring, and predictive models. Predictive model. Fourth, the union and state must work in full partnership. Data sharing and transparency are essential. Fifth, people living in downstream must know what to do case in emergency. Safety is completely won when citizens are informed. Let us let this conference send a strong message. India is committed to safe, sustainable, and responsible dam management. Our Prime Minister, Sri Narendra Modi ji, has repeatedly impressed the importance of water security. Water is not only resources, it is a shared responsibility. His word guide our approach. India today, 6,628 specified dam is there, making it the third largest dam in Karnataka in 231. मेरा एक सजेशन है, आप सब भी इंपॉर्टेंट ऑफिसर सुबह आपको मालूम रहता है, निम्न गोताग्तದೆ ತಿಳಿತದೆ. डैम सेफ्टी अभी चल रही, ये चलने का जल शक्ति डिपार्टमेंट मोदी जी 2019 में एक बड़ा एक पोस्ट भी क्रिएट करता है, एक जल शक्ति डिपार्टमेंट क्रिएट करता है. बाद में 2021 में इसको डैम सेफ्टी को भी यह को कैसा करना, क्या करना, कितने वर्ष का, ये सब भी करता है. मुझे थोड़ा थोड़ा हिंदी आता है, थोड़ा थोड़ा इंग्लिश आता है. मैं प्योरली कन्नड़ी का हूँ. बाद में मेरा इतने विनंती है, ओनली 1 year 6 महीने में मैं इतने हिंदी थोड़ा थोड़ा बात करता है. इसको यहाँ प्रेरण मेरा नेता राष्ट्रीय प्रधानमंत्री नरेंद्र मोदी जी. इसलिए मेरा एक ही सजेशन है, सुबोध यादव जी आपको मालूम है, CWC चेयरमैन है, ऑल सब कंसर्न सीनियर ऑफिसर एंड बहुत बहुत बड़ा डिस्टिंग्विश साइंटिस्ट सब भी इधर है. डैम सेफ्टी हो रही, उसको कैसा करना, क्या करना, ये सभी चिंता आप कर रहे. वर्ल्ड बैंक भी इसको कितने पैसा देना, क्या देना, आपका इसमें जाता है. मेरा एक ही निवेदन है, 50% सिल्ट है, किधर तो भी जाइए, कौन सा डैम तो भी जाइए. अब जाइए किसरा डैम को, नहीं तो तुंगभद्रा, किधर तो भी जाइए. नॉट ओनली कर्नाटका इन बट आल्सो इन ऑल ओवर इंडिया. इसलिए 6,628 डैम क्या है, कितना वर्ष का है, इसमें कितने तारीख क्या करने का. मुझे एक इंफॉर्मेशन है, राजस्थान में एक डैम का क्या कि ये शिल्ट रिमूव करने का क्या कि चिंता करको, उसमें वो सक्सेस हुआ, मुझे मालूम नहीं. वो थोड़ा अब ध्यान रखना. नॉट ओनली सेफ्टी, डैम सेफ्टी, इवन डैम में कितने % पानी रहता है, ये पानी का प्रीसियस कितने रहे, ये पानी इतने 50% सिल्ट रहे तो पानी कितने उधर स्टोरेज होता है, ये भी हम चर्चा करने का मौका है साहब. अब क्या करना, देश का बड़ा नेता आप सब भी इधर है, बड़ा ऑफिसर सब भी इधर है, ऑल साइंटिस्ट और टेक्नीशियंस आर हियर आप है. इसलिए मोदी जी एक बात बताता रहता है, ऑनरेबल प्राइम मिनिस्टर सब किधर तो भी गए तो बोलता रहता है, वाटर कंस्टेंटली बोलता रहता है, वाटर मैनेजमेंट एज ए जन आंदोलन. ये जन आंदोलन को फार्मर्स को 24/7 कुछ तो भी हेल्प करने का क्या तो भी मौका रहे, तो देश का एंटायर फार्मर्स का बैकबोन क्या है, आप सभी इधर बैठ को ही. इसलिए मेरा चिंता है, मेरा सजेशन है, कुछ तो भी कैसा आप डैम सेफ्टी कर रहे, वैसा भी सिल्ट ये करने रिमूव करने का कैसा करना क्या करना वो भी लेको एक भेजिए। CWC चेयरमैन इधर है, हमारा सुबोध यादव इधर है, सब भी बड़ा बड़ा आप सभी इधर है। दूसरा राष्ट्र में क्या क्या कैसा चल रहा है वो भी हमें चक्कर को कैसा करना क्या करना ये किया तो भी बहुत अच्छा रहता है। इसलिए मेरा विनम्र विनंती है, आई एम नॉट स्पीकिंग ये सब्जेक्ट टू माई एज ए पब्लिक कॉमन मैन, किधर तो भी डैम को जाइए, किधर तो भी जाइए, कितने कंप्लीट हो रहा है, बाद में 3 महीने में कंप्लीट खाली होता है। आज मैं मॉर्निंग में तुमकुर को गया था, तुमकुर सिटी का पानी आने का एक बहुत बड़ा टैंक है, उधर गया तो कितने है कि तो उन्हें बोलता अभी 2 महीने को नहीं होता है, इतने बड़ा है क्या है, नहीं सब सिल्ट बहुत है, कंप्लीट सिल्ट है, फिर कोई बाद में उसमें थोड़ा पानी रहता है। इसलिए ये बहुत बड़ा इंपॉर्टेंट है। PW साहब इधर किधर झगड़ा ही, अब सभी ये करना, अभी कावेरी कृष्णा का आंध्र प्रदेश कर्नाटका बाद में अभी ये कर रहे ना, ये सभी वो तो ये भी ये करना चाहिए। ये एक एजेंडा ले लिए हमारा नेता प्रधानमंत्री नरेंद्र मोदी जी, सबका साथ सबका विकास, सबका विश्वास सबका प्रयास, ये स्वामी जी का संदेश है। इसलिए आप सबको भी मेरा विनम्र विनंती है, देश में पानी रहे तो पानी का कितने प्रीशियस है आपको मालूम है, कंटामिनेशन कैसा हो रहा है आपको वो भी मालूम है, वो भी चर्चा करना चाहिए। अब एक टाइम जाइए क्या कृष्णराजा सागर के उधर से हुनसुर का पास जाए तो कैसा रहता है क्या रहता है, इधर ऑफिसर कौन है सबको मालूम है, इससे भी थोड़ा चिंता करने का जरूरत है। इसलिए वो भगवान है, मोदी जी का दूरदृष्टि चिंतन क्या है, 2021 में स्वतंत्र आको 75 ईयर्स आफ्टर 75 ईयर्स डैम सेफ्टी कर को सुबोध यादव जी उसको एक एक्ट कर को, वो एक्ट में इतने बड़ा काम चल रही किया तो हमें सभी मोदी जी का हमें धन्यवाद देना चाहिए। मोदी जी का क्या दूरदृष्टि चिंतन है उसको आप सभी भी मेहरबान करने का चाहिए। इसलिए मेरा विनंती है, अब कैसा आप डैम सेफ्टी का आप ले कोई सिल्ट का भी सीरियस में लेने का जरूरत है करके मेरा सजेशन है। अब कैसा करना क्या करना बाद में चिंता करेंगे। मेरा नेता हमारा मंत्री जी CR पाटिल जी इज ए वेरी ग्रेट मैन, अवर सेक्रेटरी कांताराव जी, अभी अच्छा टीम है, बहुत अच्छा टीम है। ये टीम में कुछ तो भी किया तो देश का कुछ तो भी होने का करने का होता है। कर्नाटका इज ए पार्ट ऑफ इंडिया, इसलिए मेरा विनंती है ये करने का बहुत अच्छा रहता है। I inspired by our ancient respect for river, guided by modern science, supported by clear law and technology. We will ensure this every dam remain a symbolic of development. Every dam remain as symbolic of development. Jai Hind, Jai Bharat, Jai Karnataka.
The Honorable Union Minister of State has complimented the efforts of all scientists, experts. At the same time, he has also given a clear roadmap for the future. Let's give a huge round of applause for the Honorable Minister for his inspiring and motivating address. Dhanyavadagalu, sir. To conclude, I would request Shri Pradeep Kumar Agrawal, Joint Secretary, Ministry of Jal Shakti, Government of India, for concluding remarks and words of thanks.
Distinguished Chief Guest, Shri V. Somanna ji, Honorable Minister of State, Ministry of Jal Shakti, Government of India, other dignitaries on the dais, esteemed delegates, experts, ladies and gentlemen. It's my privilege to propose vote of thanks at the valedictory session of International Conference on Dam Safety. Over the last 2 days, this conference has provided an excellent platform for meaningful deliberation, exchange of global best practices, and discussion on challenging in ensuring the safety and sustainability of dams. The technical sessions and interactions have been extremely enriching for all participants. I extend my sincere gratitude to our Honorable Chief Guest for gracing this occasion and guiding us with valuable thoughts. I express heartfelt appreciation to all the keynote speakers, experts, session chairs, and delegates from India and abroad for their valuable contributions and active participation, which have made this conference highly successful. We express our deep gratitude to the government of Karnataka, led by Honorable CM, Deputy CM, ACS Sir, Secretary Sir, for graciously hosting this conference and extending wholehearted support and hospitality, which has greatly contributed to the success of this event. I would also like to place on record our special appreciation for the support extended by the World Bank for its continued assistance in dam rehabilitation initiative and for its valuable cooperation in organizing this conference. I also sincerely thank the Indian Institute of Science for hosting this important international event and providing excellent academic and logistic support. My special compliments to the DRIP CPMU team led by Shri Rakesh Kashyap, the organizing and technical committees, and all supporting staff whose dedication ensured a smooth conduct of the program. With these words, I express my gratitude to everyone who contributed to the success of this conference, and I'm confident that the knowledge and partnership developed here will further strengthen dam safety best practices globally. Thank you all. Jai Hind, Jai Bharat.
Thank you very much, Shri Pradeep Kumar Agarwal, for those words of thanks. Well, ladies and gentlemen, it's now time to head back to our respective destinations safely and securely. But before that, please join us for high tea, enjoy your tea and coffee, and get back to your destinations safely and securely. We'd like to thank Honorable Minister Shri Somana and all the dignitaries. Thank you for being in Bengaluru, the IT city, BT city, the technological capital of India, and of course, the dam safety venue. Dhanyavadalu, namaskara. All of you, please take care.